Was born ready.
Good morning.
Good
How you all
morning,
doing?
everyone.
Day 3 of Cisco Live.
Yes, we're getting there. All right, well, thank you so much for joining us today. My name is Yasmeen Seddeek, and I am a junior technical advocate for Learn with Cisco.
And I am Kareem Iskander. I lead our technical advocacy group, and I'm a principal engineer with Learn with Cisco. And sorry about the feedback. So today you're here because you're after a certification, and so
There you go.
okay. I don't think you guys can hear me.
It's out. Goodness.
All right, today you're here because you're going to be, you're interested in a certification. And because it's in our contract to talk about AI like 500 times this week, so we tied certifications to AI and how it could help you study and guide you through. Just a couple of housekeeping items. We have a WebEx room for this session. We will make sure to share all of our slides, all of the work that we have, all of our slides and everything that we have. We will make sure, and the links to make sure that we'll put it in there for you. Yasmeen and I are going to be in that room. If you need guidance, if you need help, or if you have any questions that you need to help you with your certification journey, please don't hesitate to reach out to us. It's there until the room is available until June 13th. That's not really true because I still have rooms since 2015 of Cisco Live. So, we will be there after that as well.
Awesome.
All right. So we are put together this session to help you pass your certifications. And these are things that you probably asked yourself when you decided to go through a certification journey. Hey, I want to be able to, I learn through repetition, or maybe I'm more of the type of person that needs flashcards to remember things, or I like to learn better with hands-on. And so if you are in that position, this session is for you. And we walk you through a lot of things that help you answer these questions. And so we're going to start the session by talking about the importance of prompt engineering. It's an art in itself. And how to write a proper prompt is really important. And then, as you can see here, we're going to dive into every single bullet here with AI. So how AI could help you be your blueprint decoder. We're going to look into AI, leveraging AI for our study schedule. And then we're going to use AI as our study partner to keep us going. And then finally, help us practice by being the exam simulator. And then for those who are looking for the hands-on, we're going to see how we can leverage AI to build a lab architecture. Okay? So let's get going.
Yes. So firstly, we want to talk a little bit about why we're choosing AI for cert prep. So as we may all know, cert blueprints are dense, they can be long, they can be confusing, and knowing what to study is just half the battle. Some of us may feel, or our time might actually be limited, where we're balancing work, life, and on top of that, learning. We all might learn differently, different styles, might take us longer than others to remember the material, and maybe a generic study guide doesn't fit your brain and doesn't work for you in the way you study. So with AI, we can each personalize our own experience. We can take that one-size-fits-all blueprint and make it into our own blueprint, our own process. So I want you guys all to meet Alex. Alex is definitely not me. It's not me. I'm sure. She's not me, but she's early in her career. She's hesitant to start a journey in networking, and she feels overwhelmed by the idea of having to memorize so much. especially a large amount of content. She might be used to structure in the classroom, and also she wants to take advantage of NetAcad resources and Cisco U resources to make sure that she has all the knowledge before she takes her exam. So we're going to follow along on Alex's journey and see how Alex can help us understand how we can do better while studying for our exam. So first, as Kareem mentioned, we're just going to go into a quick FYI on the importance of prompt engineering. It's super important to keep this in mind. As we may know, we've probably all have our own experiences with an AI, different chatbots, and it's super important to kind of create your own experience. Unfortunately, it is a journey for each of us to kind of use the prompts and see how they work and see how they can work for us. We might not get the response we'd like on the first try. So with prompt engineering, as I mentioned, every prompt can be engineered to get the best possible result for you. So we want to make sure that we shape the right tone, the detail, and structure of the AI output before we receive it so we can limit the amount of mistakes made or confusion. So the best prompts, we want to make sure they include details, they set a role, they specify steps, so we can even write out, these are the 5 steps I want you to take. Include specific examples, that's my favorite thing to do. And also limit the output. So we say, I only want you to give me a page-long study guide. Don't write me more than a page or 5 pages. So for the purpose of today, every method with AI that we'll cover, we're going to be using the scope framework for prompting. So let's just go through each one, what each one stands for and what it means, so then we can use it. It's also great to just keep in mind when you're prompting in your day-to-day. So when it comes to situation, this is where we set the stage. We let the AI know, hey, I'm studying for a certification exam, I'm studying for the CCNA, or I'm studying for the CCST, and I need your help. The character, for me, I go straight towards, you're an IT certification coach, you know everything about certifications, I don't, and I need your help. Outcome, this is where we say, I want to be able to pass my exam, I want to be able to study correctly, more effectively, and that's where you're going to help me. And when it comes to purpose, here we can highlight, I want to pass my exam. This is my purpose. Once the AI knows your purpose, it'll be able to kind of keep that in mind no matter when it's answering you and no matter when you have a question. And when it comes to example, here's where we're going to specify the steps. We like to highlight, steps 1 through 5. This is a great way for the AI to figure out where to start and then go from there. Awesome. And then now we'll go into the first one, which is AI as your blueprint decoder. So as I mentioned, Cisco cert blueprints can be dense. We want to read and understand the exam topics. When it comes to Alex, she read the exam topics and she said, oh, I don't get this. Shut the laptop and walked away. But it's important to come back, to read it again, to be patient, and to ask the AI, hey, can you break this down for me? So we want to understand not only the topics, but we want to break down the percentage weight of each domain that's going to be on the exam, because that directly correlates to the amount of questions that you'll see on the exam, which is super important. You want to know what's the most important thing to study. Also, the AI is able to read between the lines. The verbs in the blueprint can connect directly to the phrasing of the questions on the exam and how they are written, so it's important to actually pay attention to the verbs and what they mean, especially when it comes to a hands-on exam. And how AI helps. It can take these topics and translate them into plain language. I know that helped me when I was getting ready to take the CCST. It was a great way to kind of understand, okay, what exactly does this mean? Also, it can help you highlight gaps in your knowledge. So once you read the plain language, you can go, oh, I have no idea what that means. I have no idea how data travels through a network. And now you don't know. So then you can learn it. And also, it's just a great starting point. That's what this is your starting point to get started. Now, let's go into prompt number 1. So as we mentioned, we'll be using the scope framework. So our situation today is that we're preparing for, let's say, the CCNA, and we have attached our blueprint with the prompt for the AI. And we highlight that our character is a certification coach with deep knowledge of Cisco certs. And also, we just want to make sure that your goal is to give me a structured, prioritized breakdown, so we're getting the most important topics at first. that we can immediately use to build our study plan. And also, let's just give our purpose. We want to focus our time on what's most important to pass the exam. I know it can feel hard if there's a lot of things we need to do and we don't feel like all of our attention is going towards studying. So this is where we get into the nitty-gritty. We get into the example, which is where we kind of highlight the word-by-word directions that we want to give the AI. So first we say, we want you to break down each domain and explain it to me in plain language, of course. And then, as we mentioned, highlight the weight of each domain, highlight the key verbs used, and identify which domains are most likely to be the most complex and you think might require more study time. And then from there, you can give me a recommended study order based on that prioritization on domain weight and complexity. So here is kind of your basic starting point. There's also a chance for you to be more specific, more detailed, if you want it to be in the form of, paragraph, or if you want it in table form. I work better when it's all lined out for me, so that was super helpful. And also for me, I was able to go through the blueprint and see, okay, I actually have a little bit more knowledge on some things, and that immediately brought me reassurance before I started studying. Okay, now let's get into AI as your study scheduler. So now we've given it the blueprint, we've given it our starting point, we want to continue, and now we really want to start studying. So I don't know about you guys, but Alex went into the CCST and just straight up winged it. She said, you know what, whatever happens, happens. I didn't study, but I want to see how the exam goes. And from there, you're able to study, but it is kind of common for maybe some of us to wing it. We might feel like we don't have enough time. We tend to lose track of our progress and maybe don't feel 110% confident in the things that we've learned. And also, we might feel like time is our biggest enemy. I know I sure feel like that. If, like I mentioned, we might be balancing a lot. We might feel like we don't have enough time. And also, with that, we can then have AI be our personal study manager. We can take off the load of that pressure from ourselves and now put it on the AI. It can build us a realistic study schedule. We can highlight when we want to take the exam, and then we can track that schedule, track what we've covered, and also just base the timeline based on how our life is going at the time and highlight our weak areas. So now that we've given the AI our blueprint, we're going to start with our inputs. We want to give our exam date, how many weeks or how many hours per week that we believe we'll be able to study, and also our current knowledge level. Now that you have all the topics lined up from your blueprint, you'll be able to identify, okay, I'm confident in this area, I'm not confident at all in another area. And also, I love the instant gratification of checking something off of a list. So with this, you'll have that satisfaction, and you'll be able to move on to the next thing and go from there. So for prompt number 2, we want to set up our situation. Again, we're just highlighting that we're studying for an exam, and we want to take our exam on this date, and we have this many hours to study per week. And also, don't forget that I've attached my blueprint below. Maybe you're working on a project within Claude, so Claude will remember your blueprint. If not, you can attach your blueprint again. You can even attach your amended blueprint that you've already created. Then, set up the same character. We want to make sure you have a deep knowledge of Cisco exams before we move forward. And now we want to create a realistic week-by-week personalized study schedule that maps every section of the blueprint to each domain, therefore to each section of my calendar. We want to stay organized, make consistent progress, and walk into exam day fully prepared and fully confident. So going into details about this prompt, we want to make sure that we're estimating how many study hours that each domain might require. And we also want to map each one to a specific week in our schedule. I myself, going through this, using this prompt, I was able to get a schedule, and then I realized, okay, I might need a few more weeks for this section, and I said, create me an amended schedule that reflects that I need more time for this. And that was very helpful, because sometimes the initial response might not be exactly what you're looking for. Then, something really great is to build in time for review and study sessions. You might think, oh, okay, I'll just study until the day before my exam. But what we need is review, time, and then we need to rest and relax and let our brains quiet before we go and then take the exam. And we just want to highlight and make sure to limit the output by saying, give me a clean week-by-week table with estimated, with topics, estimated number of hours, and goals per session. Having a constant goal to work towards every single day is a great way to feel that gratification. And so something I thought would be very interesting to keep in mind is to update said schedule. By updating, you'll be able to, update it on what you're doing, and then you'll be able to get the things checked off the list more and more. And so we had the idea of just giving an update after each study session. Say I studied for these many hours today, I covered these topics, and you can even go ahead and say, hey, I'm super confident in it now. Or you can say, even though I studied for 5 hours, I don't feel confident at all, but noted that I spent this time. But remember that next time I come back and study, I want to review the same topic again and again. Remember what you think I should revisit based on this feedback, and then tell me what I should focus on in my next session. This is so every time you finish studying, it's updated. Because if a few weeks pass, you've studied a few things, but then your tracker thinks that you're still on week 1, you might be confused, you might just throw it all out and just go on your own way, but it's important to keep it going and keep the track going for yourself. Alrighty. And now going into AI as your study partner. So now that we've given in all the background information, this is where we get into the actual studying part. So this is where we want to make sure the information is open for us, clear to us, and ready for us to study. So when it comes to Alex, when she reads things off of a page, she just reads them. She doesn't remember them. You're just reading. You might feel, happy. Hey, I read this page 3 times. That means I'm going to remember it. That might not be what happens for you. Maybe it is, but for a lot of us, it's not. So it is better to retrieve, apply, and engage with material. We want to make sure we're engaging it with multiple times, so then it sticks in our brains. It will then force our brain to build stronger memory connections. Say, hey, I remember that one day I was studying this, and this is how I remember, is because I literally used my hands to write it down, or I engaged with a memorization table, things like that. And with most of these exams, you're being tested on application. So you'll be needing to use your hands, you'll be needing to troubleshoot, and make decisions under pressure. So when you're able to engage your brain and get into that active learning stage, it'll be very helpful for you. So how can we do this with AI? Sometimes when you're using AI, it gives you all the information, you just read it off the page, and maybe you don't indulge with it. So AI never gets tired or overwhelmed. I know I sure do. I get tired of looking at a computer screen. I get tired of, trying to memorize things, and in this day and age, sometimes I feel like I just don't have the space to remember things. And so with AI, we don't have to worry about that. And so at this stage, we've given the AI our blueprint, but now we want to feed it our learning content. So this will take the form of maybe your own study guide that you've created, different learning material that you've accumulated, things like that. And this is where you'll be able to use this, because we'll be using that learning content to actually study. Then you can choose your tool, and AI will build it. I'll get in deeper about what we mean by tools, but it's really important here to highlight that this process, or this is the chance to make your process fit to you and make it work for you and make it specific to you. Even with the prompt I'll show today, I think it's important to change it to fit your size and what works for you. So that's super important to keep in mind. There's different ways to personalize and customize it for yourself. So going back into our situation, we're preparing, let's say, for the CCNA. And this time, instead of the exam blueprint, I've pasted the following learning material. For me, I went in and I asked the AI, hey, I'm studying for the CCNA, and I actually created my own study guide that I asked another AI to create for me, and I'm just pasting it here so you can use it. You can also give the AI a chance to scour the internet and see if it can find you any study material. any like actual written material that you can use. I personally like to know what's in my study material before I give it to the AI, so I went ahead and made sure, okay, this maps up to the topics that are on my exam. And we're going ahead with the same character here, but here our outcome is to transform this new content that I'm giving you and make it into an active study tool that I can immediately use to strengthen my study skills and my retention of this material. And here, we can just be honest with the AI and say, honestly, I want to stop being passive when I learn. I want to be active when I learn. I want to actively engage so I can recall and hopefully pass my exam. Awesome. So here we have a couple of options. We first want to make sure the AI can identify key concepts and terms and processes that we're highlighting to it, which is most important before we can move on and actually study. So our options are our tools, I should say, are you can build me a set of flashcards with questions on one side and answers on the other. And here we can go into detail. You can give me flashcards about this topic. You can give me 5 flashcards, give me 10, give me 50 about all the topics on the CCNA. That's one idea. Another one is a mnemonic to help you remember a specific concept or sequence. I know that was helping Alex when she was studying for the CCST exam. Felt impossible to remember the layers of the OSI model, all the names and the details and the port numbers and all these things. So with the mnemonic, she was able to go into exam day, get that piece of paper, write down exactly everything she knows about the OSI model. So that's a great way to remember things. I don't like memorization, but it's easier for me to remember things like this.
And you're still sure Alex is not you?
And I'm still sure Alex is not me. Yes, it's just an example for everyone else. Yeah, of course. And lastly, a tool option we have is a memorization table that can compare 1 or 2 concepts if you'd like, or it can just give you, for instance, a list of different subnet mask notations, so you could just read them off the list and have it there ready for yourself. I know for me, it's great as like a quick cheat sheet to just go back to and look at it. So that's an example, or if you want to, let's say, learn more about the different layers of the OSI model, it can create that table for you. And also, we want to make sure to highlight that we want to limit our output to just the most exam relevant content only, because there's a chance that maybe something in your study guide or your learning content, that you've provided might not be super important to what you're trying to learn. And again, remind it we want it to be clean and easy format. That's very important to mention, just because if not, the AI could give us something that we're not looking for at all, and then we're back at square one. And now we'll go into AI as your exam simulator. So now you've studied, you've put in countless hours, minutes, days, tears, blood, sweat into studying, and now you want to, feel more confident that you'll be able to go into exam day and pass your exam. So you might go out on the internet and find all the different possible or available exams that are out there regarding your exam. You might have taken all the CCNA practice exams out there, but you might still feel like you want to do more before you get to the exam. You might feel like you haven't answered enough questions on a specific topic, and you want to learn more. So now we've highlighted that practice exams have limits, but AI can create you unlimited, tailored questions based on what you need. With already having your blueprint, the AI can now mirror the depth mirror the depth and the style of the real exam. Losing my voice. I apologize. Just leaving me. But yeah, the AI can now mirror the depth of the exam. It can keep in mind the verbiage used in the blueprint. I'm sorry.
You're good.
But first, we want to keep in mind that AI is not perfect. We can go ahead and ask the AI, how confident are you in the accuracy of your answers? Sorry. We can also ask the AI to cross-reference, or you can cross-reference yourself. You can validate the answers yourself against your input going into it and checking out the learning content when you're confused. I love to use control find and see, was this even mentioned in the learning content that I provided you? I feel like I've never heard of this. Sometimes it ended up where I just didn't study something. Sometimes it ended up where I just didn't end up studying something, and so I need to go back to square one on that topic and learn more about it. And this is a great way to, again, engage in the content. Oh, thank you. Just a quick sip. So, kind of just highlighting that same thing about keeping an active relationship. And lastly, we can ask the AI to cite its reasoning. Tell me where in my learning content did you find this information? Alex had an experience where she was trying to recognize different subnet mask notations, but every answer was the incorrect answer in a multiple choice question. And you're like, wait, this is wrong. I must just not know anything. I must just not be ready for this exam. Then she went ahead and asked the AI, are you sure A, B, or C is the right answer? And the AI responds, you're so right. This is wrong. And you're like, oh, okay, so I'm not crazy. I got it. Ask me the question again, but this time, use my learning material and be confident in your response. It doesn't hurt to ask a follow-up question. Now, going into the prompt for this, we're going to, again, say we're studying for our exam, and this time we've attached our learning material and the exam blueprint. It doesn't hurt in this instance, just to give it more information. And again, you are my certification coach. And I also wanted to highlight here that it's a great chance to ask the cert coach to be familiar with the type of scenarios that come up on the exam. So it's maybe easy to say just have a knowledge, but it's a different level to have a deep knowledge on the scenarios that you'll see on the exam. And next, highlight our outcome. We want to go through and highlight the gaps in our knowledge. This is a great place where you can then engage with the AI and say, hey, remember that I don't understand this a lot, or super well, sorry. And then maybe you can create me a mini study guide to help myself remember. Again, we're just highlighting our purpose is to feel prepared on exam day. And we want to make sure to figure out our weakest areas so we can get better at them. And now, for this prompt, we'll go ahead and say that we're going to start testing ourselves. We want to focus our questions on this list of domains and these topics. I like to be specific and say the exact topics that I like to be tested on. And then after I've taken a couple of quizzes, I'll then ask the AI, okay, now that I've taken a couple of quizzes, can you test me on a general knowledge for the CCNA, for example? So for this purpose of this prompt, but you can, of course, customize for yourself, we'll say, generate me 5 multiple choice questions with 4 answer options each. And after I answer each question, then provide me with the answer and the reason for why I was incorrect or why I was correct. When Alex first tried to test her knowledge, the AI actually provided the answers within the question. So number 1, highlighted the question, and then options A through D, but then right under it says the correct answer is C. So she had no chance to give her answer before she read it off the page. So it can be important to highlight, hey, don't tell me the answer until I gave you my answer. And then, once you give me my answer, tell me why I was wrong or why I was correct. Don't just tell me I was right and move on. Again, reminding the AI to mirror the complexity of the real exam. And then, depending on my answer, flag any topics where my answer suggests I need more help and I need to study more. This is a great opportunity to kind of go through different topics and get very specific. When you get to the exam, maybe you'll end up only having one question on said topic, but it's super important to kind of build your skill. And then when you get to exam day, you'll just be like, hey, I know the answer. And for me, I get a lot of testing anxiety, so when I go to the exam, I'm already so worried about the logistics. Am I in the right place? Am I here on time? And so having this to be able to practice the questions takes away the fear of, hey, What if this question is written in a language I don't understand? What if it's written in a style that is unfamiliar to me and I've never heard of? So it's super important to use this, to leverage this. It's not a, you do it once, it's a you do it multiple times, and it'll help you. This is definitely a starting point for you to then take it and apply it for yourself.
The one, excuse me, the one thing that you can also do as part of the prompt that Yasmeen just went over is to get comfortable with the platform that you're going to see when you sit in front of an exam laptop computer, is to actually ask AI to build you the sample test in the format of a Pearson view. And it's going to generate you an HTML page, and you can ask it to even further go with time it for me. You know, you're taking a CCNA. It's 120 minutes, I want to say. So you can time yourself as you're doing the certification exam. And you can even go further as you progress throughout your professional and your expert level certifications. You can start asking it to generate lablets for you. And this is something that becomes really, really useful for us, especially with the more hands-on that we need in order to pass some of the certification exams, is being able to generate lablets. But that lablets is typically connected to hardware, typically connected to devices. And so we need a way to do that, and luckily we have access to CML free. And with CML free, you get 5 nodes that you could start building with to practice. Now, that's great, but we're trying to focus on the certification exam itself. And the last thing we really want to do is start spending time on configuring our labs in order to start practicing. And so we can actually use AI to help us build lab topologies. So we can just dive into the labs based on the blueprint and based on the exam topics, so we can start getting that hands-on practice. Which means you can generate hands-on labs in the form of CML labs. CML itself, CML free, comes built in with something called MCP. Anybody familiar with MCP? So MCP is a way for AI to exposes tools or APIs from different devices, from different tools, from different dashboards, from different components that allows the AI to take actions on these components. Okay, that at very minimum. I have a session at 11 in the DevNet zone right after this, talking all about MCP. So if you're interested, join me. But we can then use that to prompt the AI to do something very similar. Again, situation, I am a CCNA, CCNP candidate. I'm trying to build a lab topology in order for me to get hands-on practice. You are the expert Cisco networking engineer and a CCNA lab instructor. That's your character. And then you're given the outcome. Your goal is to create for me a lab that's attached to everything that we've been talking about, including the blueprint, including the learning content that I've given you. And I want you to simulate that as if it was on the exam for me. And the purpose is I want to practice real exam scenarios, which you will see lablets as you progress through your certification journey. Now, the actual prompt is, we have to define it, because at this point we're asking the AI to take action on our behalf. So we're moving into agentic AI at that level. And so a couple of things that we want to do. Create a hands-on lab task based on the blueprint. So I don't have to go define which ones. The AI understands the verbs from the blueprint, which means at the specific verb level, you'd be expecting either a lablet or a hands-on code or something, a drag and drop. So the AI is going to identify that for you based on the blueprint. Only have one task at most. That could change to whatever you want, but typically on the certification exams, you're doing either 1 or 2 tasks max, right, per lablet. So you kind of want to have it follow that. You can get as deep and complex as you want by changing a couple of sentences in these prompts. And then one thing that you should be aware of when we are talking about CML free, because not all of us have access to CML Enterprise or a license to CML. So we want to make sure that this is super easy to get started with. So you have the free version. You want to define the nodes that CML allows you to spin up at a free license. And so if you look at bullet 4 here, I'm defining the actual CML free versions so I could tell the AI when you go in and you start creating these labs, these are the only devices that I want you to spin up because that's all you have access to. And then you also want to define it at most 5 because, again, these are the regulations of a free license. You can only spin up 5 nodes at the same time. And then further, because it knows the lab that it's going to create and it's spinning up devices that you've told it to spin, you can now have it build the hands-on task itself within the lab nodes in CML. So now you can log into CML. You have AI-created labs, you have the lab notes, and your tasks are what you want to do, and you can start getting that hands-on exercise and hands-on muscle memory for your certification exam. Now, if we can even dig deeper for this because we're going in and to configure devices for CCNA, right? But how are we supposed to know if we've done it right or wrong? We can tell by if we've made a connection or not so sure. We can know that we've done a task like this. But we can go further and say, once I've completed the tasks, I'm going to tell you to go grade what I've done. So the AI is going to go and dive into the configurations of these devices. It knows what the answers are because it created the lab for us. So it's going to go look at your configuration, read that configuration from each device, come back and say, yeah, you've done this right or you've done this incorrect. And then you can further prompt it using chain prompting to say, okay, so the things that I've gotten incorrect, which blueprint items do they attach to? And clearly I need more exercises on it. Can you generate more labs on the things that I'm weak on? And it's going to go spin up another lab that you can start practicing in. So you can see how cool AI could be as our sidekick for getting past that certification. And so some of the prompts that, all of the prompts actually that we talked about today, we made them available on a GitHub repo for you, so you don't have to recreate anything. We'll make sure to share that with you in our WebEx space. We'll show you, we'll dive into some prompts right now. I'll start with my prompt for CML that we just talked about before I hand it over to Yasmeen. But if you look at it, this is what it looks like. So this is the prompt we just went through. I have Claude here using, and I'm using Claude to talk to my CML instance. And I told it, go create the CML lab for me, one task at once. On the right-hand side, this is CML free. You can see here that I'm not doing anything. This is AI building the topology for me. And you can see it dropping 5 devices, because those were the regulations and the primitives that we told AI. And it's making the connections and starting to spin up the devices for me. And it's also, what it's also doing is, it's building each device with the base configs that I need in order for me to start SSHing into the device and start building maybe VLANs, maybe configuring ACLs, whatever it is that task is asking me to do. It so happens for this, it's asking me to do multi-VLAN configuration. And once I have that, now I have access and it gives me credentials to the devices, and I can switch over to the notes section after it starts. I think this is just going on a loop now. But I can go into the notes section after it starts, and I can start doing my exercise and getting that hands-on. So you can see how really cool this is. This entire getting started with this, including the prompt and how to build out something very similar and connect your AI to CML. I have a write-up on it as well in a blog post. I'll make sure to share that with you all so you can actually spin it on your own laptop when you get back, okay?
Hello? Okay, I'm back. Now I'm just going to go into a quick demo on kind of showing you the examples while I use the AI.
Yes. I'm sorry, I didn't hear. Oh no, this is just an image that's going to show you guys. It's just a GIF, nothing more. When the task is done, it's gonna stop. Yeah. It's not burning tokens forever. Don't worry.
Okay, sorry. I'm going the wrong way.
You just want to spin up a cloud, right?
Yeah. Okay, here we are. So, we're just gonna quickly, oh, it's not showing my screen. It's not showing my demo.
Command P. We don't have Windows.
I can just put it on the other desktop.
AV is not in our favor in this session. By the way, while Yasmeen does this, so you know, this is her very first Cisco Live session and theater session ever. So she did an amazing job.
Thank you. The main desktop one. It won't switch me. Here we go. I think I know what to do.
Oh, I bet it's extended.
And then we go back to Claude. Okay, I figured it out. So we're just gonna go quickly through some examples. I wanted to actually show you guys how I asked Claude to give my exam blueprint breakdown. So here I just set up the relationship. I said, hi, my name is Yasmeen. I'm studying for the CCNA. Will you be able to give me answers to the prompts I give? I will give you each necessary step. So here's where I pasted the prompt and I made it customized to myself. And this is the breakdown that I received back. So I see that network fundamentals is 20% of the exam, and that I should actually study it second, but that I should actually study IP connectivity first. It's 25% of the exam. I'll see it multiple times throughout the exam, so maybe I should focus all my effort towards that to begin with. Also, this is a great place to read the different verbs, and also for me, I might have went up and searched their definitions to see, okay, what does this really mean? Yes, I know what the word interpret means, but how does that apply to taking an exam? So that was super helpful for me as well. And then also here it highlighted the complexity of said section. And at first I was like, oh, this is kind of freaking me out, but it actually exposed me to topics that I wasn't even aware were on the exam. So I wrote them down, hey, I don't know this, and I can come back to it later. And then we want to go quickly into the exam question practice. So here I asked for 5 questions on how data moves through a network. So I received 5 pretty basic questions. I provided my answers, and then it told me why the other 3 options were incorrect. This is a great way to be able to identify the wrong answers on the exam. Then here it tells me, okay, when it comes to unknown unicast flooding, you have a pretty good understanding. And also a great thing to do is after you then take this quiz, go back to your study scheduler and say, hey, I actually understand this pretty well. Can you update my tracker to reflect that I understand this topic? And then here I had Claude give me 20 questions, general questions from my provided learning content that didn't follow one certain topic. And I think we'll just go quickly to our study tools. Here, it gave me a subnetting block size memorization table, and it actually provided me a markdown file that I could open on my, what is it called? On like Google Chrome or Safari, and I was able to see it there, and it was browser, and it was highlighted for me, and I could just come back and memorize it. And also great practice for me is to go ahead and write it down for better memorization as well.
All right, so everything that we have for you here, like I said, we'll share it. If you're interested in learning about how we were able to learn all of this with AI, we have a certification for you called AI Tech with training, if you haven't heard of it. It helps you understand prompt engineering. It helps you understand how you can leverage AI in your day-to-day in general. It's one of our newest certifications here. We also have a set of tutorials that we wrote to get you started. Tutorials are free on Cisco U. And so if you are a beginner with AI and you're trying to leverage a lot of that, we have tutorials from entry to expert that walk you step by step with AI. And then finally, if you need help or if you want to learn more or you want to talk to us, feel free to reach out to me and Yasmeen. Our contacts are here. Connect with us on LinkedIn. A lot of the things that I talked about from MCP and connecting your devices are in a blog post format in my blog channel. You can feel free to just go there, read it. We will make sure, regardless, to share the links that are relevant to this session. And just don't forget to do your survey. Your feedback is really important to us. Positive, negative, that's how Cisco Live tells us to rerun these sessions. So I just want to make sure that we hear from you and we hear how amazingly Yasmeen did on her first session. So thank you all for your time. Enjoy Cisco Live and reach out to us. Thank you.
Thank you so much.
Okay, 3, 2, 1. All right. Hello, everybody. Thank you for being here at this Cisco U session. My name is Alfonso, and I'm a developer advocate at Cisco.net. And today, I want to share with you a very special kind of MCP server. You must have heard about the MCP technology at this point. There's plenty of servers out there. It's a pretty interesting technology. However, what I want to share with you today is how to put it to super practical use with your RADKit services so that you can deploy this next week, Monday morning, and start using it right away for your networking housekeeping. So this is your network now conversational, unlocking RADKit with the official MCP server. Okay? So just let me... Just give me 1 second. My clicker is not working. Yeah, there we go. Okay, so please, for those who just joined, if you could join my Slido, because I want to get to know you better later on in this session. Okay, so please do. And, well, I'll jump to the next part. You know the drill, right? You know the drill about our WebEx space, our WebEx chat. I take it personally super seriously. So please, if you could join after this session, I will be more than happy to help you out with any use cases, any questions, any doubts that you may have. I'm going to keep an eye on it. I take it super, super seriously. About this session, the things that we can expect, we're going to do a super deep dive into the official MCP server for RADKit. We're going to have a look at all its different capabilities, all its different features, and we're going to be building our very own agent so that we can use it along with other trinkets for very interesting networking housekeeping tasks. We won't go deeper into RADKit per se, into the RADKit inventory. There's many other sessions for that, and if you're curious about it, you can ask me later. I will be more than happy to share information with you. So now a little bit about me. Who is this guy in front of you? I'm a developer advocate, DevNet. I'm based in Lisbon, Portugal. Here's my LinkedIn, here's my GitHub, and I love to share this picture. We do this activity, this pilgrimage it's called the Camino de Santiago. We walk all the way to Spain, and it's a super cool activity. I had a lot of fun with my colleagues at Cisco. So, agenda being, RADKit at a glance. I want all of us to be on the same page regarding the RADKit platform. Then we'll have a look at MCP protocol. In case some of you are not that familiar with what this protocol is about, we're going to be all on the same page. Then a use case, which is my first agent, using a platform open source called LibreChat, along with some other toys. So we can have some very interesting housekeeping activities here. Wrap it up with a demo, some key takeaways, and resources. So now, this is the moment when I want you to help me. I want you to know how aware are you with RADKit. So the question is very simple here in this Slido. Right now, and then please fill in the blanks. Maybe you have heard of RADKit somewhere, thank you. Maybe you use it mostly for tag assistance, right? You do some basic housekeeping with it, maybe some like a source of truth, inventory management, all that stuff. Maybe you do network automation with it, that would be super cool. Or you know nothing about RADKit and you showed up just to know what is it all about, okay? So yeah, thank you. Okay, mostly for tag, you've heard about it. Know nothing, okay, I like that. I hope that I convince you to have a look at it at the end of the session, whoever you are here in my audience. All right, okay, I think we can stop it there. Thank you for giving me your answers. So RADKit, yes, you might have heard about it when it comes to tag assistance. When you raise a new tag case, you are requested optionally for a service ID. Because mostly it is used in tag for remote assistance. That means that your tag engineer can go to your devices completely remotely, do what this person needs to do to troubleshoot and get your case solved. However, it's so much more. There's so much more that we can do with Cisco RADKit. It's basically an automation powerhouse, super secure, single point of contact for all your different devices in the inventory. We have a web UI. We also have an API first access and a collection of SDKs and tools that we can use for turning this into an automation powerhouse. I like to call RADKit as one of Cisco's best hidden secrets when it comes to network automation. It goes way beyond tag assistance. And let me show you why. How RADKit works is that you have your network. This is sitting in your own premises, multi-vendor, multi-protocol, multi-everything. And then what we will do is to deploy a very small RADKit service somewhere there. It's quiet, it's hidden, it is there. It could be a virtual machine, it could be a container. There's many different ways to deploy it as close as possible to your network. So then what happens next? Outside of your network, we have a RADKit client. This could be your tag engineer. This could be even yourselves that you want to query your devices. You want to do some basic operations. You can use the client console. You can use the web UI, or you can use the Python SDK to go full on with coding. So then what happens now? We have the RADKit cloud in the middle. This is a secure access that will allow us to go as clients into your RADKit service and then into your network. Everything is authenticated, and it all comes to a service ID and then a remote user. This remote user will use our different SDKs. We have one for client, control, and access. And then it will authenticate via SSO login using the RADKit cloud. It could be either this, or we could have a direct connectivity via RPCs. We can also have security certificates for the login. We have different ways of bringing this person to that service. But once that happens, we are able to connect using any given protocol to your network and then get all sorts of information that we need. That could be, the configurations of my devices, my device inventory. I can be uploading, downloading files. I can do many different things. How this looks, let me show you. I have here my RADKit service. Just let me put it here. Oh, sorry. Let me go back to my slides and cancel that. And now you can see. Yeah, this is how it looks, the web UI. We have different devices. This could be multi-vendor, multi-protocol. We can have RBAC. We can have remote users, tags. We have many different things here. We have the exact same experience via console and also via the Python SDKs. Okay, so now that we are all on the same page regarding RADKit, I want to shift gears here a little bit and go into the MCP protocol. It is fondly called in the universe of AI as the USB-C port for our LLMs. So it so happens that before this protocol developed by Anthropic, if we wanted to use tools within our LLM systems, such as our calendars, our database, our emails, we we will need to provide the documentation of those APIs to our LLMs. And that meant that we needed to train our LLMs a little bit. We needed to give them lots and lots of context. And that it's not as reliable as it sounds. We would still have there some hallucinations. It wouldn't be precise, right? If you wanted our LLM to handle our databases, emails, calendars, and so far and so forth. So then what happens with this protocol, MCP, Model Context Protocol, is that we have this funneling that will standardizes this context that these different tools will provide to our favorite LLM. And this happens in the following way. We will be deploying MCP servers for each and every one of the tools that we want to have access through our LLM. In this case, we have an MCP server for our database, one for our email service, one for our calendar. These servers are made up of tools. We have different tools here. And first of all, when these are deployed, we will have this transport. It could be STDIO, SSC, HTTP, talking to our LLM. This LLM could be anything, right? Could be, I don't know, like a Claude model, like a GPT, whatever that may be. It doesn't matter, actually. Then, once this transport is established, each and every one of these servers is going to announce its collection of tools. So in this case, my database service is saying, hey, Mr. LLM, this is me, nice to meet you. I'm a database MCP server. This is the tool that you use to create records. This is the tool that you use for reading records, and so far and so forth. And once that's done, my LLM has enough context to know how to wisely and appropriately operate all these different tools within our different servers. In a nutshell, that's how it works. But well, here we're not going to talk about databases, emails, calendars. We're here to talk about network automation. That's what we are looking for today. So typically, MCP servers in the world of networking, they function in this fashion. So first of all, we have that discovery part, when we have all these different servers deployed, and then our LLM picks them up, the transport, picks the context, now it knows what to use and how to use it. Then we have the intent, the high-level intent. This can come from a user, this can come from a prompt, this can come from any given high-level input, right? Could you please tell me what's the status of my interfaces in this set of devices? Could you please set up a new VLAN? Could you please do some of this basic housekeeping? Okay, good. I can do that. Then comes the reasoning part. This reasoning part is split into two. The first one is the things that I need to do as an LLM to bring those queries into your devices. And let me tell you, like as of now, straight off the bat, modern LLMs are super good at doing this. They do it very reliably because they've been trained with real-life network configurations. I'm talking about CLI or NetConf or RESTConf for the most popular vendors out there, not just Cisco. So we can rely on having a good judgment. Of course, we always need some expert eyes on that, right? But well, the LLM knows what to do, knows which MCP calls to use, MCP tools to use, and then it will invoke those tools. What's going to happen? We're going to be connecting to our real devices to get real data. We bring that back to the LLM in a raw format. We crunch that data, and then we present something nice to the user. And then we, for all of this, we're going to have our Cisco RADKit MCP server sitting there. That's going to be our interface in between our LLM, Agentic, whatever, and our real-life devices, multi-vendor, multi-protocol, multi-everything. So having said that, by the way, right as of now, it's very easy to create your own MCP server. I invite you to have a look at that, actually. It's super easy to do it with Python, for example. There are a couple of Python libraries that allow you to bootstrap all of this and create your existing functions, your existing API calls, turn them into MCP tools. The most popular library out there for this is called FastMCP. And if you look right now for MCP servers of Cisco tools and whatnot, you're going to find a lot of open source, a lot of community-driven MCP servers. It's a pretty interesting ecosystem. However, at the RADKit business unit, what happened is that an official one was created. And it's got a pretty interesting twist that I personally have never seen in any other MCP server. And I'm going to tell you what this fuss is all about. So we have there our LLM, Claude, GPT, whatever, our MCP server connected to our network inventory. This could be, we have a remote user, we have a service ID. In between, we have all sorts of authentication, SSO, certificates, a direct one via RPCs, you name it, okay? Then we have one tool, and one tool only. We are letting our MCP server of RADKit create code. Our RADKit server is coding live to fulfill our intents, to make our wishes come true. And this coding, it's Python coding that makes full use of the client API. And let me tell you why. Before all this was released, I designed with a couple of colleagues an unofficial, a community-driven MCP server. And we have one tool per thing. We have one tool for fetching the inventory, one tool for pushing configurations, one tool for SNMP. It was like one tool, one tool, one tool, one tool, right? We had, I don't know, like 6 or 7 different tools. If you multiply that for all the other MCP servers that my LLM would be using, that is a lot of tools. And ideally, we don't want that because it's more likely for our LLM to hesitate and to even fail when trying to pick the appropriate tool. And nowadays, the LLMs that are good at coding, they can manage this sort of logic pretty well and make use of the whole client API that we have for RADKit to squeeze as much as possible of our RADKit service. This will make a lot of sense when I show you some live examples. But before jumping into that, there's more than that. There's more than this live coding. We can actually expand the behavior of our MCP server by using custom prompts and custom scripts. This is straight off the bat. This is as soon as we deploy this MCP server, we can change how it generates the code in this small window. And also, we can expand its capabilities using Python. This will make a lot of sense when I show you a real-life example, but it's a very powerful feature that I personally have never seen before in any of the MCP servers out there. So that's enough chit-chat. I want to show you a very quick demo of onboarding this MCP server into the LibreChat platform. So before jumping into this, has anybody here worked with LibreChat? Perhaps, does anybody know about it? Nice. Honestly, I was not expecting a lot of people to know about it. It's a very interesting open source tool. Let me show you how it looks like. So let me close this. In LibreChat, oh, sorry. I always forget that I have to close my presentation. All right, now you can see my browser. Awesome. LibreChat is an open source ChatOps platform. We can deploy it as a Docker Compose. We can deploy it in many different ways. And it's pretty cool, actually. We can customize whatever we want. We can add MCP servers. We can add agents, all that stuff. So before jumping here, I want to share with you how we deploy our MCP server. We start with a JSON like this. We're basically saying, hey, which kind of connectivity I want to my RADKit, what's my remote username, what's my password, what's my host, and what's my port. Now, about the extension of capabilities that I shared with you before, I'm going to use 2 files here, a prompt and a Python script. This prompt will let know my MCP server how to generate this code. I'm giving it some very light guidance here. I'm telling it, hey, use this function, get access mode, to know if you're deployed as read-only or as full configuration mode. Summarize, well, use this function, filter things so we can push 100,000 commands into 100,000 devices at the same time. The API allows us to do that with the filter function, and not much else, right? Like, these are some very light guardrails for our MCP server. Now we have this Python script. This is a profile. Basically, what I'm telling it is this. This is very light, very simple Python code. You can do it, with your favorite LLM, bytecoding, whatever that may be. here we're saying, hey, if this MCP server is deployed as show only, you are going to be dropping all the conf and debug parameters here, right? Like we want to forbid the user from changing any sorts of configurations. This is guardrails. This is guardrails straight off the bat because we want this to be executed as secure or non-secure. And then if it is not show mode, you can do whatever you want. Conf-t, shutdown, whatever that is, okay? So the way we deploy this is, let me show you. Here, yeah. We're going to be using these commands here. We're specifying the path to my JSON file, the path to my prompt, the path to my profile, my port, where I'm listening, Easy as that, okay? So let me go here, let me clear this, and give it a go, okay. Let's wait a little bit. Before coming to this session, I pray to the gods of the live demos. I hope that they give me their blessing today. Let's see how this goes. Because you know, like live demos can smell fear, so I hope that this is not the case this time. I will start here, first of all, by setting my LLM key. I'm using, in this case, Claude. I have my Anthropic token. I set it up already, so now I will create a new MCP server. It's going to be Cisco U RADKit MCP. I will put here the URL. It's a HTTPS mode. I trust it. Let's create this. Let's plug it in, okay. And then here I am selecting it. So I'm going to go and say, hey there, which are the devices in my inventory? There we go, okay. So then let's wait a little bit. Let's see what happens. What my LLM is doing right now is that it is already aware of the MCP servers available. No context from my end, no previous training from my end. It already knows what to do because it has the MCP already in contact with it, so it has enough context to know which tools to use. So here, what happened is that it, you can see here, whoop, yeah, here. Awesome. Let me go here a little bit. I think you can see it, right? I think it's clear enough here that this is Python. This is actually Python code generated by my MCP server using the RADKit client API. I got the code, I executed it, and I got my device inventory. These are all the devices. This is happening right here, right now. This is not a hallucination. This is not, something strange. And my MCP server is executed in show-only mode. If I wanted to configure something, it would reject it straight off the bat. Okay? But now let's crank up the volume a little bit. And I want to share with you an actual use case that you can deploy tomorrow morning in your RADKit if you want. We are going to be creating an agent on LibreChat. We are going to be putting the MCP server of RADKit, but also we will let it play with other small trinkets. You will see how this looks in the end. This is the architecture of my agent based on LibreChat. We will have there a custom prompt so that we can guide the behavior of this agent. It will be plugged to not only one, not two, but 3 different MCP servers. The RADKit one, of course. Then we will have the GitHub one for being able to pull things from our repository, being able to push reports, create issues, and many, many different things. And then the last one, MCP for Draw.io, so we can generate on the fly different diagrams, topology diagrams, network diagrams, whatever you need, right? And then, well, we have our LLM, our service, our repository. Everything is going to be based on Docker Compose. All of this is nothing but a fancy container. Now, about our agent definition, this is going to be an empty file that we will load into our LibreChat interface. And this is how I will be guiding the behavior of this agent. An agent is a very mysterious word for nothing but an entity that has a bit of a personality and has access to an LLM and different tools. In this case, this is a personality that I am giving to my agent in LibreChat. I want you to communicate with the user in this specific way. I want you to query and present data in this other specific way. When you apply changes, I want you to first and foremost check if there is no overlapping, if there is no conflict in the changes that the user wants to do. If there are, I want you to stop. And I want you to present this reasoning and why you think it's going to be conflicting to the user. If it's A-okay, if you give me a thumbs up, that this is safe, I want you to ask for permission of the user, ask confirmation to push things. I don't want you to just push things the moment you're told to. I want you to have a specific, yes, please commit this thing before going down into the device. And then I want you to save reports on a specific repository. I want you to create issues on a specific repository. And I want you to show diagrams in mermaid language straight off the bat when you're asked for diagram stuff. Okay? This is the persona that I'm giving to my agent in Libre Chat. So enough talking. Let me go back to the code. Let's roll up our sleeves a little bit and get into it. So first things first, let me open my repository here. I have provided, well, by the way, this is a repository, public repository, a RADKit NetOps agent. I will give to you the link once we wrap up the session, and I encourage you to have a look at it. It's super well documented. We have an environment file here. It does this .env file. Here I'm going to be putting all the specific information about my different MCP servers. What's the host? What's the port? Also the execution mode of my RADKit MCP server. In this case, I'm going to put full. You can configure, you can read, you can do whatever you want. Then my profile, my prompt, my JSON file, and then I'm going to do some other things for my GitHub, and that's pretty much it, right? A token to be able to push things into my repository, reports, issues, whatever that may be. Okay? Cool. Now I have a Docker Compose here. I want to ask you, by the way, has somebody here worked with Docker Compose or with containers in general? Like on a day-to-day basis, more or less? Yes? No? Okay, that's cool. Before this session, I learned that you can use environment variables in your Docker Compose. I was completely unaware of that, and I mean, that's super cool. 3 services, folks. 3 services here. We have 1 service for my RADKit. We have 1 service for my GitHub, 1 service for my Draw.io. I am encapsulating these MCP servers into containers. I have my Docker file. I have all my stuff in there, so they can be containers with their specific URLs, and we can bring them into Libre Chat, okay? And it's super simple. I mean, I just go and say, let me get my terminal. I'm just going to go and say Docker Compose opd. Whoop, sorry. I have there my virtual environment. Don't mind it. We don't need it. The Compose opd. There we go. The 3 of them are running. So let's go to our Libre Chat. If you go here, I already set them up. So you can see here that I have my URL. It's HTTPS. For the Draw.io one, exact same thing. I'm using the exact same URLs. I set that up purposely. I'm going to connect to them. Connect. This one will take a little bit. Connect. This one will take a little bit. We are all good. Good to go. What comes next? Our agent. So we go here to Agent Builder, and it's super simple, super visual stuff in here. We pick, I picked this cute little silly mascot that we have. It's called Devi. This is our DevNet mascot. In the instructions, I will be using this file here. Let me show it to you. This is our agent. Let me close this here. And these are all the different behaviors or the persona definition that we explored earlier on. These are the tools that you have at reach. These are your operational rules. This is your tool priority. These are your device operations, configuration changes. What are you going to do? Files, issues, diagrams. Where are you going to be putting them? I want you to put them in this specific repository. Your response style. I want you to be clear, be concise, use these emojis. Guardrails. I cannot stress enough when we talk about MCP, LLMs, whatever, in the networking world, we need to have guardrails straight off the bat. These need to be part of your design. We don't want either to have an LLM making decisions by itself, or we want to be pushing things on the get-go. We want to have some eyes on there. We want to have a human in the loop. We want to be this person who presses the button, who says yay or nay with these configurations. So we have this here, part of our agent persona, and I'm just copy all this text, put it here on my Libre chat in this part, pick the model, I'm going to use my Cloud Sonnet, and then finally here we choose the MCP servers that we want to use, okay, which is this three. That's cool, okay. So now if I want to fire a new conversation here, I go to my agent, Devi. Okay, I think I'm here with Devi. Yeah, all right. So I'm going to say, is it big enough, I think? Hello, world. Who are you? All right. I just want to check the persona specifications here. It's going to be thinking, it's going to be checking its definition, we'll check its tools available, and then it will come back here with a reply. Hey, I'm Devi, you're a network automation assistant. These are the capabilities, things that I can do with your RADKit. This is the documentation that I can do, draw IO, current status. I have 7 devices, show only. I think I deployed it wrong. Anyways, it's fine, okay? For the sake of the time, I want to share with you a couple of use cases, practical use cases of this. Let's say that, for example, let me zoom in here. I am planning the firmware migration of my iOS XE devices in my RADKit inventory. It's time to bring the new iOS XE firmware to my environment. I can ask which are the devices iOS XE, which is their firmware version, so I can plan accordingly. And here, this is what I ask. Hey, please summarize the firmware versions of my iOS XE devices. I'm planning a migration soon. Cool. What it does is that it fires some code in here. You can see here it gets the inventory. Then here it will get show version, include version, and then having this raw data will crunch all that information and tell me, hey, this is what you have in your RADKit inventory, just for you to be aware. And it asks me, hey, do you want to do something else? Whatever that may be. Okay, this is like a read-only planning migration-ish use case. Now let's crank up the volume a little bit. My day-to-day housekeeping, things that I would normally, like spin up a couple of CLI interfaces, SSH, telnet, whatever, and do the changes, right? Without much regard in our mind. But they can go south pretty easily, and we don't want a Friday night outage out of a regular housekeeping operation, right? So the persona of this agent does that pretty well. So I can ask, start with something very simple, like, hey, this is I want to create this new VLAN. I want this IP to be the SBI. Okay, can you do that for me? Yes, sure. Okay. First of all, without me telling it to do that, it will retrieve the current state of the VLAN-related configurations to see if there is no overlap. It will fire this Python code, like a show run interface VLAN on this specific device, and then getting the raw data, it will tell me, you know what? It's good. I don't have that VLAN. I don't have on my routing table, I don't have this IP in there, It's all good. So you're safe to proceed. This is what I will be pushing into your device. This could be this CLI, but it could be a netconf payload. It could be an RPC. It could be a restconf, whatever we want. It is handled by RADKit, and therefore it is handled by our agent. So, it's good. Okay, please confirm. Yes, let's go ahead. And then what it will do is that it will summon the different tools to push this. Let me show you here. It is using the pre-check commands, and then it is using some other Python code. Here, you can see config commands, and then it is executing the CLI commands in that specific device. Like, this is the client API of RADKit happening here in front of our eyes. And then we are going to be checking if that was applied. Then we get the configuration successfully applied. We have all of this goodness created, and we have these verifications, okay? It is ready on my device. But then what happens next? Some other regular housekeeping activity. New VLAN with a different SBI. What's going to happen now? It will go through the exact same process, but this time, when retrieving these configurations, it will notice that the SBI IP address has already been taken. And it will flag it right away before I proceed any further. So we have here, VLAN doesn't exist. The IP of the SBI is already taken. Hey, you may want to do something different because this may, bring down this VLAN. We don't want to do that, okay? So it's just for you to be aware, guardrails and human in the loop, these are the key concepts that I want you to take home from this session and to have them in mind when you start bringing all this AI goodness little by little into your own environments. Straight off the bat, design-driven guardrails, human in the loop, okay? It's just very fancy words for something very, very important. But now, I want to crank the volume up a little bit more. You may be familiar with this compliance guidelines, like these best practices guidelines that Cisco releases time and again. Not only Cisco, many vendors do that. This is an example of ISXE hardening. Like these are some security guidelines. Hey, your interfaces, your AAA authentication should be like this, should be like that. Simply suggesting you may want to have this in your devices, XE devices. So what I can do here, what can I do here? I can go ahead and say, hey, you know what? I'm checking compliance audit. Here's the URL. Here's my ISXE device. Just do it. Do it for me. I want to know how compliant I am against this publicly available hardening guide. Cool. I can do that for you. I'm going to fire a series of commands here, a series of Python code, a couple of commands, all that stuff, and then I have a summary. Key takeaways, you're compliant in some stuff, you're not compliant in some other stuff. I have a follow-up based on this hardening guidelines. I'm like, okay, sweet, that's amazing, but you know what? I don't really trust you. I don't really, I want to pass this through the eyes of my network engineers before we plan the deployment to be compliant with this hardening guide. And you know what? You can say, could you please save this report on GitHub? So I can send it to my network engineers, my network gurus, and they make the call, and then we can schedule accordingly, this hardening, right? So yeah, it will use the GitHub MCP server. It will create this file, and now it is available for all of us on my GitHub, sorry. And you have here the device information, executive summary, how compliant my device is with those guidelines. All that stuff is here. And then we have some high priority plan. Then we have some other stuff that we can do, right? Like, I don't need to trust this to the point, but I have a pretty solid starting point so that we can plan accordingly the changing of these configurations. And it doesn't stop there, actually. Because I can go ahead and say, you know what, I want to track this down. I want to have actionable insights on the plan for being compliant with this hardening guide. Sweet, let's create a GitHub issue. I'm using GitHub because, well, I couldn't get a license on time for something more, for something more realistic. Like, I want to ask you here in the audience, who uses PagerDuty, for example, for your issues, networking issues? Okay, 3 people with PagerDuty, cool. Jira, who uses Jira issues? Okay, that's the majority, I guess, cool. Who uses ServiceNow, for example? This is a pretty mixed audience. That's cool, I like that. Well, at least Jira and PagerDuty, they have their own official MCP servers. So you can take information, let your LLM decide, and push new issues and assign them to your engineers on Jira and PagerDuty. ServiceNow, I'm not that certain, but it must be. It must be. So well, in my case, I'm going to be using GitHub issues. Super simple. Please create this issue. Sure, it's there. I go there, and I have all this information. I have the overview, I have the reference to my report, the one that you just saw, and here I have these tasks, even with these cute check buttons. So, I can start tracking this, right? Maybe I will go back later and update this, but I have a solid starting point. I am not starting from scratch, and I am letting my network engineers, do the calls here to help them plan the compliance to these hardening guides. Okay, so it's this purpose here. We don't start from scratch, and we let this LibreChat agent guide our way through these activities, through this housekeeping stuff. And well, last but not least, I want to share with you one last chat. I'm a very visual-driven person, and I'm pretty certain that most of you are as well. That's parts of the perks of being networking people, right? It's always about that topology. The more information, the merrier. And well, we can use Draw.io to do that on the fly with our agent. I don't know if somebody here uses Draw.io on a regular basis. I think it's sort of the de facto tool for topologies and such on networking. I have never met anybody who hasn't used Draw.io yet. They have their own official MCP server. It's part of our trinkets here. And I'm asking, hey, fire up an L3 connectivity diagram, in between my devices. I want port names, I want interfaces. Yes, sure, I can do that. So after a couple of calls of that, first of all, to get the information from my RADKit, once it has that information, it puts it on an network topology diagram. This is Mermaid language. I don't know if somebody knew that Draw.io is based on a language called Mermaid. I didn't know that before this session, honestly. And the persona of my agent is wired in such a way that as soon as I ask it to create a diagram, it will display it on its Mermaid language. Because I want to see it here, live, on my LibreChat. And LibreChat supports navigation, I can zoom, I can pinch, I can span, I can do many different things. So I'm like, okay, but I don't want to take a screenshot of this. Could you please actually save it on my GitHub? Then it will go like, hey, yeah, sure, why not? I will create this cute diagram in GitHub for you so that you and your colleagues can check it further. And GitHub supports like navigation. I can zoom in, I can navigate, I can do all this stuff. And then just a small summary in there, just because. Pretty cool, okay? So, well, this is the whole demo that I had prepared for you today. Let me just go back to our presentation and wrap it up for good. Let me just jump here. Because these takeaways are really important. And it's something that I want you to take home so you can start deploying something like this with your RADKit service Monday morning, okay? Once you are set and done with Las Vegas. So first of all, RADKit, our kind of not so best hidden secret, but not purposely made for tag, but kind of used for tag more than often, is the super powerful automation, powerhouse, right? You can do all these things. Apart from the agentic part, you can do all sorts of automation with its APIs, with all this stuff. You can get it done. It is there, sitting quietly in your networks, waiting to be, waiting to be used its maximum potential. So that's my first invitation here. The second one, it's about those guardrails that I have insisted so many times during this session. Guardrails, human in the loop, straight off the bat, when it comes to your agentic LLM-based designs of your use cases. And then, well, last but not least, as I mentioned before, this MCP marketplace, it's growing more and more. So I encourage you to have a look at it. At developer.cisco.com, we have an official catalog of MCP servers dedicated to Cisco products and platforms. We have, as of now, we have a growing ecosystem. So pretty much any Cisco platform that you can think of already has an MCP server or is on its way to be supported by MCP. And it's something very interesting for prototyping. You can use LibreChat as well. As I mentioned, it's open source. And, well, it's pretty much that, the invitation to have a look at this and, make the most of this. About the repository, if you could take note of it, it's RADKit. Oh, sorry. Shoot, I always forget to close the presentation. Let me go back here. This is the official RADKit NetOps agent repository. It's in our Cisco RADKit GitHub. If you want to take a picture, that would be super cool. I will send it later to you, by the way. This and many, I created a list of resources. If you join the WebEx Teams chat, I will make sure to send you all this information. But here, just to give you a quick view, this is, in a nutshell, what it does, what you will get in the end, how to set up the MCP server. We have here all the different options, how to run the agent. Everything is here documented to the point. Okay? And then just some announcements here. We have, We have, at the DevNet YouTube channel, we have a series called Hack the RADKit. Here we put videos about interesting use cases for your RADKit deployment. So if you want to check it out, that's a URL. Also, if you want to talk to me, on LinkedIn, that's my profile. And just wrap it up for good. Your evaluation is super important for me. Like, it helps us as speakers to do our job better every single time. So please, please, please invest less than a second on giving an honest feedback for this session. And if you do, I will invite you personally to our new event of between Outshift and DevNet. It's Shift.Forward. We're going to be launching this on October 27. We're going virtual. We are preparing a real nice content for this event. Also, if you can pay us a visit at the DevNet zone right there, we have a really cool activation to get your feedback in case you are avid DevNet users. We have Legos, we have touchscreens, it's pretty cool. So I hope to see you there. And well, with a minute left, this is a moment when I stop talking and I give the microphone to all of you. If you have any question, or if you would like to ask me something, anything. Or is it all good, all clear? At least it was interesting. All right. Well, with what, sorry? Data exfiltration. Okay. That would be more a thing of MCP security per se. You know, how to control where these queries, where this data is going in and out. There's many different ways to do that. You can either use an MCP gateway, which is something that still is not widely used, but it's gaining a lot of strength, so that there you can have some different controls and such on an MCP gateway. You know, like beyond that, for securing what your MCP is doing, like security-wise, there are a couple of solutions. We have some labs here, because I don't have the names at the top of my mind, but we do have the Cisco, we have some Python libraries for checking the security of your MCP servers. We have some walk-in labs at the DevNet zone, if you want to check them out. It's called MCP Security or something like that. I don't really have it at the top of my mind. But I can get information for you if you want. We can chat later about it. 15 seconds, any other question here? All good? All right, well, thanks a lot, folks, and enjoy the rest of Cisco Live, Las Vegas.
Maxi.
Hi, everyone. Can you hear me well? Okay, good. So hi, everyone. First of all, I would like to say thank you for coming into this session. It's likely lunchtime, so I know some of us are hungry. But if you are here today, it's because you are hungry to learn about new technologies. And this is what we are going to do in this session. So my name is Julia. I am Crossword Technical Marketing Engineer for Crossword Automation Solutions. And what we are going to cover today is about how you can fortify your network using advanced configuration techniques. Remember, there is a WebEx space that you can find in your Cisco Live application. So we will try to cover some questions today, but in case we cannot, or if you just want to continue the conversation after the session, then please do not hesitate to reach out. This is the agenda that I plan to cover today. So first, we will do an introduction about the current state of network automation today, and also what is the target, where we want to go in the future with network automation. Then we will talk about also crossword AI, and particularly we will focus on one agentic use case, which is the configuration drift detection. And then we will go into the conclusion, and also we will have an exam. Well, okay, it's not an exam, but a quiz. So I will kindly ask you to please stay until the end and participate in the quiz. Okay, so what is the current scenario for network automation? And if you look into this slide, I will ask you to not misunderstand it, but network automation today is good. It's in a very mature state because it allows us humans to create workflows that can address different situations for the full service lifecycle in network operations. So automation today is good, it's better than ever, and is addressing most of the use cases that we can find in network operations. However, those workflows that we can create, they are deterministic workflows, and they are based on predefined rules. So that means that for the remaining list of use cases that we have in network operations, those cannot be addressed by automation because we need to have new technologies. And this is why the target scenario is about going into autonomy, going into autonomous operations, and using AI agents. Why? Because AI agents can observe, AI agents can understand, they can adapt, and they don't depend on rules. So they basically are driven by goals instead of driven by rules. They are self-planning and self-sufficient. And also, it will make your network operations more efficient because we will have less interactions with humans. So now, what is the journey towards autonomous networking? There are some working groups, for example, the TM Forum, which are trying to provide some guidelines, some principles on how we can go from the human operations into system operations, dividing the different stages into levels. So when we go from level 3 to 5 is where we are already entering into what is system operations, looking for autonomy. So today, the majority of service providers are actually trying to achieve level 3, which is that conditional autonomy. But of course, the target is to go then to level 4 and 5 to achieve the full autonomy. But we need to understand this is a journey. So now, the target is to achieve level 4 or 5, which means that we are going to pass from rules into skills. From rules, which is the current state where we are today with network operations, where we humans encode our knowledge into rules. And those rules will be focused to address specific use cases in our network operations. And those rules also will be predefined in order to know, for example, to which controller, to which system to connect in order to collect data and then be able to address our specific use case. So this is deterministic. Now, in the future, when we want to go into skills, is when we humans now will focus on setting goals, goals that will be passed to the autonomous agents. And then we also need to teach skills to the agents. So the agent will use those skills in order to autonomously decide to which controller to connect in order to collect the necessary information to achieve our goals. So now, in our domain, which is networking, networking is not just another use case for agents. So it comes with its own complexity because there are complexity in the technologies that we are using. There is complexity in the architecture. There is complexity in the design. So that means that we also need to pass context to the agent because the agent needs to know the environment where it is operating, which in our case is networking. How we are going to pass that context in this case with what we know the knowledge graph. So this knowledge graph will be basically the digital map or the digital representation of our network. All right? Now, those agents can just not live alone, but they are own. So, and you may know there are plenty of demos, plenty of prototype public frameworks out there where you can build and also host the agents today. But are you really going to allow those frameworks or those agents to connect today to your network? So most likely not, because you don't trust in them. So you don't know if at some point they will impact your network operations, right? So what we need is to have an agentic framework, an agentic system where to host our agents, but that system should be reliable and should be robust. So how can we make reliable agentic systems? Well, these are some of the main characteristics that any agentic system that wants to interact with our network should have. So for example, it should allow for LLM, for flexible LLM, because we need to decide to which LLM we want to connect. And also, we should be able to always connect to the latest version of the LLM. So the system should be flexible. Now, we also mentioned that networking is not just another use case. We need to pass the necessary context to the agent in the form of the knowledge graph. So my agentic system should be integrated with a knowledge graph. This knowledge graph will contain the information of the network, for example, the entities. For example, could be nodes or links or LSPs. Then it should also contain properties of those entities, also the relationship between the entities, any constraint, any dependencies. So all that information that compose your network should be included in the knowledge graph. Then also the system should allow for having integrated observability, because we need to trust, we need to know what is happening behind the scenes. So I'm sure that any of the public frameworks that exist today, they can run your agent, but they will not allow you to see what is happening behind, right? So any agentic system that wants to work with your network should allow for observability. Then, in addition to the knowledge graph, we should be able also to pass some additional context, for example, documentations or guidelines, and also the agent should be able to access that context in an efficient manner. So then, we humans make mistakes, but LLMs also make mistakes. And we should not expect LLMs to never make mistakes, because that probably will never happen. They are non-deterministic. What we need to do is to be able to implement mechanisms that will actually address those errors and then overcome them. So we need an agentic system that needs to be resilient. And then on the memory side, also, we need a system that should be able to track our requests across the time, right? Because also we need to provide feedback. Hey, are you doing good? Are you doing bad? And then the agent should learn from that feedback and should use that feedback to influence the future requests. So these are some of the main characteristics that any agentic system should have if they want to operate in your network. So now, in our case, from the cross-border automation product, we are working on building this kind of agentic framework, which is cross-border AI. So this cross-border AI actually will be focused, as we mentioned, in network automation. They will focus on having reliable agents. They will be deployed also on-prem because of security reasons. It will be LLM agnostic, because you should be able to decide to which LLM you want to connect. It will focus on having agents with quality, because also this system will provide the observability and the evaluation characteristics. And also it should be open, because yes, Cisco is going to provide some pre-built agents, but you also should be able to build your own agents and then put those agents into this secure platform. So now, talking about the use cases, we can divide the agentic use cases between reactive, preventive, and prescriptive. So in the reactive is, of course, when the incidents already happened, but then we need to minimize the impact. Then in the preventive, of course, is when we reduce the occurrence of the network incidents, and the prescriptive, which is focused on having closed-loop automation scenarios. So today, in today's session, because what we want to learn is how to fortify the network using configuration advanced techniques, we're going to focus in this particular use case, which is the configuration drift agent. So what is the configuration drift detection AI agent? The main goal is to detect anomalies in device configurations without the need for human-generated templates. So usually, historically, traditionally in the networks, we used to maintain what we call the golden configuration templates. So also, traditionally, those templates were maintained in a spreadsheet, for example, and all of those templates that contains the baseline of your router's configuration, they require maintenance, right? So they require human intervention to maintain those templates from time to time. And also, the complexity may increase in the cases when you have multi-vendor network, for example. So we saw an opportunity there. We put this use case with an agentic use case, having an agent that can learn automatically from the existing configurations. So that way, we get rid of the human intervention for the maintenance. So how is the agent going to learn from the existing configurations? Using a configuration language model, or CLM. So this configuration language model is not an LLM. This is not an SLM. This is a very specialized model that will focus on learning patterns from your configurations. And they will be trained locally using your configuration files. So once your model is trained, then there is a next step, which is the inference. And it's in the inference where the agent will be able to detect the anomalies or the deviations from the baseline, that in this case will be the trained model. So before I go into this example, may I check if there is any question about how this agentic use case works? Okay, no questions for now. So let's go into this use case. Maybe you heard about this because this is actually something that was also shown in this Security Week news. So this is about the SAL typhoon networking hopping. And this was related because some attackers entered into a router, and then they modified the configuration of this router by altering the authentication settings. So this actually exposed the complete network, because we don't know if after accessing this router, maybe those attackers could access other routers and then run any command they want. So this is actually how the configuration looks in the router initially before the attack. And here you can see how the configuration looked after the attack. So basically what these attackers did is to add one additional line in the configuration. You can see there below, adding a new user that will be able to authenticate in this router. So if this particular change will not be noticed, it could be staying there for days or weeks or months. We don't know. Now, using this technique of configuration drift detection, we can just run an inference using the agent, and because we have the baseline, which is in the model, so the inference process will be able to detect that this particular line is actually out of the baseline. So this is how the agent acts. It can be executed on demand by you anytime, but also it can be running in a scheduled basis. And it will be able to detect any anomaly in comparison to the baseline. So in this example also, because this was another change by the attacker, that they actually modified the attack server, so we also executed analysis using this agent, and the agent was also able to detect that this particular attack server is out of the baseline. So this is how the agent works in this example. But now let's see more in detail. Okay. So there are two particular processes or phases where we use this agent. First, we need the training process. So with the training process, what we are doing is to use the CML, the model, in order to be trained locally using your configuration files. Now for this, in the case of Crossroad AI, it provides one particular tool. It is a CLI tool that will perform this training. And in your router, of course, you have different roles for your routers, right? So you have the core, you have the aggregation, the access, and so on. So basically, what we need to do is to create logical groups per device role. And then each of those groups will be trained we will have a model per each of those groups. And once those groups are training, then we can execute the inference process. And it is in the inference process where we can load the configuration files, and those configuration files, in the case of Crossroad AI, can be fetched also automatically if you have, for example, CNC or NSO, which is the Network Services Orchestrator. Is any one of you familiar with the NSO? Okay, so this is the Cisco Orchestrator. So this agent has an adapter already to connect natively with this NSO and fetch the configuration files automatically. And in the inference process is where it will compare against the baseline that is contained in the trained model and will detect the anomalies. So now I will show you a demonstration on how this agent works. So this is my Linux setup where I have the CLI tool running. So first, let me log in here. Oops. Okay, now I will show you, in this case, all the logical groups that I already have here in my setup. Okay. These are already, I have actually 1, 2, 3, 4 groups, 4 logical groups created. So this means that I have 4 models running currently in my setup. So for example, you can see the Core XR, PEXC, and the PEXR, and also this Demo XR Cisco. These are my 4 different logical groups which are training currently in my setup. And then, because they are already trained, then I can already go and run the inference using any of those groups. So for the inference part, I will use this UI. This is the UI of Crossroad AI. From this UI, we can actually perform the management, any operation with the agents. So from here, I will go and launch the AI assistant. And then once in the assistant, what I need to do is to call and initiate one instance of the agent. So for that, I will call my agent. Then we have the option to run on demand or schedule. So I will select to run on demand this time. And then we can see we have the option to fetch automatically in case we have integration with CNC or the Network Services Orchestrator. So we can fetch automatically the configuration files from there. But for this demo, I will select to upload manually. And then here is the step where we need to select what logical group we want to use. Because actually, this model, what this model does is to try to find patterns in the configuration. So this is why also we need to separate by logical groups, because of course the configuration in the core will be not the same as the configuration that you have in your edge or your aggregation, right? So this is why we need to separate by groups. So I will select in this case this particular group, the Demo XR Cisco. And then I will select the file that I want to compare. Good. So it will take like a few seconds, I think less than a minute. Okay, well, in the sake of time, to not make you wait so much, so I will show you this other job, which actually is the same, because I executed this before this session. So this is the result after the agent is completed. So it will basically show to us how many configuration files were analyzed and in how many of them were found anomalies, and also the total number of anomalies, that in this case we can see there are 3 anomalies that were found for that particular file that we analyzed. So then here's a legend where it says that if you find a plus next to the line of the anomaly, then it means that the agent is recommending you that this line should be added. And if you find a minus, then it means that this line should be removed. So that is the recommendation of the agent. So let's see that in detail these results. These are the results of the anomalies. In this case, it is suggesting to you that in the gRPC configuration, you need to replace this line of the port because probably there was a typo here, and instead of having the 57,408, you need to have the 57,400. Then in the next anomaly, it is suggesting to you that there is an extra line in the SNMP server configuration. So the agent is suggesting to you that you need to remove, because this line was not found in the baseline, was not found maybe in the majority of the devices, and this is why the agent is suggesting that you need to delete this line. And then the third anomaly is suggesting to you that for one particular interface, this metric value should be removed. But of course, probably you set this metric value only in this device, only in this interface for some specific reason, right? So that could happen as well. So if this is the case, then the agent also will provide a mechanism for you to report the feedback. So feedback is very important also for agents. So this way, you can report that this particular anomaly, the metric 100, is not actually an anomaly, so it will be considered a false positive. You can report this to the agent, and once you submit the report, if you run the analysis again, then that particular anomaly will not be shown. So next, we can continue the conversation with the agent, and for example, we can execute again another task, or we can just put the task to be executed in a recurrent basis, right? And you can also run in a recurrent basis the training process. So this is how we can accelerate this detection of anomalies in your configuration without having to look at the baseline, without having to maintain the baseline, without you having to compare manually your files against any golden configuration template. This is the solution that we can find using an agentic AI use case. So now, let me go back here. So after this demo, is there any question?
Looking for differences that comes up with this only value, but what's a safe review of the configurations afterwards so that we don't cause an issue anymore?
So yeah, of course, those anomalies that were found are actually not changed automatically by the agent. So it still requires some human intervention in order to validate that those anomalies are actually valid, right? So yeah, the use case when we will have the agents executing automatically in closed loop the actions, so that is in the prescriptive phase. We are still in the reactive phase or proactive phase. So we don't reach yet to the prescriptive. And in the reactive and proactive actually is where we still maintain a human intervention, but only for those cases which are more relevant, like for example, the validation of the anomalies in this use case, right? So now the humans, as you can see, they don't need to maintain the golden configuration templates from time to time. They don't need to compare manually the configuration files against the baseline because the agent will do for you. But still, of course, we need human intervention for the validation. Yes. Any other question? Okay. So now I would like to share some questions with you. So I would like to ask you if you please kindly join to the Slido. Okay. Anyone else? Okay, I think we can start. Okay, the first question. What is the goal of the configuration drift detection agent? Is it to apply golden configurations templates in devices? Is it to generate golden configuration templates? Is it to detect anomalies, and how? Okay, time is over. Okay, good. So most of you got the correct response. Now, next question. What is the model type used by the configuration drift agent? So is it an LLM or an SLM, or it doesn't require a model at all? I forgot to say, for each of the questions, we have 40 seconds only. Okay, good. Yes, so it is a CLM configuration language model, remember, which is very specialized on detecting patterns in configurations. Okay, so we don't use yet, in this use case, LLMs or SLMs. We have other use cases where we use LLM, but not for this one. So next question. When we use the configuration drift detection agent, what is the name of the process when anomalies are detected? Is it training? Is it detection? Is it modeling? Is it inference? Okay, 10 seconds. Okay, good. Okay, so it is the inference process. So remember, there are two processes, the training, and then once we have the model trained, the next process is the inference, when we detect anomalies. Next question. With the configuration drift agent, before running the inference process, it is required to have, what could it be? Access to the internet, LLM, it is required to have some money. We just talked about this. We require two processes. One is the inference, and the other one is okay, good. Most of you got the correct response. Yes, so we have the two processes, the training and the inference. Next question. What is the name of the Cisco multi-agentic framework where the configuration drift detection agent resides? All right. Yes, so most of you got the right answer. Yes, Cisco NSO is actually, well, a different product that is focused on provisioning. We do have a native adapter that can connect to the Cisco NSO, but the agentic framework is the Cisco Crossword AI. One more question. The configuration drift detection agent has a native adapter to retrieve data from which Cisco platform? Okay, good. Yes, most of you got the right response. And this is the leaderboard, so congratulations to all of you, and well, to all of you for coming here to attend this session today. So with that, we come to the conclusion of this session. So please don't forget to fill your surveys because your feedback is always important for us to continue improving. And I hope you have a good learning the rest of the week. And thank you very much for coming in.
Okay, you good? Hi, everyone. Whoa. Hi, everyone. I'm Jason Belk. I'm a senior technical advocate with Learn with Cisco. And I'm really excited today to talk to you about spec-driven development, from prompts to plans, spec-driven AI workflows for NetOps. A little bit about myself. My background, I've been at Cisco for 14 years. I started my career in Cisco IT. I was a network engineer in network operations, got into automation, doing the DevNet thing. And then now I'm on the teaching side and trying to stay ahead of the curve to help share my learnings with the rest of you. And that, what I'm talking about today, I'm really excited about because this is something I've been using every day for the past 6 months. I've just seen incredible gains and improvements in quality because I think we've all seen the AI hype and all seen a lot of promises that may or may not deliver. And I'm not going to say that you won't have your own problems eventually to work through, but at least I've seen incredible gains out of what I'm going to teach you today. So before we get started, just to remind you, we have the Cisco WebEx app for this, and we have a WebEx space. I've already put links to the code and examples that I'm going to be going through today in that space. So feel free to join there in order to get the slides and to follow along and ask any follow-up questions while you're thinking about them. So the AI promise versus reality. This is exactly what I was talking about a few seconds ago. I mean, I think, especially when it comes to network engineering, it can be hit or miss when it comes to actually having AI produce things that you're happy with. Because a lot of the data that AI is often trained on is software engineering type things or English writing. So I think, at least in my experience, especially older AI, I would say maybe a year ago, it was really difficult to actually get accurate configuration, actually build use cases using AI. And we often see hallucinated device commands and missing error handling. And so there's a lot of problems, I'd say, in just like firing and forgetting with AI when you're putting your input into a chat bot, whether that's ChatGPT, Gemini, Claude, or so on. And what we're going to talk about today will hopefully help you with that. So in terms of a high-level agenda, I'm going to talk about the problem we're trying to solve. I'm going to give you a possible solution and walk you through how I'm going to set it up so you can see a live demo of me actually walking through this spec-driven development, what it looks like, and actually building a configuration template builder, and then when to use it and when not to use it. So this is a sample hypothetical scenario of what I'm talking about, where you might ask AI, hey, I want you to build me a scripted netconf, and then it makes certain assumptions about what you're trying to do, or it has incorrect training data on the problem that you're trying to solve. And then having this back and forth oftentimes leads to a context window where eventually it starts forgetting what you're talking about. And then you have to start all over again. So I would say that's another problem that's helped solve by spec-driven development, where I'll show you in a minute. Spec-driven development gives you almost like a project management guardrails and a written documentation flow for your AI to then be executing along that flow and not forget what it's talking about and kind of stay on track. And for network automation specifically, I think this is critical because oftentimes we're building automation that's for critical infrastructure. Of course, we want to have a human in the loop and looking at exactly what we're building before we deploy it to a lab or especially to production. But the challenges that we often face when working with AI, and I faced myself when I was building different things last year, was the context loss. It'll forget what you're talking about. You've defined your requirements, and then you're 30 minutes into it, an hour into it, it compacts the conversation, and suddenly it's forgotten some really important details that you wanted to give it. There's also no audit trail. So you've built this beautiful script, and then you're trying to build documentation or explain it to someone else, or maybe build a presentation about it. And it's important also to have a documentation trail for legal purposes, if you have SOC compliance or other kind of government or HIPAA type things where you want to have an explanation of how and why you built your code. And I'll also say another component that I've seen oftentimes in the bottom here is for debugging, where you ask it to fix one component of your broken code, and then it fixes it, but then it causes another issue. And you kind of get in this endless cycle of almost whack-a-mole, where you're trying to fix one problem, another one pops up. And I found without doing spec-driven development, you have a lot more issues because it's hard for it to get a bird's eye view of exactly all of the different requirements and code that it's trying to work with. So AI is a capable junior developer who needs clear guardrails, requirements, and tests, and a paper trail. I like to think of AI as someone that's incredibly intelligent, but not very wise. So you have lots of knowledge, but your ability to apply that knowledge is not always there. And so that's where we come in as the engineers who have the context of your environment, of not just your technical environment, but your workflow within your organization, your workflow for your customers, whether those are external customers you're working with on the networking side or internal customers for applications or end users. You're the person who knows exactly the impact and the important requirements of what you're trying to do. And I think that's a huge thing to keep in mind when you're building these requirements, is communicating those assumptions to your AI. And spec-driven development gives you a framework to be able to have all those requirements documented and fed into the AI as it's building the flow. So what is spec-driven development? It came out about last summer from GitHub, from the Microsoft team. They have what we call GitHub Spec-Kit. I'll show you in a minute exactly what it looks like. But it's basically a bunch of skills behind the scenes, a bunch of bash scripts that give your AI a series of instructions to be able to have a flow of understanding exactly what requirements you're working with, building a task list, and then implementing those tasks. So it helps you basically make your AI more into a contractor rather than an intern. And one of the other benefits is that as it's building these plans, it's able to map out which parts of the code it can start building in parallel. Because if it's able to get a bird's eye view of what you're working on, it can start architecting out, okay, these parts of the code don't conflict with each other. They're separate Python files, so I can just build them all at the same time. So that also speeds up your development cycle. One other important point that I'll show you a demonstration of is the constitution. So the Constitution, just like in America here, it provides the governing principles for your AI to know what to do. And it basically allows, each time it's going to be building something, principles for it to refer to as it's building. So something like this is just a proof of concept demo. Don't worry about building it out exhaustively, or use Python, or do test-driven development. It gives it these governing principles to refer to every time it's trying to make a decision to not conflict with. So rather than reading off the slide, I'll show you what the spec toolkit actually looks like. We have right here the GitHub spec kit on github.com. You can go on here and install it using the installation process of UV tool install specify CLI. I've already installed it on my system. And then after it's installed, you can do specify init my project. And I'll do that here to show you what that looks like. So we specify init demo SDD. And when I ran that command, you can see some fancy CLI art. We have the GitHub spec kit. It asks you what coding agent you're using. I'm using Claude Code. And it asks you if you're using PowerShell, PC, or Mac or Linux. I'm using a Mac. And so now it has already set up in this project folder. It's created a project folder called demo SDD. It's an installed because it knows it's working with Claude, some Claude skills that are those bash scripts I was talking about. And this command is available to me because I already installed it using that UV install command before we started this presentation, but that's pretty much all the setup I did. So now if I go into that folder, so if I go cd into SDD demo, right? Let's scroll up, demo SDD. And if I open up Claude, it will load in those GitHub spec kit skills. So if I do /, you can see they now appear within my available commands. And so now I'll go back to the slide so we can see exactly what's going to go on behind the scenes for these skills. So the commands you saw there, really the main one you need to remember is Constitution and specify. All the other ones kind of flow from one to the other. So the Constitution command defines those governing principles for your project. You really only run it once at the beginning of your project, or if there's a pivot in your project where you're going, okay, I'm going from a proof of concept now into production. So we want to add security, we want to add credential management, we want to have ability to have everything in a CI/CD pipeline. Other aspects like that would change the governing principles that you're working with in a spec kit. But initially, we're just doing once per project the spec kit Constitution, and then spec kit specifies those requirements. So if you've worked with a project manager, that's when you're defining your requirements. And you don't need to overthink it. It's just more of a matter of explaining what are you trying to do. And then the AI will use its intelligence to interpret what you're trying to do and give some feedback on starting to build out those requirements and writing them to markdown files for you. So let me show you what that looks like in terms of a file. If we go here. So you can see this was a previous one I had created. And I'm on the spec here. If I pull it over, it had created a new feature branch. And for a network config generator, which I'll show you the demo in a minute, and it had also built the Constitution earlier. If I go to specify on there, so coming back to the presentation, we'll walk through some of the other examples. So what we're going to build today is a network configuration generator. So those of you who have worked with Jinja 2, you can have basically a Jinja 2 template that allows you to feed in YAML config and then generate some network configuration. And we're going to give an example to the AI of what we want to work with, and then have it create that for us. So for the live demo, we're going to start with our Constitution, and then build our Constitution based on our governing principles, and then go into the specify phase. So I'm going to skip ahead to these are the 5 Constitution principles that I came up with, but you can come up with your own. So the 5 ones I thought of, and you usually want to have anywhere between 3 and 5. If you have too many, it'll ask you to kind of get down to a smaller number. Is we have Jinja 2 templating. We're talking about the technology you want to use. We're going to work with JSON device variables rather than YAML or some other data structure. We're going to have test-driven development. If you haven't worked with test-driven development, that's actually a very helpful approach with AI because it basically tells the AI, I want you to build tests that are failing and then write code to make those tests pass. So it kind of forces it to give it a goal line to work with. And if you include that in your spec-driven development constitution, it's giving it basically additional set of guardrails to work towards. And then we're also saying make sure and write actual code on Principle 5 and give it a canonical directory structure that we want things in certain places when we're building our config. So let me take those previous constitution pieces. I'll just copy them from the slide. And we'll go to SpecKit Constitution. Paste it in. And you can see here I pasted in SpecKit Constitution. We're using Gen 2 templating, JSON device variables, test-driven development, the canonical directory structures of templates, vars, and build, and the functional commits only. So now it is reading the files and building the constitution for us. And while that's building the constitution, I'll head to the specify flow. So within GitHub, after you've built your constitution, you want to specify your requirements. So you can give it, usually I give it a few sentences. You don't want to be too generic, because if you leave too much open to interpretation, it might interpret in a direction that you don't want to actually go. So you would want to talk about the problem you're trying to solve and any technical details you had in mind with that. So for the example that we're giving, I actually have some additional context I'll give you in a minute of example config files I'm going to give it, as well as some network requirements. So within the spec.md file, I generally don't look through it myself because I more focus on the output of when it's being built, but you can go into the markdown files, and this is the general structure it has in terms of it gives an overview description, acceptance criteria, user stories talking about exactly, it builds out based on your initial description what you're trying to build. And you can always go into that markdown file and edit it yourself. And this can also be helpful for you if you're working in a team. You could break this up into actually having a collaborative experience where you build your specs, then you have your team review it, people provide feedback, and then if there's any changes, then you go on to the next task. So basically, for what I'm doing in this example, I'm just going to go from one to the next, but there's no reason why you couldn't split up these steps and kind of have more of an approval process in that flow. So within our example, and I don't always do this, but it does always help AI to provide more context. I have two files. I have an example switch configuration, just so it knows what type of configuration we're looking for, Cisco iOS switch, because iOS could be a lot of different things. And I'm also giving a network configuration policy, because you might have specific requirements. We only use this VLAN range, or we have this interface description naming convention. And so I'm providing a PDF file as well as a config file as examples when I'm going to be creating that specify phase. So I'll go back to this slide and just copy what we have into our specify phase. So we can see that it created the constitution file. It was asking permission to create the file, because anytime it's working with one of those SpecKit files, it always asks. So now if we go to SpecKit specify, and I paste in what I had from the slide in terms of our network config generator, and I'll give an example of the type of code we're trying to work with, and we'll just copy in that component as well. And then I'll also tell it I have in the assets folder, up one directory, a PDF for network config requirements and sample network config. And so the key part there is I did the SpecKit specify. I pasted in the content we had from the slide in terms of the type of tool we're trying to work with. I gave it some examples of config we're trying to work with. So if I go to, just to kind of show you, I was going to pull up the assets folder. So right now it's reading in those network configuration examples. It pulled the information from the PDF. And it's starting to build our specs. And it's starting to use Git version control. So if you haven't worked with Git before, I'd say AI is a great way to get started, because it does all the boring commands for you. And especially with GitHub SpecKit, it automatically breaks it into new feature branches for you. So that way you're doing best practices of having it work on a feature branch before merging into main. So right now it said it read in the files. It was saying it's going to proceed with the specification creation. It's creating a new directory for the checklists on those markdown files we were talking about. And I'll go ahead and go back to the slides to see the next step in our flow. So after we've defined our requirements with .specify, then we move into the planning phase. So I generally don't actually provide any input to the spec kit after the specify phase. It just kind of goes from chains from one to the next. You can provide additional context, like if you review the specs it created on that first step and you see any issues with it, like, oh, you're building this as a bash script and I actually wanted this as Python and I didn't clarify that in my constitution, you can provide feedback at any point in the process to help kind of course correct it. But generally, if you've defined your requirements clearly at the beginning, I just kind of go from one to the next, and I'm only really providing input on that first phase. So for the spec kit plan phase, this allows it to then research online for the different technology options. So like, for example, right now we're building a CLI config generator, so it's going to look at the different Python tools out there, like argparse and I think clip, and the different options it can have in terms of frameworks. That's where, after it's got the requirements, then it starts planning out what it can do from a technology perspective. So let's take a look at our flow. So if I scroll up, we can see that the specification is complete. It's created the specs for the network config generator. And if we want to look at that, we'll do cursor. Open up on that directory. We can view those files under specs. It was under specs 001 network config generator. And it built the spec here. And if I open it up in the markdown preview mode to make it a little bit easier for people to read and make that font a little bit bigger, we can see this is what it just built. So the feature specification for the network config generation, we have a user story for generating a single device configuration. Then we have user story 2 is validating the JSON variable against the schema, which it pulled from that copy and paste from the slide. User story 3 is batching multiple devices to create configs. And then it defined, based on its own knowledge of this type of problem, edge cases that could happen in terms of this, and different functional requirements listed out for each of the steps, and success criteria that it's going to be working with, as well as assumptions. So since we have the specs and we reviewed it, we can then go to spec kit plan. And like I said, I generally don't put that much input in at this point, so it's going to continue on from building the plan from those specs based on the requirements it has from that first step. And it generally doesn't take that long, so I'll just give it a few seconds to build those context pieces. While it's building, are there any questions or clarifications? No? And I would say with the GitHub spec kit, one of the other neat things about it is that it gives you, I'd say, a really rapid way to prototype and build something to see if it's possible. So if management's saying, oh, we want to see if we could build a config generator, you could build one in a couple of days. And come to your meeting, instead of coming to the meeting with a PowerPoint saying, well, this is what we could do, you could come to your meeting with a demo and say, this is what it would look like. And generally, people, I find, are more receptive to an idea if they already see how it's working and they can see what type of feedback, because it's almost, when it's in a theory, people have less feedback than when they actually see the buttons on a page or they see a CLI command. And I'd say for network engineers, in my experience, you want to think about the audience that you're working with. And that's important to think that it's harder to build like a web app and have that hosted somewhere than having maybe a CLI tool that you can have on your jump host for your different people to work with, or having a CLI tool that can be in a CI/CD pipeline that you might already have set up. So we can start looking at some of the files it's creating. So we can see it's creating a quick start file. It's creating a contract CLI.md file and a data model file. If we go in here, we can look at the files. We can see that it created a data model for this network config generator. saying that we're going to need things like a host name, we're going to need things like a device type, we're going to need things like interfaces, VLANs, management, NTP servers. It pulled this all from the configuration example I gave it. The interface needs things like a name, description, VLAN ID. The VLAN needs things like the ID, name, and description. And so it's building these contracts and this data model so that way when you have the CLI tool and it's building the configuration, it's be able to validate those inputs before they even go into the configuration. And so now it's built that plan, and we can move on to the task phase. So I'll go ahead and get that started while we look at the task slide. So Spec-Kit tasks is just like it sounds like. It's its checklist of specifically, okay, I've defined my requirements, I've built a plan for what type of technology I'm working with, what type of data model I'm working with, and now you can break that down into a series of concrete implementation tasks that it is going to do. So right now it's building those tasks for us. You can, of course, it's a markdown file, go in there and add tasks yourself or give it feedback in the process and kind of say, oh, no, we need more validation because this is a hospital and we want to make sure that all the security requirements are met. Or we always have additional logging that go to this type of server. And the tasks is the last step you hit before you actually start implementing the code. Because everything we've done so far, we've not actually written a line of code. It might seem like overkill, like, oh, you're just writing a bash script. I could just do that in like 15 seconds without doing this whole framework. But the whole point of this is that we're building this audit trail. We're avoiding hallucination. And also, you can do this more than once. We've done one spec. Once we've done this, we could do another spec with another set of requirements. Okay, we've done a VLAN. What if we wanted to add ACLs? What if we wanted to add Nexus? And you can kind of have each spec build on one to the next. I have some personal projects that have hundreds of specs. I've been working on them for months. And it also gives an audit trail for your AI to work from, because usually its context is just for that spec. And you can say, oh, can you look through the previous specs and see we already solved this problem like 3 weeks ago, and look at the requirements we defined, the research we've done, and all of that's organized for already in all these files for you. And because we're using test-driven development, that's what TD stands for. That's not part of the spec kit, but it's something I generally put in there because it forces the AI to give those tests, those concrete tests that it needs to pass, rather than just saying, oh, I built code and I think it works. And that it will actually run the code and make sure it generates the artifacts that you're looking for. So it's finished the task phase. I'll look at that in a second, but I'll go ahead and start the implement phase while we're looking at it. So if I scroll up here, we can see the tasks were generated. It put it into our 001 spec on task.md. We have 48 tasks, 5 setup tasks, and then it has our 3 user stories tasks with about 10 tasks each, with 4 tests and 6 to 7 implementation tasks for each one. And it also usually marks, I don't see it here, but when there are parallelization opportunities, that's where right here it says there's 4 tasks that can be parallelizable, task 43 through 46. So just because it knows what it's going to do, it said, I know I can do these ones at the same time, so we'll plan on having that sub-agent spun up automatically. So let's go ahead and take a look at those tasks. If we scroll up, we can see these tasks are in the spec, task.md. Go to task.md. And here's the markdown file it just generated. So it tells us the format of how it's building these tasks, the naming convention of our project. Remember, that was one of our constitutional requirements, is that we wanted to have things in certain named folders. It has to be an SRC folder, it has to be in templates folder, because that's what we're expecting our production environment to have. So it has setup tasks in terms of creating the directory structure, creating the initial Python files. It writes the failing test that it needs to pass. Then it goes on to generating the device configuration tasks. So you can see here the test-driven development. It starts by writing failing tests for all the different things it's trying to do in terms of rendering the template that will generate the config. And then it writes, then after writing the tests, then it writes the actual code to pass those tests. And that's the implementation phase for that first user story in terms of passing those tests. So writing the CLI renderer that is going to take the input of those JSON variables, then feed it into a Agentic 2 template. And then we have a JSON schema. So if you haven't worked with JSON schema before, it's actually fairly useful. And one of the reasons I put it in here is to kind of help indirectly let you know about it. Where as network engineers, you have IP addresses, you have other strings that you're inputting into your network configuration. If you're just working with Ansible or Python, it generally doesn't care what those strings are. You can feed an IP address with 2 periods in there, it's still a string. So the benefit of JSON schema is it gives you input enforcement and saying, hey, I'm expecting this type of format for this particular type of data. So if I'm looking for an IP address, I'm looking for it in a format of, between 0 and 255 on these 4 octets, and have maybe 2 sets of those. So you can get down to really granular detail and even ask the AI to build that based on its knowledge of these types of data components. And so that's just a side benefit of doing that with AI in this approach is that it's kind of doing that heavy lifting on the schema for us. So then we have the third user story in terms of not just making a single device configuration, but also making a batch. So if you want to make 100 configurations at once. And let's go back to its writing the code. So right now, if I scroll up, we'll kind of get to the top of the implementation so we can see some of the code that's been flying by while we've been talking. So go to the top here. It is building the test directory. And then it updates our PyProject.toml. So if you haven't worked with a PyProject.toml, it's similar to a requirements.txt that basically defines the Python dependencies for the particular project in a slightly different format. So it's basically saying, if someone else wants to run this project, these are the Python dependencies they would need to use in order to run it. And it creates a get-ignore file, ignoring all of the Python cache components, so they're not committed to a version control. Then it's going to create our testing files and our actual tests. So first it writes the failing tests, and you can see little snippets from our tests, and we can go into those files. We can see these, the code is starting to pop up. So if we go into one of the tests, we can see our configuration test here. We have working with an interface Jinja 2 template, so it has some sample content it's working for its tests. In terms of JSON schema, we have a sample JSON schema that's written for the test here as well, in terms of actually making sure it's generating the configuration that we're talking about. I'm not going to go through all the tests, but we can also start looking at the Jinja 2 templates. So you can see it built this Jinja 2 template based on the configuration sample I gave it. So we have the host name where you plug in the host name where the host name goes, and we can see for the IPS SSH version, it even realized it needs to do conditional statements, because you don't always have some of these statements in there. So I didn't tell it to do that. It just looked at the configuration and our requirements and decided, oh, we need to put some Jinja 2 conditionals in there. We need to put some loops for each interface in our list of interface, loop through, add descriptions. And I've done a lot of handcrafted Jinja 2, so I really appreciate the attention to detail the AI just built in a matter of seconds for us with this Jinja 2 template. So that's the one for the router, and it has a different one for switches. So let's go back down to here, and it's finished writing all of our code that's passed. So we just kind of reviewed a lot of the code, and so that's actually the last step in our flow. So let's demo it. Say, okay, what do I do to run with UV test? Live demo for a config. So it was thinking I was talking about running the PyTest. I'm not interested in running through all the PyTests. I wanted to generate some configuration. So let's do UV run. So it's running all of the commands here. You can see it did UV run config generator render. So it plugged in the template for Jinja 2 with the variables for a switch1.json and created with our JSON schema, as well as did the same thing for the router. So it did it gives us an example now, a quick reference for if we want to do it for a single device, validation, or do a batch for all devices. So let's go ahead and look at our output build directory to see the config it created. So let's close up templates, close up tests, and we have the build directory. I don't see that here. Well, let's just try running the command on the single device. Oh, it's just grayed out? Yeah, because you're right there. Good idea. Good eye. Yeah, because if we go back to the previous step, we had get ignored the build output because those are the artifacts. And we can see we have the router configuration here, but it was just kind of hard for me to see because it's gray on black, and my glasses don't help with that. So we have our router here, router configuration, and switch configuration based on our test requirements. So another step that I didn't demonstrate here that's good to know about is the Spec-Kit Analyze step. So this is an optional step that you can do where if you have a lot of tasks and maybe you've done a lot of specs over time, you can ask it to analyze for consistency, to be able to compare basically between all the different, because if you're going through your flow, you do Spec-Kit specify, maybe you change the requirements of the plan, maybe you change the requirements again of the tasks, and there's been these changes over the flow, you can actually ask it to analyze to make sure that there's no inconsistencies in the flow that you've created. So this is an optional task that I've used on occasion that is very helpful in order for it to make sure all of the code and tasks that you're working with actually follow your constitution principles and that there's no inconsistencies in your flow. So what just happened? I went through a lot of code, a lot of terminals, but at a high level, we as the human define the requirements. We as the human provide the insight. We gave it the config. I gave it also a PDF file of our network specifications of how our network actually runs. But it did all the heavy lifting in terms of the coding. I think for me, someone with a network engineering background, that's the level of interaction I actually like working with code. Even though I've taught CCNP automation, DevNet stuff for years, I have a lot of experience with coding. It's still something that I'm more outcome focused. As a network engineer, you're usually so busy that you're like, I don't want to be troubleshooting random dependencies in my Python. I just want it to work, and I want to get on with my job because I got other things to do. And so that's one of the things I love about spec-driven development is that I can kind of like set up my requirements, fire it off, and then get on to some other work, check in on it, and see, oh, okay, you're on your task phase. Let's go on to the next one. And it kind of allows you to do multitasking. Oftentimes, I have 3 to 5 tabs open at any given time where I'm building 5 different projects at the same time. And you can even be working on the same project on different what they call GitHub work trees, but I don't recommend that if you're just starting out. But it just kind of lets you know that there's a lot of parallelization even for you as an engineer to be able to think of ways to make your job easier and make your operations team happier. And when I first got into this, we have a GitHub repo for our team that we create tutorials, which I create a tutorial on this that I'll show you in a minute. And in that GitHub repo, we have a ton of markdown files for all these different tutorials. And we had a CI/CD process that, let's just say, had been built but had issues with it. And so I went in there with GitHub Spec-Kit and basically cleaned up all of this technical debt that we had just not been getting around to for years. We also had an older GitHub repo with an older format for these tutorials that nobody had ever wanted to migrate over. And so I created a spec for that. And so like in the span of a week, I cleaned out like 2 years worth of old technical debt. Just because I knew what the requirements were, nobody had wanted to do the work and you wanted to make sure it was done right. And so I'd say that's one thing is start with concrete projects that are not touching the network even and think of ways to make your life easier. Another related one is that we use Jira. So you have Atlassian Jira for keeping track of all of our work. And there was a delta between we had all of these tutorials and then the place in Jira where we were supposed to track all the tutorials for other people to know what work we were doing, and they weren't always the same. Or maybe there was spelling differences between how the title went in one way, we changed it over time, and we never updated in Jira. So I gave the Jira API key to Claude Code with the spec and kind of defining, hey, I want you to go through all of our existing Jira tickets, compare that against all of our existing tutorials, give me a CSV Excel export of what those problems are. I'll tell you which ones are false positives and why, and then we'll just update them all. And so I was able to then clean up the data in that way too. So I'd say is think outside the network here. Even though I gave an example here to try to be more network engineering focused, think of all the different aspects of your job and kind of the things that actually are maybe technical debt that you've always been wanting to fix but never really had a chance to. So I mentioned this earlier, but I just created one feature, one spec. It will automatically start numbering and doing the next spec on the flow after you finish implementing. You go back to the specify phase, and like say if we wanted to add a new augmentation on the VLAN config, maybe we wanted to do SVIs. We want to say, okay, we have VLANs now we want to have layer 3 interfaces. Or we want to move to Nexus. You start over in the same repo, and you just continue going through that specify, plan, tasks, implement, and go back in the beginning then. So I say that's one of the other power too, is that you're able to continue to build on your work and actually build more sophisticated projects. And then what I often do is then I'll point Claude at my project and tell it, build me a PowerPoint presentation based on all the work I've done. because it has all of these markdown files of the specs and tasks and tests and all the things it's done, it can then generate markdown files that Claude can then build into PowerPoint files, so then I can present to my manager, my team on what I've done without having to actually build the PowerPoint either, because it has all that additional context already. So spec-driven development really shines, like I mentioned, when you're working with a multi-agent work or a large team of people or just kind of more complex work. Also, if you want to have documentation to be able to hand off to someone else, it makes it so that whatever you're building, if someone else wants to start working on it too, you're like, oh, I actually started working on a project recently with another engineer, and he was able to review all my specs and then start contributing his own. Because it provides that paper trail for them to then understand the architectural decisions you made, why you made them, the trade-offs you made. Because whenever you make any type of technical decision, you always have to make some type of trade-off. And being able to document that decision flow through these specs gives you that paper trail to then be able to hand it off to someone else or have them collaborate on the project as well, whether that's from a networking perspective or just from a generic software. But spec-driven development's also kind of overkill. If you're just doing like a quick one-off script, you're like, okay, I need to do a quick cleanup of all my screenshot files. You don't need to do spec-driven development for that. You can just have AI do it for you and then have it be happy with the result. So I'd say spec-driven development, it does add a time overhead. You know, in the course of this presentation, it took a minute or two for each step. It's not nothing, but it does add up, especially for larger projects. So if you are just doing something that's a really quick one and done, small script, you don't need to worry about spec-driven development, but like I said, I use it for most of my significant projects, and I've been very happy with the result. So the key takeaways, I just want to reinforce, there's nothing wrong with ad hoc prompting. I still use that for research and trying to explore a bit, or sometimes I've introduced my own custom steps in the spec-driven development flow. So after you have specify, plan, tasks, and implement. So between I have my tasks and ready to implement, I've actually added a review step on my own custom flow. And you can ask Claude to do that for you. And I've added a multimodal review where I have 3 different AI models. So I'm using Claude. I have Gemini, OpenAI, and Grok all review my tasks, review my specs, review all of my requirements, and make sure there's no gaps in it from a security perspective or maybe there's other capabilities I should be considering. And then I also usually do another step after I implement. I have a multimodal review on the pull request. So generally, I'm working on a feature branch, and I pull that feature branch to merge it into the main branch. And then I have a series of AI then review the code to make sure that there's no gaps in the code as well. So I'd say that's another layer that's not part of the GitHub spec kit, but I highly recommend adding in some AI review processes both before you actually start implementing and then after you implement before you merge the code in. Even if the code works, sometimes there can be gaps or edge cases it doesn't think of. So in terms of resources, you can go to GitHub right now, download the spec kit just like I showed you. I also have a tutorial on Cisco U. If you search for spec-driven development on there, it's on the first page. You can kind of scroll down. I'll show you in a second. And then you can go on github.com, and I have the demo project I just showed you. I put the link out into our current WebEx space, so all of you can download it and play around with it and kind of get a feel for exactly what we're working with. I'll show you what the tutorial looks like. So we have on Cisco U. So our team with Learn with Cisco is in charge of Cisco U. So Cisco U is where we have our learning paths, courses, but we also actually have a ton of free content. So even if you don't have a Cisco U subscription, or if you do, you can go on u.cisco.com/tutorials, and we have a whole list of tutorials here. And this is the one I've written. I came out with about 2 months ago on Introduction to Spec-Driven Development. Build a project without writing code. And it actually goes through this exact use case that we just walked through. So you can take your time going through it. And it doesn't have to be with Claude. I demonstrated Claude here, but it works with GitHub Copilot, Gemini, or even your own local models if your enterprise doesn't allow you to use frontier exterior models. So that's all I had to share today, but I'm really excited to hear what you all began building with it, because like I said, both on the professional side and on the personal side, I've been building a ton of projects. I built a productivity app for my wife to help manage your schedule and manage your budget and all kinds of things with Spec-Driven development. I'd never done that before. Built an iPhone app, and I've also built I play Magic the Gathering, and I built a whole website for that as well. So I'd say play around with it, not just on the professional side, but play around with it on your personal side. See whatever kind of side project fun things that you're into, and have fun. Thanks.
I'll try to call it out, though, a couple of times. It is not master control program. All right, I think we're live. Are we live? Okay, you guys able to hear me? Test, awesome. Dave?
Think so?
Okay, cool.
Yeah.
They'll kind of,
Good.
yep. Awesome. So I'm Bernie Clairmont. I'm a solutions engineering leader here at Cisco ThousandEyes, and I have my special guest, Dave Burton, who's going to talk to you about the real world, about how this stuff works versus hand-wavy things. But we're going to talk about ThousandEyes MCP server today, how you can accelerate your incident triage, and have some AI-driven network intelligence and workflows with Agentic Ops. Feel free to join the chat. I put some extra context in there. You'll be able to download the presentation as well. The PDF has some live links in it that you'll be able to check out. And anything you'll chat with until June 13th, we'll be answering questions. I have the PM actually in there as well for MCP, so he'll be able to answer questions that you might have, or if you have ideas about tools or things you want, feel free to post in there. We'll get into the roadmap. We've been very agile about the tools we add. To cover just the quick agenda, we'll talk about ThousandEyes MCP, which is Model Context Protocol. We'll talk about the server configuration briefly, and then we'll go into a quick demo, and then I'll jump into some things around Agentic Ops and Agentic Operations, some use cases, and we'll see a quick demo, and then I'll wrap things up with the future direction of where we're headed. So, really, AI, as I think you've all seen so far, is really revolutioning the way that network operations occurs, as well as just your general workflow. And it's empowering IT operations to operate more effectively and efficiently. It's streamlining your operations in a lot of different ways. And there's so many different use cases to really bring you instant intelligence from all the different data sources that you're being deluged with every day. And tying that all together into something that's operational and actionable is really important versus all the noise that you have. So ThousandEyes came up with an MCP server, and really we wanted to help enable, AI assistants having access to the deep and rich data that ThousandEyes has, and make it very fast and efficient, and provide a conversational workflow so you can ask it questions to get answers versus just, hey, I'm going to hit this API and I'm going to get these metrics back, and then I have to go interpret those metrics, and then I need to put that over here and do these things and figure all this stuff out. And so we wanted to meet you where you were and make that ThousandEyes available to your AI assistants and your Agentic Ops workflows. And so that just really expands the troubleshooting user base. It expands it out beyond just the NetOps and the engineers. It takes, you can add stakeholders, your executives. I've shown executives how to use MCP and just ask questions about their environment, and they're like, wow, you can actually do that quickly, because it's minutes or even seconds. And you can integrate it into ServiceNow so we can meet you where you are. Whatever your ITSM workflow is, being able to enable that with a simple MCP server config. And so that conversational AI-driven workflow, really with the ThousandEyes data, makes it so you don't have to context switch. You can take that data and, if you have other MCP servers, combine multiple tool sets to basically reduce your mean time to identification, as well as, your mean time to resolve your problems that are facing your operations today. And, having that natural language makes it so it's simple to use. Anybody can use it. Hey, tell me what's going on with Wi-Fi performance in this particular building, and it'll go through and do that analysis for you. You don't have to say bad or good, things like that. It'll do it. The MCP also exposes, that ThousandEyes data in a standard protocol, so you don't have to know, again, which API to use or any of those kind of things. It automatically, the tools know what data to use when you ask the question. And you can tie it into assistants really easy, like Claude Desktop, Cursor, Microsoft Code, things like that. And you can, again, integrate into ServiceNow or those kind of things, so you can automate that with real-world troubleshooting steps that are enhancing your workflows. So the public MCP server that we have really exposes that network telemetry as well as the path visualization, BGP routing, all the alerts, all those different things, as well as allow you to run instant tests, create new tests, any of that kind of stuff. It supports like a lot of different troubleshooting workflows as well. I'm not going to go through all of these, but ultimately, based on the ThousandEyes permission the user has is what they're allowed to do within the platform. So you don't have to say, okay, well, we need to tie this down here and there. It's whatever they can do when they access ThousandEyes, they'll be able to do if they're using their user account. And it operates as a client-server model. So you can think about it kind of like USB-C. It just works when you plug it in. The same thing kind of happens with the MCP server. It allows you to have that adaptability. And it's designed really for AI agents as well. So having that JSON RPC2 response and the way the data comes back allows those AI agents to parse that data very effectively and efficiently. So now as you're tying those tools together and you're using third-party tools as well, you can make an efficient workflow that gives you the best information. And we unify all of that with the tool-based infrastructure so those agents can discover what those tools are and be able to execute that. And so as you think forward-looking, the different protocols like A to A and things like that are coming out, all of this is going to fit directly into those pieces as you're creating new agents. And without creating custom code either. I mean, it's right there. This is a word salad, I know. It's a lot of different tools. We're constantly adding more tools. So when I wrote this, we've already added tag support. We've added some deep reasoning models as well. So I always start with what tools do I have available, and I'll show that in the demo in a minute. But the ability to really, we started off with the ability to just read data only, and that was our initial design. Then it was like, well, we really need to add endpoint agent data as well, because that's really important. So we did that. And then we're like, well, we need to be able to make it so people can actually test things. So running an instant test to troubleshoot real time. So we added the instant tests, and then we added the ability to actually create tests as well. We added an anomaly tool as well, so you could say, hey, over the last day, in this particular location, tell me if there's any anomalies, because maybe you didn't see it, but we can find the needle in the haystack and tell you, oh yeah, this particular interface from this router was taking this path, it failed over here, did that twice during that day, and it caused your latency to increase by 200 milliseconds. And maybe for like a half hour every day that happens. And your users don't notice it because they'll just fail in silence and like, yeah, I mean, think about it like when you go to do a credit card transaction and the kiosk is slow, they're like, oh, well, the network's slow. Well, we can show you where. So some of the different prompts, these are just some simple examples, but asking what tools are available, like I said, start with that. See what tools, and then you can say, how can I use these tools? What's the best way to use those tools? If you're in multiple different account groups, we will use the default account group that your account is associated with, but it does have access to all the other account groups that you have access to. You could also say, hey, what active tests do I have running? Do I have any active alerts? Help me do an alert analysis. Help me do root cause. Are there any outages with third-party systems? Provide me an executive summary. So think about the length of time it takes you to do a post-mortem. You can do that in minutes. And then you can also interface with third-party collaboration tools. So now you can say, I'm going to tie into Microsoft Teams or WebEx or Slack. And you can have all that information shared there and interact with it in real time. I think, Dave, you had a good example of some prompts as well.
Yeah, sure. So like Bernie was saying, obviously these are some that you can start with. But as you mature in what you're asking, and I'll just use Claude because that's what I'm in pretty much every day when I'm working with ThousandEyes and MCP, I just jump out to Gemini, and I'll have Gemini create a prompt for me. You get used to conversing with the ThousandEyes MCP, and you're going to ask some pretty direct questions, and you're going to get a somewhat limited response based on what model you're using, of course, right? But instead of doing that, go out and get something a little more complicated, more thorough, and you can also do that as well. That way you're saving on tokens with your API calls as well.
Exactly, because we all know tokens cost money. So let's just talk about the server configuration real quick. I don't have a bunch of details in here. If you look at our documentation, it has a lot more. But what I really wanted to point out is that if you're using something that doesn't support streamable HTTP, you're probably going to have Node.js installed, npm, npx, and you're going to need to use your basically your OAuth bearer token, and that's going to be the method. But we also have a lot of plugins and things like that that work with using DCR, so dynamic client registration. So if you use something like Cursor, which I'll show in a minute, basically, that'll pop up a browser, and then you'll auth, and based on your auth, it'll share the token in the back end. The API rate limit I want to call out in the bottom there, if you use the OAuth token, your org has 240 calls per minute per org. If you use DCR, that's per user. Now, if you start running into issues, just open a support case. They'll be more than happy to increase your limit. So if you have like ThousandEyes integrated into Catalyst Center or something like that, chances are if you have those kind of integrations, that starts using the same API for your org. So just some things to think about. Or if you're using a service account and everybody's using the same service account for their agentic operations, you might have to increase it as well. But we're happy to update it. This is just where we started as the default, and for so far, most folks haven't hit it. If you're using Claude Desktop and you have the free version, you do have to use the actual desktop client itself. You can't use the web version for free to do this, but if you're using a paid version for free, you can add it very simply into just your connectors. We're not in the market space in Claude yet, but once you do configure it, be sure to allow the tools to run. That's kind of a got you, otherwise the tools don't do anything if you hadn't said they're good to go. In Cursor, we have a plugin. Today, if you're using Cursor and you start asking about ThousandEyes, it'll actually prompt you to install the plugin. There'll be a little ThousandEyes logo. It'll be there. You just click on it. Again, it uses the plugins use DCR. If you don't want to use DCR, you can actually just change you can update the MCP JSON, add the config. All that's in our docs. So with that, let me pop over to a quick demo. So again, let's see, does it share out? That's kind of interesting. Stop. Choose content, entire screen. Odd. Oh. How about there? Is that better? You guys able to read that okay, or did you made it bigger? Okay, cool. So the first thing that you really do is you start off, again, like I said, ask what tools you have and ask how to use them. So this created a really simple, hey, I actually have 2 MCP servers. I totally forgot I had staging. I probably should have disabled that. Obviously, there's more tools that we have in the queue already ready to go. But looking at those tools, it'll categorize them for you. Let you know you can do instant tests, synthetic tests, alerts, things like that. What it did here is it created this kind of cool canvas for me. And this is something that I really like about the way AI tools visualize different things. I didn't ask it to do anything other than just ask it what tools I had. And here I can see, show me the prompts. Here's the prompts that I can use for this particular, for running instant tests. I want to do agent to server. Again, all those tools are categorized. Here's my synthetic tests. Here's examples of how you can use the tools. So it helps you learn how to use it right out of the box. Again, the reasoning model is what's helping interpret what those tools are. We're telling it what tools are available and what the tools can do, and the reasoning model gives you the extra context. I won't go through all of those, but I do recommend, when you're using them, give that a try. The next thing I did is said, hey, do I have any alerts that occurred in the last 8 hours? Because typically, you're looking at a period of time, so time boxing, it's a good idea, rather than, since the dawn of time. And here it went through, it did the analysis, said you had 23 alerts. There's 2 that are active right now. These are what they are. These all cleared, so you don't really have to worry about those too bad. And then it recommends down here, hey, this PAX retail demo cluster looks like these occurred. Would you like me to investigate them more? Because there's this network loss cluster that kind of occurred at the same time. So I was like, yeah, sure, let's just go ahead and dig into those, because I'd like to know, is there a particular resource that's causing this problem that I need to dig into, and maybe something's intermittent, maybe that router rebooted, maybe it was, the memory was constrained, or there's QoS that's occurring. So I went through and investigated that. And again, if I had, say, the Catalyst Center MCP server put in here, I could pull in context from Catalyst Center or things like that, or Meraki. But it said, hey, the root cause from this WAN, was this routing reconvergence that occurred. Here's your router that you need to look at. Here's the whole timeline that occurred associated with this outage. And then it gave me some immediate actions. I didn't ask for troubleshooting steps. It just gave that to me. So this is another thing that I think is really powerful with the reasoning model, is its ability to provide extra context to help you resolve problems. Now, you could ask for detailed troubleshooting steps, and Bob's your uncle will give it to you. It's pretty awesome. So let me come over here. I'll show you. this is where I went through, and in the same environment, we have end users who are connected in with their laptops. They have endpoint agents that are running, so we also can tie that data together in context. So I was like, can you look at all my users and provide a list of users that are having bad Wi-Fi performance this morning? I didn't specify anything about other than just bad Wi-Fi. I didn't tell it like what good or bad looked like or any of those things. It's already got that as part of its model. So, and again, I'm just using Claude Sonnet, just the out-of-the-box model, nothing special. I mean, obviously it costs billions of dollars probably to create, but at any rate, here it came back with, here's my critical folks that I should probably pay attention to and help out first. Here's some folks that had degraded experience, and here's an interesting breakdown. And again, it created a canvas. I didn't have to ask it to. Created this awesome visual that I can use to like see exactly who my critical users are, what their experience is. Here's all the metrics. I could have asked for more metrics if I wanted to, but I just wanted to keep this pretty high level for this. And it already knows, again, what good and bad is. I didn't have to tell it. And then it said, these guys really are having a bad day. These other folks down here, they're kind of probably grumpy. From that, I was like, well, we should probably work on this. So I said, can you create a ServiceNow ticket that includes those critical users, include some troubleshooting steps for the engineer when they get on, or the help desk person's going to have to call the grumpy user, so they already have a plan in place, and include the SSID so I know that location. I could have, again, done like heat map, any of those kind of things, but it went through and it created this ServiceNow ticket for me, included all those steps, added those users, and assigned it to my favorite network engineer, John Adams. So he now has ownership of that and can move forward with those troubleshooting steps. And again, this took me just like minutes to go through and do this. I just didn't want you to have to watch the prompt spin. So with that, again, you can find our documentation here on the ThousandEyes MCP server. And this will like get you started. There's a getting started guide as well as the actual docs. I mentioned before doing a post-mortem, for example. So there was a Slack outage, and this link is also in the PDF. But it'll explain the exact prompts that I did to do this. But again, I was thinking, well, how long does it take to do a postmortem? And usually in the past when I was doing this stuff, it would take me hours to do, sometimes even days to pull all the data from all the places. Again, this used ThousandEyes data to create this. It created this executive summary for me. It went through, gave me all the different services, said, here's your timeline that occurred. Here's the root cause analysis. Here's my key findings associated with this. Here's my business impact and recommendations, all off of me just asking it, like, can you provide a concise postmortem that I can share with an executive leadership, including the application and duration of the outage? That's all I asked, and it created that. So I thought, man, that's pretty awesome. And of course, I showed this to some of my SE friends, and they made something way cooler. So they decided to one-up me. There was a Microsoft Teams outage. It lasted for about 15 minutes. There was HTTP server 500 errors that occurred during that time period. It affected 55 agents, 419 different locations, and it was pretty severe. Here's the incident timeline, so looks a little cooler. Here's my affected test that I had running that we flagged associated with this. Here's what this looked like before the outage. Here's what it looked like during the outage when people were pretty grumpy for about 15 minutes. Here's what it looked like as it started to recover. All this was done with a prompt in a matter of minutes. And it starts to talk about the recovery phase. Here's all the locations that were affected. Here's my root cause associated with it. And down here, here's my recommendations that you should follow afterwards to remediate this type of issue and help you out in the future. Again, all that was done with a simple prompt, interfacing with ThousandEyes, looking at internet insights, and some tests that we had running. So the other thing we started looking at is how can we make live dashboards that really help people see what's going on in their environment? How can we make it really cool, really simple, really quick? So we started iterating on some prompts, and this is one that was basically for healthcare, but you could again do this for retail, for whatever your industry is. You can use now that we have access to tags, you can use those tags to align with the data so you can slice it and dice it however you want. And you can make it very interactive. So here I can see overall what that average performance is of all the users over time. And then down here is the list of my application personas that I have would be based on the tags, so I can kind of divide that up. And then down here is, all right, well, here's worst performing so that I can work with them, and who really needs some help and attention. Again, you could link this into internal systems if you want. And then as you come down, we start to have some device metrics, and then again, categorize each one of the different groups in the way that we want. And then we can start to see up here, like, well, let's take a look at by location. What does this look from remote users versus, my SLTs? And then be able to see that all, again, filtered in context and have like an actionable dashboard with real data for like the senior leadership. Because usually you have a VIP set that you really need to deal with. Or maybe you have folks that call in a lot and you really need to have in that VIP list. So you create that and you add that to that tag, and then you can have this automatically show all those things. As well as like, hey, look, here's a different set of briefing of like the data and recommendations associated with this based on the findings that we have. And this, again, is just a vibe-coded live dashboard that's based off of real data. We took that and decided to make a vibe-coded site. So the next thing was, hey, how could we do even better? Again, we could tie in Meraki data into this. One of the SEs actually created a really cool dashboard that has that, and we're going to be creating a Git repo in DevNet. So you'll be able to go to DevNet and then click into the Git repo, and we'll have all these prompts, and we'll start sharing out this code so you can do this as well in your own environment. And I think the coolest thing is, once you create it, it's not static. You can say, oh, well, I want to add this button, or things like that, and really update it in real time. So here's the overall availability of my entire infrastructure that I have. Here's all my business services on the side. Here's my end users. As I come down, I can click on any of them and see, okay, well, here's Al, and I could drill into ThousandEyes if I wanted to. Or I could, if he's associated with a particular site, which I'll show in a minute, I could just drill into that site and see that overall. So as we come over to site health, again, this is where having those tags and labels could help you out. You could have this building, this floor, for example, and tie that together. But I have all these different locations around the world that we're monitoring. In this case, I'm just going to start with San Jose. Here's my overall health. Here's my business services based on collaboration. Any of your business critical services that you're monitoring, you can create this type of dashboard with. And then as you come down, you can correlate that all the way down to, what's going on with DNS or any of those kinds, or BGP. You can tie it however you want. And then if you had endpoint end users, you could have that down there. One of the things that we started thinking about as well is, one of the SEs vibe coded in customer sentiment as well. So pulling from Twitter or places like that. Or if you have a call center, for example, you could pull in the call stats of what's going on as people are calling in from these different locations. So the last part that we did was, well, that's great from an operations standpoint, but maybe the execs need to see this because they kind of like to understand that they're signing their money off to different places and see what the investment in their infrastructure is. And know that you're doing an awesome job. You can share this out and say, look how awesome we run the network. And so here's the score overall. Obviously, they like it to be green and 100%, but things do break. Here's your network availability, your packet loss, what incidents are open, things like that. Here's all my business services and health. And then down below, here's my top issues that we're working on and active alerts. And again, you can tie in third-party data sources. You could tie in ServiceNow into this, have a list of tickets, things like that. Create a workflow where they could dive into another dashboard or any of those kind of things. But all of this was, again, vibe coded and just created, on the fly to provide a really good way to visualize the data. Because there's a lot of knobs and dials in ThousandEyes, and we have a lot of great data. But making it simple for an exec or for the NOC to digest really quickly and troubleshoot is what we wanted to do. So let me pop back over, and we'll go back to play from current slide here. See if this works. All right. So now we'll dive into the agentic ops side of the house. I think this is where folks are probably going to be pretty excited, if you weren't already pretty jazzed about what I just showed. So from an agentic operations standpoint, really, it's allowing autonomous AI agents to observe all those network conditions, all those different metrics, all those different various data sources, and make intelligent decisions that, can take actions to, optimize your workflow, optimize your network, help your users out without requiring human intervention. Now, obviously, the first pass, usually as you're doing this, you'll have human in the loop. And then as you start to trust it, then you open it up. So those routine tasks of, hey, look, we had this cert that expired, and all it takes is to refresh the cert and then reapply it, restart the service, automate those things, like make them go away. Look at your tier one things, the things that people have to do that are monotonous. Pull that data out of ServiceNow or whatever you're using to track that. Look at those things, do that analysis, and start thinking about how do we like automate these pieces. And I think that's where we're at today. A lot of folks are already doing a lot of this, but having autonomous monitoring to continuously observe those network performance and application health and really get at what the user experience is across your environment to make it more healthy, and use that intelligence analysis to look at all the metrics that are there and those details and predict where those issues are and start to help you get ahead of things before the user even knows there's a problem. Because I think the best thing is when a user comes and says, man, I didn't even know your team existed because the network always works, is a great day. And determine what the appropriate response is. Obviously, don't go make changes just to make changes, because that's not a good thing. And then that autonomous response takes those corrective actions for you. It notifies the team so it can log everything into ServiceNow or whatever your ticketing is. Have that ability to go back and mine that to make sure that maybe this is something that's noisy that's happening a lot, and you could go through. Maybe it's just that device needs to be patched, and your autonomous agent is going through and making these changes constantly, and it shouldn't have to. It's more like maybe that's a firmware issue, or maybe that application needs to be patched or something like that. And ThousandEyes' role really in that is to provide that comprehensive visibility so those agents can make informed decisions with that data, that contextual data that is giving them the reference of what's going on. And so when you think about why this matters, it's the business impact, right? It's the speed to resolution. How do we make things faster, resolve things before people notice, take things from minutes or hours to like seconds, detect and analyze that, no matter what time it is, and reduce those operational costs so that, thinking about all the things your tier ones do and those triage things, or those, hey, like this escalation comes to me and man, I just have to log into that and I have to make this change and I do this every day, and you can automate all those things. And that allows you to have the time to do the cool stuff that you want to do versus respond to a ticket and do those things. So free yourself up to go explore some new technology. Or design a whole new process. And also 24/7. I know at like 2 a.m., you probably don't want to get up and respond to an alert where you have to go make a configuration change or something like that. You can automate those things. It'll automatically detect, run off, or again, if you have human in the loop, you can just say, hey, that tier 1 tech has the ability to run and escalate that, or run that. It's just going to ticket it and close the ticket for me. And then as you think about those technical advantages, correlating across multiple data sources, again, you can tie in third-party tools to this. It's really fairly simple. And combine that so that you have a holistic view of your network and your environment, and use the data that's at your fingertips so you're not having to context switch between a bunch of different things and remember what's going on and then try to correlate that together to go make the change, and then gather that afterwards into the postmortem. Predict those problems as well. So start to see where there's, maybe some sort of degradation over time and get to them before an SLA is violated. So again, maybe there's, some sort of queue that's starting to get filled up that was misconfigured. That starts to trend up. You can start to get ahead of those trends and create intelligent filters around your alerts and reduce that signal to noise, right? Because if you have a noisy alert, nobody ever responds it. Why is it there? So we're actually releasing a deep reasoning agent within ThousandEyes that you can just say, hey, go through, do my alert analysis, tell me, find the noisy alerts and help me resolve, how do I tune my alerting and things like that. Because, again, garbage in equals garbage out. So the last piece here is really that continuous learning process too. So as you start having these agents do these things, being able to categorize that and store that somewhere where you're taking those pieces and tying them back in and learning from them how to be more effective, how to be more efficient, how to use those same reasoning tools. And Dave in a minute will have a great use case that he can share on some of that. But as networks become more hybrid and more critical to your infrastructure, networks obviously have always been critical. That's the foundation. And of course, it's never DNS either. But having all that tied together really makes it easier for you to monitor those complex networks and make those decisions and automate those things to resolve those problems and have the data be more actionable intelligence, at machine speed versus, hey, I have to go log in here, log in there, gather this, do this stuff, put it in the ticket, and then find that Bob's the only person that can make the change. So when we think about agentic ops, this is more of like a chat ops, but I'll get there. This is like, hey, tell me what's going on open the ServiceNow ticket and tell me what's going on with Boston. So having the agent go in, and the agent goes ahead and says, all right, this user wants to know what's going on with Boston. They're getting a bunch of calls, complaints, things like that. Let me go use the tools that I have access to. So one, I'm going to create that ServiceNow ticket to track everything that I do and to track the users that call in. I'm going to take ThousandEyes, I'm going to pull all the data from Boston that I know that ThousandEyes has. Maybe I have Splunk, maybe I have Catalyst Center. This is just kind of a sample, but use all the different tools you have access to. And then now go over and use the agent to resolve that or create a plan about how to troubleshoot that and have an answer back to the user that the user gets in whatever, whether they're using WebEx or however they're wanting to interface in. You could use the Now Assist agent to do a lot of this as well within ServiceNow if you wanted to. You could use Microsoft Teams, WebEx, whatever you choose. But this would be more like a chat ops-based agentic op workflow. So let me skip over here. Well, actually, we'll go forward a little bit. Let's just talk about a quick use case, and then I'll show a demo. So we have set up a WebEx space here, and we have ThousandEyes monitoring some sites. That alert kicks off when that site is having a problem. The alert goes into a WebEx space via webhook. The webhook then gets processed by a bot that's watching for that. So when it sees that incident, it goes off. The orchestrator app goes through, processes that alert, and says, hey, I'm going to go look at these different things from ThousandEyes, and I can do things like create an incident report. I can search through global outages. I have a bunch of different tools. I'm going to use Claude as my reasoning agent to go through and do that analysis for me. And this is really the core of what you can do from an agentic workflow. All this stuff happens without a user's interaction in any way, shape, or form. The alert happens. Those things kick off. It pulls more data in context from ThousandEyes using the MCP server. Claude knows, like, hey, tell me what tests I have that are aligned with this alert. Help me do that root cause analysis. And then it also logs all that into ServiceNow. So you have the entire process that it's doing logged in ServiceNow for you as that back out to see, well, what did it do? And it does the entire triage for you. So I'll go ahead and show you an example of this, because otherwise it's probably not real, right? So here's an example. Here's my alert that kicked off. My bot grabbed that and started analyzing it. So it says, hey, I'm working on this. It came back and said, here's my alert analysis. And you can see this happened at 11:01. At 11:01, it's already triaged this. It's done all this work for me. It's gone through. It's grabbed the issue summary. It tells me what affected resources are being affected. Here's the initial assessment of what it sees, like the ISP pattern, the different correlations. It's completed its entire piece, and then it creates this tag down here where it's like, hey, would you like to open a ServiceNow, create a ServiceNow ticket or attach more information to that? Would you like to do a global search for global outages, those kind of things? Simultaneously, as it was doing that, it also created an incident report for me. So, if there's an outage analysis you wanted to do, here's your report for an executive summary of what's going on with this, and has the timeline and all those pieces. And it's obviously a few pages long. We could probably make it more condensed, but again, all that happened without human interaction in any way, shape, or form. And if you had some sort of remediation tool, obviously, if you look back, you'll see the alert clears. So once the alert clears, then we're all good. But again, that happened in a minute. Like, to troubleshoot something like that, you're going to have to go log into a tool. You're going to have to run some different things. You're going to have to do the analysis, look at the time slice. You could use ThousandEyes AI Assistant to do basically the views explanation and provide the root cause for you. But the agent did all that for you on the back end. So that, Dave, I think you had a couple of great stories. I'll cut it over to you.
Yeah, thanks, Bernie. So that is a lot of terrific content. And what I can tell you is I'm the administrator for ThousandEyes at Lilly. And when I took over the tool about a year ago, I started thinking about ways of how I can improve my environment. And at the time, before I really started using MCP, that was pretty much agent proliferation, right? Try to spread the thing out, use as many licenses as I have to try to grow the tool. And I accomplished about this much, without MCP. And as soon as MCP came into the picture, everything that I was doing just absolutely exploded. And when Bernie's talking about the prompts and, letting the tool actually do the work, I work pretty much exclusively with Claude. So what I started out with, as I mentioned earlier, is this prompt from Gemini. And the prompt from Gemini was, in a nutshell, look at my environment, the real environment, live, and go through, analyze where you think I'm doing well, tell me where you think I can improve, and build it in a report card fashion. So what it made for me was an actual report card with a grade. I've got a B+ right now, so just for full transparency. But I told it, give me some of the things that will help me mature this environment over time. I actually run that report card for myself once a month, and I look at it compared to the way that it was in January. And I didn't ask Claude to do, like Bernie said, 90% of the stuff, it just kind of intuitively says, well, if you want a report card, then you're going to need to have these things. Where are you right now? What are some things that you can do right off the bat that are easy wins, right? What are some things that are a little bit more difficult, and it labels them as such? And then here's what you ought to be thinking about in the next quarter, right, in the next couple of months. And so from that, I created a score improvement plan. How do I get there? And it was like, okay, well, you could do these things and it'll add 0.04% to your overall grade. That's the biggest opportunity you have right there. And it's a low effort, everything else like that, just iterating over and over, starting off with that report card. In the end, where I really got to was letting Python do a lot of the work for me. So I'll skip the initial failure that I experienced, and I will go on to tell you that the score improvement plan that I came up with, it's an HTML-based document. With each one of these suggestions, I told Claude to embed a checkbox. And so when I have it analyze the environment once a month, it comes out with a handful of suggestions, and I pass that to my Cisco team and say, would you please, put a second set of eyes on this? This is what Claude says of my environment through MCP. Again, it took 2 minutes to generate all that information. So when I pass it by Cisco, the support team takes a look at it, we talk about it, and in the end, what I have to do is what we agree on and what I think makes sense. I put a check in the box, and I coded it into Claude to put a submit button at the bottom. When I click that submit button, it builds the Python code for the choices that I made. And I'll skip over the initial failure that I had was my own fault. So I built in a lot of error checking to this Python script. So the Python script will do a dry run before it does anything. It will visually give me red X's and green checks for the things that are going to fail or pass. It prompts me in the middle, yes or no. I'm running it from terminal on my Mac, whether I want to proceed. If I do proceed, it goes ahead and runs the scripts, makes all the changes that we discussed and agreed upon. But in the meantime, it also creates a backout script, right? It creates an audit log that it can read to look at any errors. And when it's all finished and I like it and it's been executed, I've got a GitHub repo. I initiate my command, pushes it all up to Git so that I've got a record of everything that I did. And again, the use of this has just exploded. I went from there and said, why is this running all by itself, right? So Claude Desktop, Bernie was mentioning utilization of other tools. We have other tools in our environment that, do a lot of telemetry. We've got tools like Splunk, whatever else. And so what I started doing was, I want you to tell me what you know about this event from every system. So we've got one system, Logic Monitor, that we use as our primary telemetry. And it can go through and say, yeah, I see that. Here's what I know about it over in this system. And over in this system, here's what I know about that event. We pull in the ServiceNow ticket, and like Bernie was showing, we've produced minute by minute, events from each system. Claude, again, didn't ask it to do it. Color-coded by software package, like Logic Monitor's one color, ThousandEyes is another color. Color-coded by criticality, so I get a really nice report. I can tell it whether I want it to executivize that one or make it technical enough for our team to go look at it in a post-mortem. That morphed into, why is this a human-driven thing? That's not where we want to be, right? So I came up with the idea of this war room. That's going to be buried into a new front door that we're designing up in Amazon. And so the war room is going to watch queues, right? So it's no longer a human thing, right? It's an event-driven thing, whether it's EventBridge or Lambda or whatever. You can do it 10 different ways. So when a qualifying incident comes in, let's just say that it's a Sev2 in one of the queues that we manage, then the event goes out and sends the MCP server connections to do their job, and it brings back a cross-application report of, here's everything I know about this problem. Here's when this caught it, here's when that caught it, da-da-da-da-da. Recommendations at the bottom, here's if it's got it already, like root cause analysis. If it doesn't have it, here's an executive summary you can send to your boss to tell them what's going on. This is what we know at the moment. This is what the most likely cause is. And guess what we do with that information? Well, in the war room, we automatically spin up a Teams channel. Hopefully, the goal is that we look through our company directory and we've got people that are SD-WAN experts. We've got people who are working on the other levels. We want to mention those people and get them in, right? Don't invite 25 people, invite the right people. So we spin up a Teams channel. We've got an Anthropic API that goes out that gives them their chat space, all in one little consolidated war room. The webhook data comes in from ThousandEyes about the alert, and it'll show all the agents, all the locations that are impacted. And every time there's a change to that, when the test time comes around again, if an agent comes on, drops off, then that data changes. And ideally, what I wanted to happen with the war room is, as people, the right people, again, are in this incident, running it down, there's a network map that automatically gets created. Bernie, you were talking about the map that you're showing gets created at event time. So that's 0.0 seconds, right? As soon as the event gets noticed, it starts building this network map based on what it knows from all of our tools put together. And as that event matures, changes, goes away, as people are running down the problem, the map changes, it gets refreshed, and until the problem is solved. Once the problem is solved, the Teams channel gets torn down. We take all that data, all the conversation, everything, we put it up into something like S3, so we know about it the next time that it comes around. The next time there's an event that happens, one of the things it does is go right up to S3, check that out. Did we run into this before? If so, when? How did we fix it? Who fixed it? And why didn't we log a problem? We'll get there. So that's being implemented right now. We hope the full solution will be out in just about a month. But those are just
frogs you so much far. Far forward.
And some of these are just afternoon things.
Yeah,
they're just afternoon discussions. Really.
Yeah, no, that's awesome.
Did you want me to talk about the change thing?
Yeah, if you can talk about the change piece too. But I was going to just point out, this Postgres database up here, this is kind of what that's designed around, is categorizing what those steps were that were used to resolve the problem. So the next time that happens, you're already pre-gaming the system with here's how we resolve the problem, which is what Dave was mentioning as well. So I'll cut it back over here for change control because that's pretty awesome.
Yeah, and the stuff that I just described are the things that I'm kind of in charge of doing, so I'm proud enough of those, but they're paling in comparison to what one of my buddies has done. So we've been kind of working closely together. Paul Richardson's one of my colleagues at Lilly, and we actually caught a change request that went bad. One of our operations teams implemented a change, and it just destroyed part of the network. And so we pulled that ServiceNow ticket into Claude. We looked at our Logic Monitor instance. We looked at our ThousandEyes instance. We put all that data together. And as far as it knew, we hadn't done this yet. It was smart enough to figure it out. But we did it after the fact, just to see if it would predict, right? So Logic Monitor's got BGP data. It's got LODP, everything else like that, neighbors. And ThousandEyes knows the route, everything else like that, which would be expected. And it actually spit out an HTML-based reports. I love those, by the way. So you can do stuff in PowerPoint, Word, and everything else like that, and it takes a little bit longer to create it. So go HTML. That'd be my recommendation. But the HTML told us exactly what went wrong, and it was exactly right. It was if you do this change right now, you will break this, this, and this. And what's more, even without asking it, it said your testing plan is insufficient. It doesn't do this. Your backup plan is not present. It doesn't do that. And so it made suggestions. If you're going to do this, this is the way you should test it to confirm it. This should be your backup plan to make sure you take care of everything that you were trying to do. Completely amazing. And if we mess up one of those things, like anybody in any other industry, then you know what the cost is monetarily. You know that you could lose, these number of dollars if you don't do these things right. So we are, because of MCP and because of this functionality, we're totally shifting that stuff around, so much so that we may provide another front door for people who have process user to go into ServiceNow and do these things. We may create an agent gatekeeper, right, to say, you can't move forward into the next stage until we say that this is good, that we know you're not going to break anything. And when we started looking at it, we added some things on hey, when I see this script, insert in that HTML kind of a teaching moment. Like, you wrote this, and what you really should write is this. So we made some teaching moments in there to help train people as they come up. You know, engineers don't just start out being experts. So it's really cool, and that's going to be implemented here again probably in the next month. So we're absolutely relying heavily on MCP, and I still think there's a long way to go.
Sky's the limit. We're just getting started.
Absolutely.
I think the other thing, too, to think about this is like a pre-mortem. You can ask before you do something, what are all the different things that I should think about that could go wrong? Prepare for that, because Murphy's Law happens. Stuff breaks. Be prepared. And that's ultimately what you can do now based off of your post-mortem analysis that you did off of some learning time. We'll wrap up here real quick. I'm not going to cover all this, but I just wanted to show kind of like that workflow that I showed within a couple of minutes. You can create a workflow from ThousandEyes through ServiceNow to automate and resolve issues or have human in the loop to do that. So this would be something that is completely possible and would not take all that long to really create. The slides will be available as well, so you can grab the PDF. I'll leave it here for a second. And as you start think about turning network intelligence into actual outcomes, really ITSM, adding your ServiceNow instance or whatever you're using into your ThousandEyes MCP to streamline those operations, using conversational, AI-driven workflows. I think you can see what that intelligence of having ThousandEyes network data associated with that to drive those accelerate those incident responses. Really, it simplifies so many different things, and you can autonomously resolve incident responses using MCP. And ultimately, again, it's secure, and you can expand the users that are able to see that data, as I showed with the executive dashboard and those things. There's some other sessions. Feel free to go over to Walk-in Labs if you want to get your hands on. There's an MCP lab over there. You can actually see the difference between using APIs versus MCP tools. Also, Capture the Flag has some great cases. Make sure to take care of your session evaluations. I always love getting feedback, so would love to hear from y'all. And continue your education. But thank you very much.
Thank you.
All right, good afternoon, everyone. Thank you for joining today's session on no-code network automation. Instantly respond to network events with Cisco Agentic Workflows. I'm Ed Novak, a technical marketing engineer for Cisco Workflows, and I'm so happy to have you in my session this afternoon. And my clicker is not working. There we go. Okay, before we begin, I would like to remind everyone we do have a WebEx space dedicated to this session. It's a chance for you to ask your questions you think about after this session, or anytime over the next 2 weeks. I will be monitoring the space. So please, if you think of a question later on, ask the question there. I've been a technical marketing engineer at Cisco. I've actually been at Cisco for 25 years. And I've worked with a lot of different new and exciting technologies. I can honestly say that agentic workflows is the most exciting thing I've worked on in that career, and I've worked on a lot of different things. I'm also a bit of a certification geek, and I've taken my lessons learned from certifications about putting together a good training plan and following that plan, and then 2 years ago, I started running marathons and then ultra marathons. And actually last year I was out in Page, Arizona. I did the Antelope Canyon Ultra out there. If you ever get a chance to go to Page, Arizona, it's the Antelope Canyon. The scenery is just unbelievable. So today we're going to do things a little differently. We're going to talk about network automation from an ultra runner's point of view, because I have a lot of time to think about things when I'm out there running these miles and miles. So we're going to ask questions about network automation that I ask when I'm getting ready for a new race. Like, is there a review of this race? And I'm going to do a live demo of this technology for you today. What are the race details? In this case, what is a webhook? I know some of you are not familiar with webhooks. Some of you are. So this is going to be a webhook 101. We'll talk about what is workflows as well. We'll talk about what's the cost, and you're going to like the answer to that question today, I guarantee it. What are the frequently asked questions? What are the aid stations that can help me get started with workflows? Is there a training plan I can follow to get started with workflows? And we'll do a chorus review here. We'll actually do some real-life work with workflows and the webhooks. And of course, I got to keep in mind my cutoff time. My timer is running, so let's get into it. Before I do, though, I just want to talk. Anybody here is familiar with Catalyst Center and workflows inside of Catalyst Center? Okay, a few of you. Now, before you guys get up and leave, because I'm going to tell you that the workflows I'm talking about today is not that workflows. I'm talking about agentic workflows that's available inside the Meraki dashboard as the automation menu, or now also available natively inside Cisco Cloud Control as the workflows menu there. So just because it's not Catalyst Center workflows, however, this agentic workflows can do operations inside of Catalyst Center. There was a great session this morning by Keith Baldwin who drilled into that in detail. So let's start out with a live demo. How about that? I'm going to jump over into a system. And these are use cases that came from real customers. So here I'm in Cloud Control. I'm going to jump down to my Meraki dashboard. And so this first use case came from customers who had a bunch of different branch locations with stores. And they offered guest Wi-Fi in their stores. And their problem was, if they lost their primary internet connection and they switched to cellular backup, their guest Wi-Fi was driving up their cellular bandwidth utilization. They said, hey, is there a way we can disable the guest Wi-Fi when we're on our cell backup? Okay, that's a reasonable request. You can do that. There's a network event for that. A network event can use a webhook. A webhook can trigger a workflow. So let's do it. So here we see our guest Wi-Fi is currently enabled. I'm going to try to pull up my terminal window. Here we go. I'm going to give it a command right here. So this is a webhook. A webhook is nothing more than a web request. You see up here, I'm just using curl, and I have a URL right here. But the bottom line is we have a failover event to uplink 1 taking place. And if I jump back into my browser window, I'm going to go down to the automation tab and look at the rules area. And I'm going to look in my history. And I see right here at 3:03, there was a disabled guest Wi-Fi event that took place. And if I look, it was a failover event for uplink 1. And I look right up here, there was a run. Let's click on that. So this is inside the workflows environment. It shows me the workflow that ran. It ran successfully. Let's take a look in that workflow, get the details of it. And then zooming in a little bit, I see a visual representation of the workflow as it ran. And right down here, I see primary WAN link down condition branch, set guest SSID state to false. And down here, it did some other operations, updated guest SSID. So the blocks in green ran successfully. The blocks that are grayed out weren't executed also. Again, a visual representation of the logic of my network automation here. So let me jump back over into the wireless area and take another look at my SSIDs. Come on, there we go. Okay, and we see now that the guest SSID has been disabled. So let's jump back into my rules tab. Come on, there we go. And give me 1 second to grab my next curl command here. So rather than wait the 5 or 10 minutes it can take for a device to detect that, I'm using it manually using a curl command. And again, it's nothing more than an HTTP message. So again, HTTP to our URL. We see another failover event here type. Uplink 0 has taken place. Jumping back in to network operations. Let's see here. Let's refresh this page. There we go, 3:05 p.m. Another enable guest Wi-Fi event came in, and right down here we do see it was uplink 0, so it's gone back to my primary WAN interface. And then clicking on the run view, we see the workflow that was selected, it actually ran successfully. And again, I can get all the details for that particular workflow here. And if we zoom in a little bit here, we can see that primary WAN link up condition, enable guest Wi-Fi took place. Scrolling further down, we see it enabled the guest Wi-Fi. And if we jump back into our SSID page, and we do a refresh here, there we go. My guest Wi-Fi has been enabled again. So that's what we're talking about here with using webhooks and network automation. So with that, let's jump back into the slides. And start with the details. What is a webhook and what is agentic workflows? So webhook 101. A webhook is nothing more than a mechanism that allows you to send notifications to another system whenever an event occurs, like a WAN interface going down or a device going offline, for example. It's used instead of polling. So instead of constantly asking, hey, anything happened? Anything changed? What's your current state? You just say, notify me when something happens. It's nothing more than, call me at this URL when an event takes place. It's a web request. We make web requests every single day when we're using a browser. And so here's some references. These will be available in the slides. Again, the slides will be available in the Cisco Live app for this event or this session. So what does a webhook look like? Well, this is an example of a Meraki webhook request body. Again, if you go to those URLs on the previous page, the references, you get plenty of examples. But you see the details are in here, which network it was, what device it was, what time it took place, other details about that. So you can then use that information to make a determination of what type of automation needed to take place to perform whatever type of network operation you need to do. So let's get into what is Agentic Workflows. Agentic Workflows is nothing more than cloud-hosted automation tool available inside of the Meraki dashboard since October of last year, and now also available inside of Cisco Cloud Control. Now, it's hosted inside the Meraki environment, but it's not just for Meraki automation. You can automate Catalyst Center, Catalyst SD-WAN, ICE, Umbrella, ThousandEyes, FMC. There's also third-party integrations built in natively to workflows, things like NetBox, InfoBlocks, ServiceNow, Jira. Anything with a REST interface, there's generic REST applications in there as well. So lots of functionality there across Cisco, a third party, and also AI integrations as well. You can have pre-built automations in there from something we call the Workflows Exchange. It's a catalog of those pre-built workflows you can bring into your environment and run those as is, or open up in our simple low no-code editor to drag and drop and customize them. And so today I'm going to show you examples of 2 workflows that are available in the Exchange. We're going to install them into a network, configure a webhook for them, and then trigger those webhooks. The whole purpose of workflows is to eliminate those repetitive manual tasks by making APIs as simple as drag and drop. So if you've been working with Meraki for anything more than a year, you probably remember Cisco Live last year when the Meraki dashboard changed from green to blue. So that was all part of the common user experience. The Meraki dashboard and Catalyst Center are coming together into a common user experience. As we see now with Cisco Cloud Control, we have a unified platform that starts bringing all those different domains together as well. I'm part of the workflows team. That's the common automation effort across Cisco. And so there are different teams at Cisco that work on the same common automation software engine. If you've done any work on security, you may be familiar with XDR Automate. Our team is partnered with the XDR Automate team, that engineering team. We both contribute to that same common software base, so that allows us to accelerate our feature velocity. But we still maintain our individual domain focus. They're focusing on security incident response. We're focusing on network operations, so day 0 configurations to day end configurations. So what can you automate with Cisco Agentic Workflows? Well, I've already mentioned right here at the top of the list, you see HTTP. So anything with a REST interface, it's good to go. Right below that, you see Ansible. Down towards the bottom, you see Terraform. So if you already have some existing automation, either one of those 2 platforms, it's not throwaway work. You can trigger those from workflows, and now you have a central dashboard that can audit everything that's going place and automate commonly across all your different Cisco domains and third-party tools as well. Of course, you see the Cisco domains. I've listed them earlier, and those third-party tools as well, and some AI integrations here. You also may notice down towards the bottom, you see a terminal endpoint. So if it doesn't have a REST interface, but I can only reach it through SSH, you can actually add that into your automation tools here as well. I've mentioned that Workflows Exchange, that catalog of pre-built workflows, and we're going to use some of those workflows today. So here's a chance to get those pre-built workflows, run those as is, or as we often see with pre-built tools and network automation, the way somebody else does it isn't exactly the way I do it. I have this setting that's different, or a couple settings that's different. So it's 80% of what I need, but not entirely what I need. Great. Open up in the editor and customize it to meet your need. You have the foundation right there. Just build upon it. Don't reinvent the wheel here. You will see 3 levels of offers in here. You'll see Cisco Managed, Cisco Verified, and Community. All 3 of those go through the same pre-publication review. So we review them for malicious logic and things like that. So you can have confidence in anything inside of the Exchange has been reviewed by Cisco. Really, the only difference is the support model. So Cisco Managed, those are supported by Cisco. The Cisco Verified, those are supported by Cisco partners. And then the community ones are by the community author or community member at large. But again, if they don't meet your need entirely, but they give you 80%, it's a reusable foundation to build from. You have your workspace. I call this your collaborative automation environment. You see your status of a workflow. You can edit, you can run, you can share. You can import and export workflows as individual JSON files. And you also have the ability to connect into a GitHub repository and share workflows that way as well. Workflow editor. This is the heart and soul of the workflows environment itself. On the left-hand side, you have your panel of activities that are grouped by domain controllers, or we call them adapters. Underneath that, you have categories of API calls. So you can click and drag those individual API calls out to the canvas, drop them there, rearrange them. You have logic, so you can do conditions. These are your if-then statements. You can put loops in there as you need to, and then it may be a little hard to read, but that third column on the left there, that's workflows. So you can have workflows calling other workflows. So think modularly, build your workflow as a function, and then reuse it over and over again. On the right-hand side, you have the property window, and in the center there is the canvas, which shows you that visual representation of the logic of your workflow. And today, we're all going to be talking about automation rules. So we have 3 different types of automation rules you can use to trigger your workflow automations. A schedule rule, nothing more than a cron job. So Monday at 9 a.m., Saturday at 2 a.m., or every day at noon, run a workflow. Today, we're really going to be talking about webhook rules and how network events can use webhooks to trigger automations. But there also is an email rule where a workflow can monitor an email box. When an email comes in, that can be used to trigger a workflow. As I've seen in some other demonstrations here, you can also use the AI assistant to help you select and run a workflow. So that's great, especially when you have hundreds of workflows in your environment. You may not be sure which workflow you need to run. Have a natural language conversation with the AI assistant. Have it, limit your selection down to maybe a couple workflows, and then it can give you the content of that workflow and help you make the proper selection for the inputs for that workflow. And again, you can have confidence in the AI assistant running a workflow because workflows are deterministic. So deterministic means I give it the same inputs, I get the same outputs every single time. So when you're having the AI assistant run a workflow, it's not the AI assistant deciding this is the API call I want to use today. It's the AI assistant using a deterministic tool, just like calling a Python script, for example. And so how do you run a workflow? Manually, through the AI assistant, through our automation rules, or through our API. Complete flexibility here, whatever meets your needs. And big question now, what's the cost? Any guesses? Free, here we go, free, exactly. It's included. So ever since October of last year, you all have had access to this great, wonderful, free automation tool. Why aren't you taking advantage of it? So there's no cost here, so there's no risk to adopt it, to deploy it, utilize those Cisco adapters, have access to that full catalog of workflows in that exchange, that low, no-code drag and drop builder, and actually now AI-generated workflows as well since last month. I can describe natural language workflow and have the AI assistant build it for me. Some frequently asked questions. Hopefully you can help me answer some of these today. The first one is agentic workflows only for Meraki. Everybody should now be able to say no. The Cisco domains, third-party tools, anything with a REST interface. To connect to an on-prem device, so devices don't natively talk to the cloud, like a Catalyst Center, for example, does require the deployment of what we call a remote VM, a remote target. That's a 2 virtual CPU, virtual machine you download from the Workflows dashboard. It does currently require vCenter, but by the end of this month, we will have a Docker Compose version. And that calls back up to the cloud using MQTT, establishes a connection so we can communicate with adapters down there to make API calls to local resources. Does workflows count against the Meraki API limits? Yes, it currently does, but we are working on that. There is a mechanism built into the adapter inside of workflows that actually makes the Meraki API calls. So if it gets a back off message, it will back off and retry up to 5 times before it reports a failure message back to the workflow itself. And currently, how do you limit permissions on a workflow? So to start with, you do have to be a full Meraki organizational administrator to edit and run workflows, but by the end of this month, we will have more granular role-based access control for you to be able to limit workflows, so individuals who are like network operators can only run a workflow. They can't edit workflows, they can't do target configuration, they can only run a workflow, and since the workflow is deterministic and you can bound the inputs, so maybe there's no even free inputs, they just have a selection to pull down for variables, for example, when they're running a workflow, you can have confidence in giving them access to those tools. One thing I should mention, if you have any feedback on your user experience or new features you'd like to see added into workflows, in the bottom right-hand corner of the Meraki dashboard, there's the Give Your Feedback button. If you're anywhere under the automation menu and you click on that button, that feedback goes straight back to the workflows engineering team. So we do read every single one of those messages. And the more we hear about something from the customers out there, the more highly likely it's going to be added to the top of the priority list. So aid stations, when I'm doing ultra marathons, I look where the aid stations are so I can refuel, recharge, and make sure I can complete that race. You're here at Cisco Live, so that's probably the best thing you can do about getting started with workflows. Over in the world of solutions, we do have the Future-Proof Workplaces demo number 32. That is Agentic Ops. That's workflows. I will be there all day tomorrow, so please stop by and have a chat with me if you'd like to go deeper into workflows, especially the new AI agent activity. There's also a number of sessions here at Cisco Live. We're getting more towards the end of Cisco Live, so I only listed the sessions that are recorded. So if you didn't get a chance to catch any of these sessions live here, they will be available in the Cisco Live On Demand app about 2 weeks after the session here. For those of you who are automating Catalyst Center with workflows, you really want to check out the BreakOps 2379. That was from Keith Baldwin. Fantastic session. He is the expert when it comes to automating Catalyst Center. And then, of course, we have the Cisco community, so please join the Cisco community, community.cisco.com. We also have a YouTube playlist. So if you go to YouTube, search for Cisco Workflows, you'll find a self-learning lab series there on workflows, and I especially want to draw your attention to one of the lessons, which is all about using webhooks, lesson number 8. And of course, here are some useful webhook references and resources, links to automation rules, links to setting up webhooks, and also sample webhook alerts. I did mention we'd have natural language workflow generation coming. It's actually here now. That just launched last month. You can describe your intent, and these are some best practices right here. Cover your intent. Describe your input variables and the formats for those. Describe your output variables, those formats. Give your constraints, and then let the AI assistant generate a plan. You can then iterate through that plan. Add a step, remove a step, change a step. And then have it produce that workflow, open it up inside the editor, validate it. See if it meets your needs exactly, make sure it does everything you want to do. And if you need to, you can make changes to it. We do have a Copilot experience to be coming later on this year, so you can then have a conversation with the AI assistant inside the editor to update that. It's just not here yet. Let's get into our training plan here for workflows, webhooks, and automation rules. So starting off with, how do I create a webhook for workflows? Well, under the Automation tab in the Meraki dashboard, or the Automation tab for workflows in Cisco Cloud Control, you're going to find Rules as the bottom option in the submenu. You click on that, you go to the Webhooks tab, and you can click on the New Webhook button. And we do, a new webhook window pops up. There's only 2 things you need to provide for it, a name and a description. And I would encourage you to add descriptions to things, because if you configure it now, 6 months from now, or maybe a year from now, you may forget what it is. One of the new fields we do have is the API key expiration date. So the default expiration is 1 year from today. You can always go back in there and update that, but that was just recently added now that the API key for webhooks will expire automatically in 1 year. So once you've configured the name and description, you click Save. It will automatically generate your webhook ID and the API key for you. And once you have that, keep in mind that this is the format you're going to need to put that in when you're adding a webhook URL into the Meraki. And we'll cover this a couple more times, but you grab the webhook ID, which is the URL, the API key query parameter, and then the API key after it. Then what you use with that webhook? Well, we have to put it to a rule to associate it to a workflow. So we're going to go over to the Automation Rules tab, New Automation Rule. Again, we have to give it a type. There's multiple different types of automation rules, so we select webhook. We give it a title and description. We pick which webhook this rule is to be associated with. And then down at the bottom, down here, we have the webhooks. So, the workflows. There are some restrictions for these workflows. First thing is it cannot be a non-atomic workflow. It has to be a standard workflow. It has to be a valid workflow, and we'll cover this a little bit later. There's a validation step. It just means the workflow has all the proper inputs. And it does have to be a workflow where the target is set as specified. It's not specified for workflow start. So a default target has to be set for the workflow. And then we need to assign variables to the workflow. So that webhook request body that comes in, for a workflow that's being run from a webhook, they should have a single input variable. And right here, we can map that variable by clicking our variable reference icon right there. It brings up the Browse Variables window. We have our webhook rule where the request body comes in, and that's how we send that webhook request body into the workflow. And that's all there is to it. As we saw earlier in the demonstration right there, I can see the rule history. So every single time a webhook event comes in, I can see the webhook body that came in with it, and then the workflow that was then run from that event taking place. Again, that run monitoring screen, we saw that earlier. And from there, we have the ability to look at each individual run of the workflow. And in the workflow run view here, we can see the inputs and outputs of any single step along the way. So how do we process a webhook? First thing is, your workflow has to be validated. So I mentioned that inside the workflow editor, you have the button in the upper corner there for validate. Once you validate it, that workflow will be available for you to use for a webhook rule. It does have to be specified to execute on a target or on a target group. So you cannot have it specify target at workflow start. So these are a couple things to keep in mind when it comes to the workflow itself to make it ready to be utilized by a webhook rule. And again, a single input variable, type string of JSON. So those are two key things there. And then, of course, required for workflow run start. How do we parse that webhook request body? Again, that was a big JSON data object. Well, right now in workflows, there's a new object in there, activity, to parse webhook JSON body for Meraki. Now, this is only dedicated for Meraki webhooks, but all I'm going to do is drag that activity into my editor, drop it in the middle of my canvas, and then pass it in the webhook body that came in as an input variable. Again, by using our variable reference icon, that activity, the webhook request body, and then the output from that activity for follow-on activities using that browse variables window will give us access to all the different fields inside of that webhook. That's great if we're doing Meraki webhooks, but if I'm not using Meraki webhooks, I'm using some other format, there is a brand new activity here called a parse JSON activity. I can find that in the palette on the left-hand side, drop that into my canvas in the middle, and all I have to do here is identify the source JSON, so I'd map in my webhook request body variable, and in the example JSON area, I paste in an example JSON webhook of that particular format. And that will then allow me in following activities to use my browse variable icon to get the output of that parse JSON activity. Under the parse JSON area, I'll see all the different keys that were listed in that JSON object that I gave as an example. So it's going to automatically parse out all that JSON for me. Where do I configure, in this case, Meraki network alerts? Under the network settings in Meraki, I go to alerts. At the bottom of the page down there, there's a webhook section. I click on add a new webhook server. And then there's that URL box I'm going to put the URL into. And keep in mind the page earlier here. That's going to be the webhook URL, the @API key, and then the API key itself. So those three things you got to put together, paste that into that URL block, and then you have access to be able to send webhook alerts for network events. So in the case of a situation we're talking about in a minute here, for cameras or access points when they go offline, we can associate those devices going offline with a webhook. You also have the ability to configure this at the organizational level. So inside Meraki, go to alerts, configure alerts for organizations. You identify which alert you'd like to have a webhook associated with. You click the edit button there, and then down at the bottom, you can add a new webhook rule. Give it a name. Again, remember that URL format. And let's jump into a demonstration for the webhook rules. So, yep, there we go. Okay, I'm going to jump back into my live system here. And I'm going to change to a different organization right here. So in my new Meraki organization, I'm going to go into my workspace. And I don't have any workflows. I need to get some workflows. Well, you heard me talk earlier about that Workflows Exchange. So let's go browse that Workflows Exchange catalog. And there's two particular workflows. The one I showed you earlier that did the guest Wi-Fi. And we also have the one that here, so let's grab that one, that's going to bounce switch port PoE. So this particular switch port PoE one, let's install this one into my workspace, came out from customers that had cameras or access points. And when those devices go offline, their first tier 1 troubleshooting step is to go to the switch, find out which switch port it is, bounce power over Ethernet, wait to see if it comes back up. Sometimes, especially cameras, you got to bounce it a second time. How long does it take that network operator to see that event take place, figure out which switch port it is, bounce it, wait for it to come back up? You know, there's time involved in that. Let's automate that repetitive manual process. And I've also got this one I just showed you earlier that disabled, enabled guest Wi-Fi. Let me grab that one as well. So again, pre-built automations right here from the Exchange. I'm installing these into my workspace. So this is how easy it is to use these workflows into your environment. Okay, so I've added these into my workspace. Let's go take a look at our workspace and do the second step of the configuration. Wait, I only added 2 workflows. Why do I have 5 workflows here? Well, some of these workflows have sub-workflows with them, and so those are important as well. So again, keep things modular so they have more usability. So let's start off with here, this enable guest Wi-Fi one. I can come in here. I can edit that workflow. Keep in mind the rules I said. It has to be validated and has to have a target set for it. So as soon as this loads up, we'll get into validating that workflow and setting that target. So here, I'm inside the workflows editor now. Again, I can look at the logic of that workflow, but I need to set the target. So right down here, instead of specify on target start, I'm going to execute on this target. And I'm working in Meraki today, so I need this to be a Meraki endpoint. And then by default, everybody who's brand new to workflows gets a Meraki current organization target for you configured automatically. So I can just select that one right there, and then I can validate that. And those meet the requirements then of using this workflow with a webhook. Let me jump back up into the other one right here, which is going to bounce the power over Ethernet. Kind of need to do the same thing. Again, we're going to set the target type to execute on this target. And this time I'm going to take a Meraki endpoint here. And then I'm just going to select my Meraki target. But that one has access to multiple organizations if I need to. And I'm going to validate that one as well. Okay, we have our workflow. It's met the requirements. Let's go into the rules area. And down to the webhooks tab. And we're going to build a new webhook. And this is going to be our demo webhook. And that's all I need to do. I should give a description, but this one's only going to be short-lived, so that's all I need. So let's open that back up again. Scrolling down, remember I talked about that format we need to have for the Meraki dashboard. Well, we have the URL, so let me grab that, and then I need to jump over. Uh-oh. There we go. And I need to go into here, and I'm going to put that URL right here. So I have that. And then going back in, I need to grab that API key. So I can copy the API key. Back into the text editor for me. And then add in my API key. So I have got that. And to use a curl command with this, I just need to copy a couple things here. I need to grab this. And I'm going to pre-build my curl commands for the demonstrations I'm going to show you in just a second. So pardon me for 1 second here to paste those into the curl commands I need for the demonstrations in a minute. And then I do need the API key as well. There we go. Got all that done. Okay, so we have our webhook. Now our next step is the automation rule. So here we're going to add an automation rule. And again, the first step is to select the webhook rule. And again, I'm just going to go with our demo webhook today. Conditions are optional, so we're just going to ignore those for right now. Next step is what webhook? Well, we're going to select our, where's my webhook? I didn't check the webhook rule. There it is, webhook rule, there's my webhook. So here is my one webhook I have. And then down here, what workflow do I want to run? Again, I have 2 workflows that meet the requirements. They're validated, and they have the target set for those. So the first one we're going to take a look at is that bounce switch port PoE, since we already did the guest Wi-Fi one. And again, that workflow has a single required input variable. So I click on that browse variable icon, my webhook rule, request body, right there. Save that. Oh, okay. Okay, there it is. Everything's set. Save that. Okay, now we can go over into our network area. Where's it at here? Network wide and alerts. And down here under the alert settings, for example, we could add our HTTP server, workflows. We have our URL. Oops. We put together over here in the other. Okay. There we go. We put together in that text document, demo workflow format, right here. So we built the URL. Right in there, and save that. And now we can then configure that for different network alerts, or we could go into the organizational level alerts and configure it that way. And you always have the ability here to click on Send a Test Webhook, and this will send a power supply event into your webhook. So that's going to be enqueued and sent in just a second. And then we can then look into our automation delivered. Okay, so let's go into automation right here, rules, history, demo webhook right here, 332, an event came in. Let's click on that, and again, we see power supply event. That is the standard test webhook event. So our webhook is working. It's receiving events from Meraki. So if we configure that webhook for either network events inside of Meraki or organizational events inside of Meraki, webhook could be triggered that would run a workflow. So let's see what this looks like in real life. I'm going to come down here. I need to grab my API key. And then find my terminal window. Get my API key put in there. And now let's do a camera down event. So again, I'm going to use curl because a webhook is nothing more than an HTTP request. And that's what curl is great at, and doesn't allow me to wait around for the required time limit to trigger the webhook event. Oh, that didn't take. There we go. So here we go, camera went down event. Let's jump back into the dashboard and refresh our page here. Oh, did I miss the, oh, thank you for catching that. Typo, sometimes a little difficult to move between the terminal windows here. Yep, I had an URL command instead of a curl command. So let me try one more time. I'm like, wait a minute, it should be there. That's what happens when we do things live. So there we go. Did that, should have worked. Jump it back over. Refresh demo webhook. There it is. Let's take a look at that. And right down here, we see that was a camera down event. Scrolling up here, we get the run. What workflow was run from this? That was the process Meraki webhook and bound switch port PoE, and that workflow is still running. Let's take a look at that. Okay. So again, you see the green activities were completed. The blue activity is still in progress. So right here, we see was a network level event that took place here, indicating a camera went down. It parsed the information about which switch port it was connected to, and now in the process of bouncing that switch port for that device, and now the device is back online. There are placeholders in here to do that a second time if it's required, and also a place in there to look at that workflow. So again, this workflow is now locked since it's associated with a webhook. We can come down here and drill into the second iteration, and right down in here, you see as a placeholder to add activities for Tier 2 escalation if required. Okay, so that was a camera down event from a network event. Let's take a look at, for example, an AP access point going down. Back to our old friend curl here. There we go, curl. So again, event taking place here. This one's a lot more detailed information. But we do see, serial number of the device, alert ID. Here's device name was AP1. It's hard to read some of that details, but let's go back into the dashboard now. Again, looking at the history page in our workspace under rules. Okay, there's another demo webhook event right there. Again, lots of detailed in here, but somewhere in here we see the serial number of the device. Oh yeah, here's CW, so access point event right there, definitely. Again, looking at that workflow. It took us a little bit longer to get to it, so already completed. But here we see that was an organizational level event. So you get visual representation of which event took place. It identified the switch port it needed to, and then bounced that switch port PoE. So very easy for us to install that workflow from the exchange. All we had to do then was configure the target and validate it, go in and build a webhook. That was pretty easy to build a webhook, and then to create a new automation rule and associate that workflow to it. So let's do the other one right now. I'm going to jump back into my rules area. We have our automation rule. And I'm just going to reuse that same demo webhook. I'm just going to change which workflow we're using right now. So instead of doing the power over Ethernet, we're going to do the enable, disable guest Wi-Fi. And again, I want to grab the request body as the only required input variable for that particular workflow. And while we're here, let's take a look wireless. Let's look at the SSIDs. I see that guest Wi-Fi is currently enabled. So let me jump back over here and grab my full curl command, no URL commands this time. Oops. There we go. Good message back. Back into our rules area for the automation tab. Looking at that full history, again, the demo webhook came in. Looking at that here, uplink status changed, so that should trigger our workflow to then disable guest Wi-Fi. Again, it called the correct workflow. That's good too. And right there, zoom in a little bit here. Primary WAN link down, disable guest Wi-Fi. And then the opposite event is just as easy to do. When the WAN interface comes back up, just grab that one. Again, so you just associate that network event in Meraki, either at the network level or the organizational level. Jumping back into the dashboard, go to the rules area, history, another demo webhook, and here another failover event, uplink 0. So we're back to our primary WAN interface, drilling into our workflow that has run. We see the details that it now enabled guest Wi-Fi, and we go to wireless and our SSIDs, and refresh our page here, and the guest Wi-Fi has now been re-enabled. So again, we installed those workflows, 2 different workflows from the exchange, put those into our workspace, configured the target and validated them, went down into the rules area, configured a new webhook, configured an automation rule, associated that with those workflows, configured that webhook URL into a webhook in either a Meraki organization or network event, and then we're able to trigger that to automate those 2 repetitive manual tasks. So quick, easy, reuse the resources that are right there and automate all of your basic repetitive manual operations. Let me jump back into slide mode here. Okay, so we did some live demos, and we are going to make our cutoff time. So before I wrap up here, let me just remind you to please take a minute and complete your session survey. So these are very, very important to the speakers themselves and helps you get a better Cisco Live experience. You could get entered in to win a free pass to Cisco Live next year by completing the minimum number of surveys. But again, that's very important to the speakers and to yourself to improve this experience. You get points towards the Cisco Live Challenge leaderboard for doing that as well. Please keep in mind you can visit us down in the World of Solutions demo booth over there, Future Proof Workplace number 32. I will be there all day tomorrow. All the sessions for workflows are also going to be available on the on-demand library for Cisco Live, so don't forget about that. Before you leave today, on your way out, the desk back here, everybody's going to get a Agentic Workflows badge ribbon from me. And I've got a couple minutes right now, so if there are any questions so far, please come see me afterward. Oh, you have a question? The YouTube link. So just search for Cisco Workflows. Go to YouTube, Workflows in the YouTube channel, Cisco Workflows right there. Thank you so much for giving up 45 of your precious minutes here at Cisco Live. Please enjoy the rest of Cisco Live. I'll see you all at the celebration this evening. Thank you.
We still, wow, this is loud. We still have probably a minute before we can start. How many of you came to a session of mine at Cisco Live till today? Some of you. Okay, so it wasn't enough to do it. For those that didn't come, I had a lot of sessions. A lot of them covered MCP. This one is focused a little bit more on how to actually build an MCP server, a little bit more foundational. Do we have any network engineers? Anybody that doesn't feel as a network engineer? Developers, a little bit of both. AI, data science. What are your platforms? What do you use as a platform today? Catalyst Center, Meraki, SD-WAN, firewalls. Who's Catalyst Center? Meraki? Both? Some? Do you have other controllers, SD-WAN or third party or firewall data center? So everything we are going to see today can be absolutely reused no matter what the platform is, because it's nothing proprietary. By the way, the code you are going to see is open source. I wrote the MCP servers for Catalyst and Meraki. It's going to be open source. I have a number of slides that are going to be hidden. I don't have time to go through the entire context, but it should be published on Cisco U, on Cisco Live. If not, let me know. I'll make sure that you guys get the PDF presentation. Gabi Zapodeanu, I'm a principal TME. I have been with Cisco for 20 years. I'm a network engineer, still a network engineer, even if I changed a little bit my focus. For the last probably almost 12 years, maybe a little bit over, I worked a lot with APIs, with different platforms, different controllers. Back in the days, we had APKM and UCS Director and Prime, and now, of course, we have Catalyst Center, we have Meraki, we have a lot of different controllers. Last couple of years, I started to spend quite a bit of time with AI solutions. I have been the TME working with engineering on the AI assistant integration for Catalyst Center. Super happy to announce we have a cloud control and AI canvas integration with Catalyst Center, announced probably yesterday, today, another demo, I believe. We announced this week also an infrastructure as code MCP server released by our engineering, and I believe we have already released, or we are almost there to release the Catalyst Center and Meraki MCP servers, official MCP servers. What you are going to see today are open source projects that I worked. The first version of these MCP servers have been released by me last September. They have been significantly updated from the way they look to us and we use them, but the tooling capabilities is very similar with what I released a year ago. Very important, if you can, join the WebEx space. I'm going to share links for repos. You can ask questions, provide feedback, provide comments, ask for any other resources or any other materials that could be interesting for you. If you cannot join WebEx, ping me directly, and we can try to find another way to communicate. So I'm going to speak a little bit about why I think, especially now, in a multi-controller environment, we can use AI and why it's beneficial for us. We'll cover the model context protocol, how to build tools, and touch a little bit on advanced tools. There are a lot of advanced capabilities I built in these MCP servers. If you are interested, I can share additional tools, details. I can share additional slides with you that do not cover those tools in this presentation. A couple of slides on MCP hosts. I have tomorrow a presentation where we'll talk about a mobile AI for an iOS device that will talk with MCP server. So from the MCP server, we talk with a mobile application that is AI-enabled on a mobile device. Exactly the same application can be built with Android devices as well. So why do we think that AI is fundamentally changing the way we manage network infrastructure, but also unifying? Because till today, or recent, I have a controller. I have to know the interface, the APIs, all the foundation, how to use it. I have another controller I need to learn again. I could ask with my MCP server, and this is a real question, give me all the details about all the locations I have, the devices associated at each location network-wide. And it will go to Catalyst Center and understand location means the sites and the site hierarchy and gets the devices, and then goes to Meraki and understands location means networks and get to give me the information. So it's very simple with MCP servers, with tools like these, to really unify how we manage the infrastructure and very simple to scale. Be aware that all of these models you are going to use, large language models, embeddings are not necessarily used as much in this presentation, but I use embeddings in the advanced tools section if you are interested in, and AI platforms. All of these, you need to be careful with what data you share with them and be sure that you follow your responsible AI policies you have in your organizations. How many of you build an MCP server or use MCP servers today? I know some have. So it's not extremely hard to build an MCP server. Actually, you can go to probably any IDE that is AI-enabled and say, hey, these are my APIs, build an MCP server, and we'll do it. It probably needs some work after that to really make them good, but it will create that MCP server. In a core functionality, what from a model context protocol we are going to have to do is build an interface to the human, and that's the AI agent, is the agent application that we are going to use that will orchestrate communication with the large language model. We'll be able to understand that I have access to a number of tools, resources, and prompts through the MCP client. So MCP client is a library that is inside the host. The host is the application. If you use Cloud Desktop, that is a host. Could be your AI agentic solution that you are building. There are so many other options. You are going to see throughout this presentation, I think I have a couple of other hosts that I built that will use large language models, in my case in Bedrock, AWS Bedrock, and the 2 MCP servers that I published. It is important to understand from a host perspective, the communication from the MCP client and the MCP server can be over multiple protocols. The most common one that you are probably going to start with, standard input, standard output. If I have the client application, let's say Cloud Desktop for simplicity, and the MCP server collocated on my laptop, they are very likely going to use standard input output. It's very efficient, it's simple, it's secure because it's within the same host or somehow secure, but it's also very, there isn't really much overhead. It's very simple to configure. But if I need to have the MCP host communicate with a server that is a real server, and the servers, MCP servers I use are actually hosted on a real server, then likely I will use streamable HTTP. There are a few other options, not necessarily officially supported, but they would work. So this is one thing that you need to decide, what protocol, based on where the MCP host and the MCP server are in relation to each other. For me, the MCP is just an option I have to expose capabilities through APIs. I don't have to know exactly the API. I can ask MCP, the client, the AI agent, do something for me, and it will find the right tool to do it, to implement that. Of course, it's very important to support multiple servers. It is very likely that you probably will start with one and very quickly have more servers you add. And each of them will provide the same capabilities, a number of tools, resources, options that we have to communicate with the same host. The agent actually will do all the orchestration. I have multiple tools. Which client do I need to use to which server? That is what the AI agent, basically is the orchestration, the routing internally within the MCP host. This is important to understand what is going on when actually I'm starting my MCP host. So when, let's say, this agent application starts, it has pre-configured already the MCP servers, the transport, credentials, API keys, security, everything that is required to communicate with those MCP servers. And it learns through the MCP protocol all the tools that are available. This is what's going on between my application and the MCP server. And actually, I can see in the MCP server logs that it's connecting and publishes all the tools. The user submits a question, and by the way, that happens even before I send any questions. It's just part of the protocol. So as soon as I send a question plus all the resources available from all the MCP servers are going to be sent to the large language model. The large language model looks. The question was about, let's say, Catalyst Center inventory and compliance, and looks, I need to find the inventory of devices and non-compliant devices, and looks in the description of all the tools and says, oh, I need to call these 4 tools to get this done, and makes a plan, part of the reasoning, and then it starts to call those tools one at a time or in parallel, depends on what kind of agent application we have, or also the large language model. And then it invokes through the AI agent the tools that we need. We make the API calls, we return the response back to the large language model. At that time, the large language model looks, the question was compliance and device inventory. Do I have all the compliance and device inventory? And it needs to decide, I have everything I need, or maybe I need to get more information because maybe the device inventory does include the location, and I want to group all the data by location. It will go back to find more information, call our tools, and prepare the entire data. When it's final answered, it will basically respond to the user, and of course, it is in natural language. This answer will be formatted likely, if I don't do anything, every time different. So I'm going to have an answer that is presented to me in a different way every time that I'm using. It's not going to be necessarily consistent unless if I really do extra work to make it consistent. So very important, because a lot of times I get questions, hey, we would like to use your MCP server and your large language model. Yeah, I know everybody wants to use my large language model. They save some money. We all want that, but it's not that the reason. It's just maybe a little bit of a slight misunderstanding. Large language model is a decision, it's a choice we make when we build the agentic application. It's not part of the MCP server stack. So when you build your agent or you decide what agent to use, think about the large language model and the data privacy requirements when you use that large language model. So this is also kind of important to understand. Not all MCP servers will implement all the resources. Some implement only tools. Some implement tools, prompts, and resources. Tools are the actions. What do I actually expect the MCP server to do for me? Call an API or do specific things. We can see here a number of tools that are available from an MCP perspective that are provided back. This answer is coming back from the large language model. It's presented in the agentic application I use. Prompts are instructions that either the server has internally, which I do have in my server, some instructions of how the MCP server to operate, and those instructions are coming to the large language model, or you can provide those prompts. Hey, I want to run tools in specific sequence. And resources could be your best practices, validating designs from Cisco, policies, what does it mean compliance. This is how you tell additional information that a large language model must use or will likely use when it performs a task. So Catalyst Center has very good compliance capabilities, but I'm sure how many of you have your own personal corporate compliance policies that you have on top of Catalyst Center? Probably all of you. So those compliance policies you can import as resources, and the large language model says, okay, compliance means this from Catalyst Center, but I have this other custom compliance I need to inspect. I'm going to find the tools to validate those compliance policies. So why MCP servers and not API calls? Is there any value to do this versus API calls? Any guesses? So the number one reason, and you are going to appreciate when we get to some demos, is the fact that when we make direct API calls, everything that I write is by hand. All the order in which I make API calls. I need to know each API from each platform. I need to know very well how each of the platforms operate. With MCP servers, it's a little bit more centralized. It's a little bit easier from a login perspective. It's also a lot easier to build new workflows. Every time I write something direct with APIs, I need to know API by API what I need. Loops, conditionals, pagination, parse data, do it again. And if I need to change something in that workflow, I rewrite everything. I need to test it again, validate, approve it, distribute to production, and then change again. With excuse me, with MCP servers and tools, it's sometimes writing a tool is just a YAML file, and you're going to see how. It's super easy, and the large language model will write the logic for me. I don't have to be descriptive in that logic. So each tool is purpose-built. These tools are much simplified because with exactly the same MCP server that I have, I can solve probably, I don't know, 20, 50 different use cases. I'm not writing any line of codes for this. This is a reference slide. I'm not going to go through everything here. We are actually going to go through what's important in the next few slides. But we need to be comfortable with about tools and resources. Of course, skills are coming as well very quickly. They are very important as well to be aware of how to build skills with MCP tools or without MCP tools. It is outside the scope of this presentation, talk about tools. We can talk a little bit about the large language models, and we'll talk a little bit about agents. So how do we build tools? What's actually inside an MCP server? Because we all, we see an MCP server. My bank actually has an MCP server. If I want to download a statement from my bank, I can use the MCP server. I can build my agent to integrate with the bank, and I can get downloads or new transactions or whatever is needed. So inside an MCP server, there are some requirements, like I need a tool catalog. And you remember when the agent connects to the MCP server, discovers tools. And this is the tool catalog. What are the tools that I can use? And I need to be able to execute those tools. These two could be the same wrapper, but it's easier if they are not. So I have a tool catalog that is presented for me, to me as a user, human, but also to the large language model, and then I need tool execution. Be careful with this. I have been guilty once or twice to leak some credentials I didn't intend to a large language model. So it's very easy when we get excited something works, it's awesome. And then some credentials could be leaked. For me, lab doesn't matter. Information that nothing in my lab is that confidential, but it's also very easy to change. In my case, I use the large language models for Anthropic from AWS Bedrock, so those are a little bit more private. The damage wasn't that great. But be careful when you write your code. This should never go to the large language model. First, security. Second, doesn't need them. Really, there is no need for any credentials for the large language model. You don't want any large language model to communicate with your network devices or the controller directly. It doesn't need that. And there are some additional nice to have: response formatting, guardrails, some additional policies. Of course, prompts, resources, those are part of this. Those are nice, but you don't have to. But at least this part is very important. Be able to communicate with these platforms, be able to make API calls, credentials, all of that. So tools are what the agent actually does. And this is a catalog of the tools from Catalyst Center and Meraki. We have here a number of tools, 17 for Meraki, 26 for Catalyst Center. These are tools that could get information regarding devices and sites and networks and topology, issues, alerts. Help me understand anything that I need. The wonderful capabilities of large language models when they use MCP tools, I can ask, hey, I need you to provide me an inventory of all the devices not compliant, do it by site, and do it by device type. And then that's what the large language model would do. Oh, I need by site, let's get the site hierarchy. By device type, let's get device detail, and then check compliance for each of the devices, and then presents to me a table with the information I ask in this way. If I would have to do it with Python SK, I need to write that code. Might take me a little bit of time. With large language models, I don't, because they will do it for me using the MCP server the MCP tools. And next time, if I want to change, well, by the way, add also information about p-certs, I don't need to write code again. The large language model says, OK, I can do it. I'll add the p-certs details as well. So tool catalog is the first part. I need to present the tools that are available, tool execution, and response handling. Sometimes I need to parse data. It is wise not to send all the data that we get back from some tools that return a lot of data back to the large language model. Anybody guesses why not? Expensive. It's going to cost us a lot of money. For example, I'm looking for all the devices not compliant, and I'm asking, hey, can you get all the devices from my environment that are not compliant, and then check to see which ones are not compliant. So I get information about, let's say, 500 switches, but then I have really all I need is just 10 switches because those are not compliant. But I send potentially data for 500 switches to the large language model. So it takes time to process that data, but it's also expensive. So very simple. This is a very simple tool. We will learn how to build these tools. So I have a server that I called as a basic Meraki MCP server. It's available in the code that I'm going to share with you. And this is the description. The list of tools actually has only one tool. And this is the description of the tool. The API, sorry. This is the information, the description of the tool, get the information back. This is what the large language model sees when I'm asking anything from an agent perspective. And this is on the, basically, I'm sorry. And this is when I want to execute the tool. I apologize for that. I have a function to call the tool. I have the header, which includes the Meraki API key. This is the API endpoint that I'm going to call. It is for the organizations, for my Meraki API key. And then I'm going to return data. And in this case, I'm going to return all the information. Because there isn't much data in this organization API return. There are maybe 5 parameters returned. And I'm going to send everything back. Maybe in my design, I consider everything is important. And then I'm going to start my server, the MCP server, to run. So let's see how this looks. This is Cloud Desktop. I think I have another demo using a LibreChat client, but if you are getting started, my recommendation, start with Cloud Desktop if you can. It's really good. It's one of the best, if not the very best agent, at least that I have worked with. You may need to be careful what large language model you use. Recently, I believe they opened the door to actually use some other large language models that you want. But you can see here information, what it tells me. There are some other tools that are built in. Those are default. It's not that I wrote. But it tells me, hey, you have access to this organization. This is what's coming back from that single tool that I have in my MCP server. It's, of course, nicely formatted. It's JSON formatted data. It went back to the large language model and decides, based on the question, these are the details I received from your MCP server. So what happens if I need to build 2 tools or more tools? I kind of need to build a logic to do this. So in the tool catalog, now I have 2 tools. Get the organization based on my Meraki API key, and this is where I want to get the networks. But the great part about anything that is related to AI, MCP, you have the freedom to instruct using natural language. It's not a strict recommendation. How you define, you tell additional instructions, you give recommendations to the large language model. And in this case, this is what I added. List all organizations, requires organization in parameter to be obtained from the other tool. And this is important because I'm helping the large language model to make the right decision. In this case, the large language model would figure out that anyway, because it will try maybe this API, this tool with the name production, and then fails. Meraki would say, well, I need a organization ID. I can't use the name. And then it will say, okay, I need to go back to finding tools. The organization ID tool will find this one, we'll call this, and then we'll go back to call. So it takes a little bit longer, uses a little bit more tokens. It's a little bit more efficient if we take the time to provide additional instructions to the MCP, from the MCP server and tool to the large language model. So this is how I have now the same common header. I have two functions. I can call this API endpoint or this API endpoint. I have an if statement to define if the tool call is list networks. I'm going to call that tool, and I need to provide this parameter. Who makes this decision and tells the MCP server what tool to call? Where is this coming from? Any guesses? The large language model, because it will look like my question is about networks. It will look at the list of networks. This is what it received. And it will say, oh, call the list networks tool with the parameter, which is the organization ID. And then when it comes on this side, it will say, oh, the tool called is list networks. I'm going to call that. So let's look at a quick demo. It's a very, again, this time I have only a couple of tools. And we can see the description. This is very simple. The tools are not very difficult. It tells me what the tools are, what I can use them, which is not really that much. This server is starting to get a little bit more useful, but it's not that much useful at this point. And then it tells me, if I ask, you can see here I ask about networks, and it says, oh, I'll get the organization first, and then I'll get the networks. So the fact that I added this description in the list networks tool, get the networks, help the large language model to decide the plan from the beginning, the correct plan. And now it gives us the information. And this is all it has, doesn't have more. If I ask about the device at each of these network, it won't have that information. This is another elegant way, and you are going to start to see the shape I build tools. I'm using a YAML file for Meraki organizations and one for Kerli Center clusters. And in this YAML file, I provide easy-to-use name, the API key that I want to use that it could be different, but also I provide if is in service or not in service. So this is a very simple way when the MCP server starts, it loads these organizations and clusters and decides, oh, these are in service, these are not in service, I can use them or not. I can expose them to the large language model because the large language model doesn't even see these solutions cluster because it's not exposed by the MCP server. So if I have a lab network and I can put it maybe like here, it's in service, but maybe my production, which is my home network, I don't want it to be in service, so I'm going to maybe remove it. I'll make it false, like in case of enabled will be false, and then I can do demos because I'm not concerned about my production network being at all used during those demos. So what happens, and this is where we are going to start to appreciate the power of MCP tools, servers, and large language models. What happens if I ask, give me the information, all the networks for the production organization? This is actually the large language model reasoning. This goes the tools and the question go to the large language model. The large language model discovers my organizations I have access, then decides, oh, I need only for one, so I'm going to call only that organization with that parameter and get the data and provide me the information. Well, the beautiful part is I don't need to change anything on the tool, on the server side, if I want to get information regarding all the networks. Because what will happen is, in this case, we start in the same way. The large language model starts by getting all the networks that I have available in my infrastructure and says, oh, I have two organizations. I have two organizations. I need to call exactly the same operation for each of the organizations, get the networks with the prod, lab, aggregate everything, and provide back to me. So with MCP tools and servers, we don't have, it is unlikely, unless if I build very advanced tools, to have to write loops, if then else statements. Most of the times when we build basic tools, we're not going to need to do this. It doesn't matter how many organizations or Kerli Center clusters I have, how many networks I have, how many devices I have at a site. The large language model will have the logic, oh, I need to call networks 10 times to get the list for of the devices for each network. So let's do another quick demo. And now we are going to get additional like client tools as well for Meraki. If I would ask client without Meraki, what would happen? If I say, hey, show me all the client tools, what would happen in the context of this question? What do you think would happen? The answer would be, because there is a chat in this question, I ask about MCP tools from Meraki. So I would expect the large language model would say, in the history, you ask about MCP servers from Meraki. You ask about client tools. You don't say Meraki. I'm going to start to return you the client tools that are for the Meraki MCP server. And what I'm expecting probably will happen is it will say, and by the way, you have tools for Catalyst Center for client. But it shouldn't be that I have to, basically, it will at least give me the information in the context that I was looking for. Is it always going to answer in this way? No. Sometimes it may give me only the MCP tools for Meraki, but probably will give me, by the way, you have other tools for Catalyst Center. So let's look a little bit at some of the advanced tools. So advanced tools could be, well, I have a sequence of APIs that I want to run for specific workflows. So for example, compliance, we talked, you have your own compliance policies. That requires probably additional capability, additional tools to call to get all the information about running configuration and maybe logs and anything you need from the device's protocol status. Those are additional tools you need. So when we build some advanced tools, we can write them, hey, I want you to run through these 5 tools in sequence and maybe build a tool that maybe calls all of those 5 APIs in a sequence. AI flows is another option that I use for troubleshooting. We are going to see in the last demo today. Tools could be user guides. A tool could be, hey, I want to read in all the compliance policies that we have in our enterprise. Maybe there are pages and pages and pages. I want to find out from there what is saying about AIGRP. What is the best practices that recommended in the AIGRP configuration, and tell me if the devices at this site actually are configured with the AIGRP correctly. So all of those are additional tools, advanced tools that can be implemented. Code generation is also important based on the APIs that are wrapped behind MCP tools. You can say, hey, I want to write a code that is using these APIs because the API documentation is available as well to us. And very important, these tools can be auto-generated. So you can see here, I have a tool that is for configuration changes of devices, and I can write, this is a YAML description of those tools. I can write them with AI. And this is where I think is probably the most innovation that you are going to find in this presentation. The way I decided to write tools was declarative and auto-generation. I don't want to write tools by hand. It takes too long time. I want to define all my tools in a YAML file, and then my server will load this YAML file and will do 2 things. Create the tool list, that's what's presented to the large language model, and tool calls will actually execute these API calls. So the only change that I make, if I need, is actually on the YAML file. So it resolves a major problem that all of us have. Yeah, I write 2, 3, 4 tools, it's not hard. But then if I need to write and I have 20, 25 tools to maintain, every time I change something in the tool, I need to go in the tool catalog to change parameters and descriptions, in the tool execution to change parameters and descriptions, test again, and do it again every time. In this way, this is a single source of truth. We are all network engineers. We appreciate a single source of truth where everything is defined here. So if I need to change something here, add another parameter to this tool, I'm adding the parameter here. And that's it. I don't need to change the server code. It's unlikely that I need. So this is how I define tools. I have here the tool name. I have the API call some tags that I assigned, how to categorize these tools, how to make them better from a catalog perspective. And then I have the ability to define the parameters. In this case, we can see the parameter path. The parameter in this case is in the path. And that's how I define that this is the ID that it's in the path of the URL of the API call that I make. And I support multiple options, path, query, special, because this is the organization that I want to use. There are few API, basically parameters, request, body, if it's post, put, delete. I can decide, hey, it's in the body of this API. So for me, it's very easy. I can auto-generate tools. I can write the tool catalog from this YAML file. The only thing I need to do is change the YAML description and reload the server. Why do I need to reload the server? Any guesses? Because every time the server starts, it will load the files, the Kali Center clusters it has access, the Meraki, the controllers it has access, but also it will load this file with all the tools, and then it will basically update itself in that way. And this is how it looks. This is a tool that I have in my YAML file. It will be added to the tool catalog, and from there it goes through the agent to the large language model, which presents me the information here. So it looks nice. I didn't have to write menu or documentation for my tools. Everything is self-documented because basically AI, the large language models, are very good to take different types of data and present it nicely to us. So this is very important. Is this good? Hey, show me all the network issues I have across my Kali Center clusters. In my lab, typically I have 11, 12, 13 issues. What's the least amount of issues you have in your Kali Center cluster? More than 100, less than 100? You don't say the number. It's probably high. So if I ask, hey, I want you to retrieve all the issues or troubleshoot all the issues in Kali Center, it's going to be one of two things will happen. Either it's going to be very expensive and our manager will come to us, what is that you are doing, that you are spending that much money with tokens with the large language models, or we are going to crash the tool because it's just too much data. So like with any AI tool, we need to be smart. Ask, hey, give me information regarding this site. Troubleshoot the BGP issue. Troubleshoot the client issue. Troubleshoot the WAN issue at this location. Don't just go troubleshoot everything because it's not going to work well. So let's do a quick demo for this. And I'm asking, and I had no idea, I swear, I had no idea what the answer is. I said, okay, let's see what the large language model thinks the use cases could be. And you can see here in this window, actually the reasoning, the plan of the large language model. I'm using in this case AWS Bedrock. This is a LibreChat agent that I built. If you are interested in this agent, I find it very good. I can share the open source code if you just let me know. But we can see here all the logic. It thinks what it can do based on those tools. I don't tell the large language model what use cases it can use. But this is what the large language model thinks it can do for me with only 26 tools that I have available. And look at this. It's going to tell me, hey, these are all the tools available, and it will give us a number of use cases. Look at how many use cases, and it keeps going. So once you build your tools, you're going to open the door to a lot of opportunities. You don't have to rewrite. Maybe you need to rewrite tools, you add more tools, but you don't have to do a lot of work. So it's interesting. One platform, and you have so many opportunities after this. So a little bit of insights on how I built this MCP server. I use FastMCP. I didn't use FastMCP initially, but I updated to FastMCP. I have a couple of, I support both STDIO and remote streamable HTTPS transport, and I have a wrapper for just the transport. The core functionality of the MCP server is exactly the same. So by doing this, it allows me to actually, if I change something in the core from tooling perspective, it's exposed immediately both options, because otherwise I have an STDIO version streamable HTTP version, and I need always to update 2 versions of the MCP server. Doing it in this way, it is a core, and I have 2 other options for transport. And then I have obviously observability. API keys are very important. If you are using these MCP servers, remember 2 things. You need an API key for each of these servers. You decide what the API key is, and you are going to need session ID. So if you run in troubles, if you try these MCP servers, remember these 2 things. I need an API key, and I need also a session ID. And if it doesn't work, you can ask me, and we can figure out. But if you have these 2 things done with your agent or cloud, you should be in good shape. So we talked a little bit about MCP hosts. So even if we have exactly the same MCP tools, large language model, and exactly the same basically agent, when we start changing things in any of these, the experience would be different. To have a great experience, we need really good MCP tools. We need also a domain knowledge rich large language model. So look at this MCP server and the large language model. It identified and troubleshooted like, I don't know, 6 issues here and provides basically all of them are probably correlated. It figured out the event correlation reasoning, gives me with a lot of detail why it thinks these issues are correlated. And of course, a very good agent. And you have one in Cloud Desktop is better than this. Probably my client, the LibreChat, is really good. I'm very happy because I can use that with my AWS Bedrock models. But if you have the same MCP server and the experience is not good, it could be the large language model you use, could be the agent. Don't always blame the MCP server is at fault if something doesn't go well. I would start first with the large language model selection and then the agent, because the agent especially has significant impact on the experience users have. And this is what happens from an agent perspective. We have internally in the agent, in the application agent, we have the MCP host, we have the agent. It's running, obviously, the interface through the MCP client. The AI agent is all orchestration. So if you walk away from this slide, what's most important, agent is all about orchestration. It needs to keep track how many network engineers use my agent platform, how many chats each of them have, how many chats are active, do I save these chats, history, compliance, what do they have access, role-based access, accounts, everything. The agent also will keep track all of these chats with the large language model, because it's not going to send information from a chat to another in the stream of another chat. The large language model has the only job, which I'm not saying it's easy, to plan, reason, validate, observe, and adjust based on all of this information. And then the client will do the communication from the agent through the client with the MCP server to call the tool and get the data from the tool. As I said, Cloud Desktop is probably the best that you can use. If you have a choice, start with that one. If you don't have a choice because you can't for policy reasons, then you have an option to use build your own agent. And I can share with you a web application agent. Tomorrow I have a session on a mobile application that is AI-enabled, where of course, I can share with you the LibreChat code as well. This is where you have the code for the MCP servers, the open source, and the infrastructure as code Ansible MCP server that we publish. Our engineering released this code this week. Let me know if you have questions on these servers or any other source code that you are interested. So let's do a quick demo, and I'll take some questions while this demo goes on. So this is about a session on troubleshooting, and you can see here I'm asking to follow a specific workflow that I defined for the BGP issues in my Portland cluster. So I'm trying to be restricted. I probably have multiple issues in this cluster, my lab, but I want to troubleshoot only BGP because I don't want to overwhelm the large language model with a lot of data, or maybe have assessment of the issues that is incorrect because it may not follow properly that, hey, I'm troubleshooting only BGP, but you are looking also at EIGRP or other issues. So any questions so far? Is it hard to build tools? Is it difficult? Shouldn't be. Is it hard to build a lot of tools? If we do a declarative like a YAML file, it shouldn't be that hard. It's not that difficult. So we can see here it goes through AI suggested CLI commands to run against both routers. It will go through all the step by step to collect all the information, and then at the end will give us details about what it thinks is actually the problem. Do you think it will find out what's wrong? What's the confidence level? High? For me, it's very high, because I've tested this with so many different issues, not wireless, but with so many other issues, and it's very, very good to find out actually the information, what is wrong. And we can see here, it will soon give us all the information, this is the reasoning. I have some BGP town. It shows me that, hey, I checked the MTU, I checked a bunch of other things, and this is all it analyzed. And then it will give us the reason why we have this problem. And it retrieves the last command, and it will be done. So throughout this session, we walk through a little bit about how MCP protocol works, standard input-output or simulation GPS transport, how to build tools, the very basic tools. We have the option to build advanced tools. And also, we looked a little bit at agent options. By the end of this troubleshooting, we'll see, for example, it finds the 40 issues. It looks like what's going on. It looks BGP is down because both routers correlating infrastructure down between them. It shows me the proof of why it thinks this is down. I know you have a lot of options for sessions. It's always a privilege. You decided to spend 45 minutes here, or actually 47 minutes now. It's always greatly appreciated to hear your feedback. We have a couple of options: feedback in WebEx, in the space, ask questions, comments. Obviously, it's very important. The session surveys, every probably speaker is asking you, begging you to complete the session survey. It's very important to hear back from you. Do you have any questions now? Thank you so much for coming. I appreciate the time that you guys spent here. If you have any other questions, I'll be outside there if you have follow-up questions. Thank you so much.
Is it hot? Okay. Hello, everybody. Welcome to this session. Appreciate you all coming on to us late in the day. So today we're going to talk a little bit about NetBox and some of the integrations we're doing with Cisco Catalyst Center and Meraki. My name is Ben Bowling. I'm a solutions engineer at NetBox. A little bit about my background: system and network engineer for many years. Used NetBox in the wild, both commercial and community. So I've been there, done that, and so just want to take you guys through some of what we're doing with these integrations. And we have got a booth back here in the World of Solutions. So if you've got any questions, see me afterwards, or come visit us in the booth. We'll be happy to talk to you and set up a demo or whatever you need. Yeah. So use the WebEx app here we'll probably upload the slides here if you need to ask some questions or whatnot. Please utilize the app. So the agenda, we'll talk about a little bit about NetBox Labs for anybody that's not very familiar with it. Then we'll go over the integrations for Cisco. And then those integrations actually pull data into NetBox. We'll actually go over some of the built-in functionality that already exists in NetBox to actually push data out of NetBox into other systems, and then we'll have a demo. So a little bit about NetBox Labs. We'd like to say that everybody uses NetBox. Just curious, anybody here using NetBox? All right, that's usually what we get. So just some of the logos here. There's thousands and thousands of companies using NetBox networks of all scale and size use it. So yeah, it's a very popular tool, very robust. So NetBox Labs was founded in 2023, and we're the commercial stewards of NetBox community open source. What that means is we actually have engineers on staff that are committed to just the open source project. So when we say we invest back into the open source community, we're not just putting that out there and saying it. Like I said, we actually have full-time engineers that work on the open source project. We're led by a world-class team that actually built and led NS1. We actually spun out of NS1. And people like Jeremy Stretch, who's the original founder of NetBox, is one of our founders as well. So we have world-class investors and customers. This slide is actually out of date from the time that I put it in this deck. There's well over 20,000 GitHub stars, well over 11,000 commits, well over 300 contributors, and thousands and thousands of companies are running NetBox in production. So we talk about this network source of truth. So what does it mean? What is a network source of truth? Well, it defines the intended state of the network represented as structured data. So that structured data part is really important because if you've ever done a show run on a switch or router or whatnot, you get a lot of data. It's unstructured. You've got to parse through it and whatnot. So with structured data, you actually get it in a format that you can use programmatically for automations and all those kind of things. It should act as a single consistent data set. And we found that adopting this requires a significant mental shift. And so I know that when I started using NetBox, I was coming from spreadsheets, and I just thought, okay, I'm just going to put this in NetBox, IPAM, and then it was just odd starting to move away from something that I'd done for so long, and then it just kind of snowballed. It's like, okay, from IPAM to, oh, I can do this with it, I can do switches, servers, all the things, and so it does take a bit of a change in mindset to take it from something like a spreadsheet to structured data, but once you do it, the wheels just start rolling. And then you want it to become the authoritative reference, because when you get the data in there and it's accurate and you know it's accurate, then you can start driving automation from it and be very certain that what you're automating against is accurate. So we say it's the world's most popular network source of truth, but why? Well, it's got a comprehensive data model. So we like to say everything from ASNs to VPNs can be documented. Again, when I started, I thought, okay, this is a great way to get off spreadsheets for IPAM. Then I started realizing, I can document this, I can document that. And before long, I'm, using it as the reference point for my network. It's API and integration first. It's the way it was built. So we have things like event streams, webhooks, and so other systems can programmatically interact with NetBox. NetBox can programmatically interact with other systems, so it's very flexible. Massively extensible. This is super important to a lot of people. You've got things like custom fields, custom objects. So if the data model doesn't exactly fit what you need, maybe you need a specific widget field on your devices, you can easily add that, and then that has an API endpoint. You can automate against that. So a lot of extensibility there. And there's just an enormous ecosystem because of that. So really everything works with NetBox. So this is kind of the journey slide that all of our customers are on. Everybody wants to get to automation, but what we find is most people are actually starting here. It's a win just to get off spreadsheets, text files, things like that. So that's where this documentation comes in. Once you start pulling all that in and documenting it, after it's documented, then you begin to model it. And by modeling, what I mean is you start actually building that fabric. So you've got your IPAM, and then you've got your DSIM, and you can start tying those together. I can start taking IPs and attaching those to devices, whether it be a management interface or an IP on an interface. and then I can take prefixes and attach those to the VLANs and so on and so forth. So you just start building that network and modeling it out. And you can also enforce consistency. So something like a VLAN group where you could say, if someone were to come along and want to put or document a VLAN that's outside of the scope of your storage VLANs or whatnot, it will stop them from doing that. You can enforce naming conventions and whatnot. So again, this modeling is very important to get that picture of your network built. And from that point, then you can move to the automation. What we've talked to a lot of people this week about, and what we talk to customers all the time about, is when you have everything in NetBox, everybody's automating against the same thing because it's accurate, you can trust it, you've modeled it, you've vetted it, you know what you're getting, and so then you can start automating against it, whether it be, against your IPAM data or your DSIM data. So that's really the journey that everyone goes through to get to that automation point. So there's really three flavors of NetBox. There's the open source community version. We've also got NetBox Enterprise. NetBox Enterprise is deployed on-prem, so you provide the Linux machine that it's deployed on, and you maintain that machine, but you get advanced features like what we're talking about today, 24/7 support, best practice assistance, and extended version support. And this is important because a lot of people like to customize, whether it be plugins or whatnot. And so because you get up to 2 years, you don't want to be forced to upgrade and that break your plugin. You want to have time to get your plugin ready for that upgrade. So that's nice to have that. And then we have the NetBox Cloud, which is a complete SaaS offering. And that is completely maintained by NetBox Labs. So we would do the backups. Obviously, there's no hardware or VMs or anything to maintain. And then it also comes with all the advanced features, the support, best practice, and then you have the 1-year extended version support. So let's talk a little bit about the integrations for Cisco. We're actually building a lot of integrations right now, but we're going to focus on the ones for Cisco today. But you can find all the integrations on our site. There's a lot coming out for a lot of different things. But before we do that, let's kind of talk about how these integrations work. And there's two important pieces, which is discovery and assurance. So discovery is where you're going to go and discover your network. You're going to either go discover subnets and prefixes, or you're going to go discover devices, and that's going to be brought into NetBox, which is great, except you want NetBox to be the intended state, not the operational state. So if you're just going to bring in everything that's out there, you're really kind of muddying up NetBox and sort of defeating the purpose of the intended state, because it's just going to bring everything in. But when you layer assurance on top of it, what happens is you get a visual, you're going to get a visual dashboard where it's going to bring discovery in, or bring the items that discovery has discovered, and show you those and allow you to make decisions on what you want to do with that. Like, yes, this is right, it should be in NetBox, or I don't know why this is configured on this device, I need to go fix that, and then push it into to NetBox. So just a little bit about how those two function together. So with Discovery, it's just a lightweight Docker image that runs on any Linux machine. And you've got three flavors. You've got Network Discovery, which is powered by Nmap, and that's going to discover a list of prefixes that you assign. It's going to go out, discover any active IPs. Any active IPs that it finds, it's going to pull it in to your IPAM data and populate that for you. Device Discovery, same concept. List of devices. It's powered by Napalm. So when it discovers those devices, it's going to discover any and everything it can. Model, serial number, manufacturer, device type, then your interfaces, VLANs, IPs. It's going to bring it in, and once you approve all those changes, it will actually build out that device in NetBox. And then controller discovery integrations, which is what we're talking about today, is where the agent is going to go out and you're going to point it at a controller. So you're going to point it at like a Catalyst Center, and it's going to pull back all the information that Catalyst Center has. So all the devices, all the interfaces, VLANs, prefixes, all that is going to be pulled in. Same with Meraki, and that's the way all the integrations work. So it's kind of a one-stop shop where you point it at the controller, and then you get all that data pulled back. So this is a visualization of the agents running. So you can have as many agents running as you want. You can have them spread all over your network. There's no limit to that. You can have some that do device discovery, some that do network discovery, some that do controller discovery, and you can have one that does both or all. But you deploy them, as many places as you like. And what you see here in the middle is assurance and diode. So diode is the ingestion engine, and it takes what discovery has discovered and it orders it so that it can be put in NetBox in the correct order. If you've ever tried to work with diode outside of assurance or discovery, you've got to. It's really kind of painful because you have to put everything in order of operation. You have to have this to have this to have this. Whereas with assurance and diode, that order of operation is going to be figured out on its own. So assurance is kind of the gatekeeper here between discovery and NetBox. So again, it's going to say, hey, discovery found this. I'm going to present it to you before I put it in NetBox and see what you want to do with it. So this is kind of the workflow. So you've got your network here, which that can represent, IPs, devices, controllers, whatnot. So you're using discovery to discover it, and then what assurance is going to do is it's going to extract what's in NetBox, it's going to compare it to what discovery found, and then it's going to display the deviations in assurance for you to take a look at and then act on that. So there's two scenarios here. One is the source of truth is correct. So you run this and you get deviations, and it's MTU on an interface has been changed, or VLAN shows up on a switch, and you say, yeah, that's not right. That shouldn't be there. The source of truth is correct, so this deviation is wrong. So at that point, you may, fire off whatever automation pipeline you have to go update the correct config, or maybe you're going manually to the switch or whatnot. But that's where you would see that and go correct that. You would run discovery again and see that deviation is gone. Or it could be that the network is correct and that it was an approved change. People knew about it. Okay, that's good. So network is correct. We'll go ahead and let that through and let that in the NetBox. So this is the assurance dashboard. So what you're seeing here is it's broken down by type. So you can see the deviation types like prefixes, IPs, new devices, whatnot. So this is good for network engineer staff to just look and see what's going on the network, what kind of changes and deviations are out there, what kind of type of deviations are there. So this is just the device type overview, or I'm sorry, the deviation type overview, so you can keep an eye on it. You can then go into those deviations. You can drill down, and you can see. We know that this was a deviation that was found by running the Meraki integration agent. It's an MX105 device that was discovered, and over here you can see all the information that it found about that device, and that's what would be placed in the NetBox. So Catalyst Center and Meraki integrations automatically sync network infrastructure from Catalyst Center and Meraki into NetBox. So this alleviates that manual data entry of building devices and building IPs and interfaces and all those things. Again, it's a scheduled sync with the discovery agent, so you set your schedule of how often you want it to run. The comprehensive mapping, again, it's going to map things like sites, VLANs, IPs, wireless LANs, anything that has a mapping in NetBox. And then again, use NetBox assurance for the safe data ingestion, meaning that you're going to have control over what goes into NetBox and doesn't go into NetBox based on those deviations. And then secure auth, that we securely connect to NetBox via those agents. And again, easily deployed with that lightweight Docker image that just runs as many places as you'd like. So here's the docs can be found netboxlabs.com/docs. All the configuration and data for these integrations are there. Also, this has now, for a few months now, it's on the Cisco Networking App Marketplace. Just go to marketplace.cisco.com. There you'll see, you can watch some videos, read some collateral, and then you can choose to demo this app, and we'll be happy to get with you, demo it, and go over it, and find a use case for you. Also, the ACI integration is in customer preview, so it's going to be released next month. So same sort of thing, same architecture. It's going to, again, sync device inventory interfaces, VLANs, network contacts. So it'll work the same way as the others do. So that's all about pulling data into NetBox, but NetBox already has some ways to push data out of it into other systems, and that's built into even the open source version. And so you've got event rules that automatically perform certain functions in response to an internal event. So this could be executing a script, firing a webhook, generating a notification, and they can be conditional as well. So for instance, here we've got value is true. So say you're in NetBox, you go to a device, you mark that device as active, it's going to fire an event rule that's then going to, let's say, have a webhook or script or whatnot that goes to your monitoring system that says, hey, new device, add this device. So a lot of people use the event rules and webhooks for things like that. So the webhooks, we transmit those out to remote systems and, response to internal events, and then those systems can act on those. There's Jinja 2 template support, so you can get very creative in the payload that you're sending in those webhooks. And again, you can send context data like event, model, timestamp, username, etc. So example of a webhook is trigger a Slack message anytime an IP address is created. So we could set it to where if the IP address is created, we're going to do an HTTP post request. We're going to send it to that Slack URL. The format's application JSON, and then you can see the body template there. So it could be somebody goes in, adds an IP, it's automatically going to send a message to Slack notifying, hey, this user created this IP. Just an example. So I'm going to run through a demo here, and I'll talk through it. I may need to pause it at some places if I need to slow it down or whatnot. But we're going to demo the integrations as well as the event rules and the webhooks. Let me just kick this off. Yeah, it's playing. So the first thing we're going to do is we're going to create secure credentials, and this is to securely connect to NetBox from the agents. So we'll just add our credential here. We're going to give it a name, Catalyst Center integration, and it's going to create us a client ID and secret. We're just going to copy those off, save those, because we're going to need them for the configuration file. So we can see the Catalyst Center integration. This is our endpoint, so this would be your NetBox endpoint that you're also going to need to put in the configuration file. So this is a discovery integration file. You can see the target there would be your NetBox endpoint. We've got the client ID and secret that we just copied off, and then down here you're going to see your schedule where we can schedule it, the URL host for your Catalyst Center, username and password for Catalyst Center, and you can see here the scope that we're going to discover. And here we see Bootstrap is true. We run it one time with Bootstrap true because we need to pull the custom objects in for Catalyst Center. So we have to have those objects to map what we're finding in Catalyst Center. And here's just an environment file with all the client ID and secret as far as the Catalyst Center information. You can secure this with something like HashiCorp Vault, just using a .env file here. So what we'll do is we'll kick it off. And again, the first time it runs, we've got the Bootstrap true. So this means all we're doing right now is trying to ingest those custom fields for future use. So we see it executed successfully. And now we're going to go into assurance. We'll see those deviations. We see the custom fields here. There's 6 of them. and we'll just apply those. And once we apply those, then we're ready. NetBox now has the custom fields for the mappings, and then we can use the future runs of it can just run as bootstrap false. So if we go and look at these, we now have 0. We've applied all those, and we'll go to the customization here, and there's our custom fields. So now we've got what we need to do the mappings for the Catalyst Center integration. So after that, now we can come back and we can do bootstrap false. We can now run it as a schedule, do it every hour, and we'll actually set the site to building 7. You could set this to mini sites, just listing it out, or you could do a star and discover everything. So from this point on, this is set. This is all we have to do. Leave it as it is, and it'll run every hour. So what we'll do here is just kick it off, and again, you can run this as often as you want, minute, hour, day, doesn't matter. So the next time it's going to run, it's going to get a lot more data. I'm going to speed it up here, and we'll see it executed successfully. And so now when we go back into NetBox, we're going to go into assurance, and it's going to be lit up here with all the information, IP, devices, MAC addresses, sites, virtual chassis, and so we can actually explore this. So we're going to go into one of those devices that it found, and we'll actually drill down. You can see all the information that was found for this device, and then this is the NetBox information that it's going to be updated with. So you can actually see what's going to happen in NetBox when you apply these. So we'll apply all these. So now we basically built those devices in NetBox. Deviations are gone, and we'll go and we're gonna observe some of what came in. So we're going to take a look at the San Francisco site. This San Francisco site is actually a Meraki site. So the same exact thing has been done for Meraki. It works the same way. The integration has been ran from Meraki as well. So down here we'll see what Meraki networks we're dealing with. We can see that it synced over tags for Meraki. And then we'll go up here on the right. All these related objects, we see all the devices, the prefix, the VLAN groups, wireless LANs, and it gives you the numbers of how many are in that site. So again, we discovered that site, and it brought everything in for us. So we'll just, we'll go into these devices, we'll go into this first campus switch here, and we'll kind of observe what it built. So we can see it built the entire switch. We see the platform, we've got the IP of the switch, the status. Down here we've got device type, serial number. So we got all that information from the controller, and got the Meraki serial number and also the Meraki stack ID. So if you have a stack, it'll come in as a virtual chassis. We can then look at the interfaces on that device. We can see real-time information for those interfaces. We've got that it's disabled. We've got the speed, description, and then IP address that's assigned to that. So now we'll go back into the site, and we can look at VLANs that were brought over. So there should be 2 VLANs in the San Francisco site. Yep. And they're going to be just an infrastructure and associates VLAN. So again, just synced over from the integration there. And we also have wireless LAN data that came in. So if we filter here by the San Francisco site, we're going to see our SSIDs. We're going to see the status, and then, of course, the authentication type. So again, instead of single devices, you can point to the controller and get everything. So let's send some information back. So here we're going to do an event rule. We have Meraki switch port updated. So what this is we're going to update a switch port in Meraki, and that's going to fire a webhook, and it's going to go the other way to update Meraki. So let's look at the webhook here. So put request. This is the Meraki dashboard endpoint. We can see we're sending the name, the status, the type, and the VLAN, and that's what's going to be sent in the webhook payload to Meraki. So again, just showing this is native to NetBox, how you can get information out. So we're going to go to the device here. We're going to go branch office device. It's going to be this first one, switch 1. And what we're going to do is we're going to take an interface and we're going to make some changes to it. I believe it's port 2. Before we do that, let's go to Meraki and look at this device to see what it's currently configured as. So we'll look at the switch port. So it's a switch port 2 here, type trunk, native 1 VLAN. So that's what it currently is. And then we'll go back over to NetBox. Go into port 2. And we'll just we'll edit. Oh, and we have the Meraki port ID and Meraki serial number, so that can also be sent in the payload of the webhook as well, since we have that. And again, that's part of those custom fields that we imported to have. So we'll give it a description of DMZ. And I think we make it an access VLAN here. Let's see, access port. Yeah. And we'll put it in VLAN 100. So we made several changes to this interface. So once we do that, it should fire that webhook. And we can go over here to background task here, and you can see this finished background task. So and you'll be able to see the payload that was in here, all the changes that we made with the access, DMZ, everything was sent over. So if we go back to Meraki, go back into that port, we should see that it is DMZ access VLAN 101. So just a way that you can get that information back the other way. So let's also take a look at this with Catalyst Center. So here we've got a 9300 and we've got gigabit Ethernet 101. So what we're going to do here is we're going to change the description on this port. So we'll just say configure, I think we're going to say configured by Cat Center. Something civil, yeah. So remember, now we're trying to get information back into NetBox. So your discovery agent is running every hour. So the next time it runs, it should pick this change up as a deviation. But we'll go ahead and run it manually to find that deviation. And when you go into assurance, the only thing we should see is that one deviation, because everything should be matching the intended state. So now we just see what has changed. And again, it's whether what's right. Is the network right, or is the source of truth right? So we'll just go with this was an approved change. Yep, we found out Dave meant to do this, so we found out we can drill into the change, what changed, description configured by Cat Center. So we're okay with this change. So what we'll do is we'll just push it through. Now, if you didn't want to push this through, this is where you could stop it and go fix it, right? But we'll just apply it, get our deviations gone, and then we'll hop over to the device, go into that device, and we'll drill down to 101, configured by Cat Center. So this is what the integrations are doing. They're just constantly giving you that operational drift, keeping you from that operational drift, and so you can identify it. So let's go back. So Catalyst interface description updates. Now we're going to fire a webhook. We're going to send something back to Catalyst Center. So we're going to say if the interface is updated, fire this webhook. Now, because of the way that the authentication works in Catalyst Center, you need something in the middle. So you need something that's going to listen for that webhook and post it to Catalyst Center. So you don't have to worry about this too much. I'm just firing up a Flask app here that's going to listen for the webhook. It's just an intermediary. So we'll go back to NetBox, and what we'll do is we'll change that interface back and see that we should see that webhook fire here. So we'll just go in, same interface, and we'll just say configured by NetBox. We can see it fired. This guy got it. He's going to post it to Catalyst Center. We should be able to see that as soon as we go into Catalyst Center. So go to the device here, refresh, and we can see this device down here. So we've got configured by NetBox. So again, this discovery, assurance are going to bring that information in. This is just an option of ways to get things out of NetBox, natively. So what's next? The NetBox Cloud Free Plan. So this is great for labs or small environments if you want to just kick the tires on things. I think you get 100 devices, 500 IPs, 10,000 API calls per month. So that's a very good tool to use if you want to try it out. But again, if you have any questions or want to talk further about this, go into some more detail. I see Sid's back here, Tom's back here. Find any one of us. And again, we've got a booth back here in the world of solutions. So I really appreciate everybody's time. I hope this was helpful, informative. And again, like I said, we've got more integrations other than just the Catalyst Center and Meraki. So if you'd like to talk to us about some of the other integrations that we have, we're happy to discuss those. They all work the same way. So once you have it configured, you know how to configure one. You know how to configure most all of them. So I appreciate everybody's time. I know it's late. Hope you have a blessed night. I know you have a lot going on tonight. So have fun. Thank you.